Kia ora koutou. My name is Michael Orewiri Thorson, and I am running the tech behind the stream that you are now viewing, the AWS Community Day Aotearoa Virtual Edition. As the hosts, the AWS User Group Aotearoa are based in New Zealand, and we would like to share a Māori tradition with you. As Māori, we like to start and end our meetings with karakia or blessings. This is non-denominational, and I will translate as I go. So, let's begin. Ha ki roto. Breathe in. Ha ki waho. Breathe out. Kia tau te mauri e kokiri nei, to settle the nerves within. Ko te rangi Māori e tāku e rapu nei, for it is peace I seek. Tihei mauri ora. Share with me the breath of life. Hey, thanks for sharing that with us. And now, here to kick it all off, is Paul Dunlop.
Good day everyone, and a warm welcome to the very first online virtual Oceanic AWS Community Day, streaming live globally to you on this day, the 10th of August 2025. My name is Paul Dunlop, and it's an honour to open this inaugural community-led event. I and my committee peers have spent several months volunteering our time to pull this all together, and we're very excited to be able to bring today's conference to you. We have an amazing lineup of speakers and topics, and are hoping everything goes off without a hitch, though with 15 live streaming events back to back, things may get a bit tricky for us. If we do strike any issues, please be patient with us as we seek to resolve them quickly. Thanks. I'd like to take a moment to offer our heartfelt thanks to our sponsors, who without them, this event would not have happened. So a big thank you to AWS, our platinum sponsor, Datacom, our gold sponsor, and our silver sponsors Mantle Group, CyberCX, and MongoDB. Your continued support in making the Builder community a reality, allowing us to connect in person and virtually, is much appreciated by everyone. You may or may not know, but the AWS Community Days are entirely organised by the community for the community. All logistics, speaker selection, session curation, and event delivery are driven by the user group leaders and volunteers, so a massive shout out to the speakers for raising their hands to present, and a special thanks to the committee members for their help. Ramaswamy Arunachalam, Githaka Gurugay, Darship Pandia, Chamila Diavis, and Casey Orr. Without your dedication, this event would never have taken flight, so thank you all for your hard work. YouTube, LinkedIn, and Twitch, please feel free to use the chat systems on your chosen platform to view us. During each session, as we have moderators on standby monitoring chats, they will help field your questions and pass them through to the speakers. We'll do our best to get your questions to the speakers in a timely manner. However, the speakers may not be able to answer everyone's questions, so your patience is appreciated. With the housekeeping out of the way, we've got a full schedule of powerful technical sessions, including deep dives into DevOps, AI agents and machine learning, cloud from real users who have built real solutions, your peers, providing you with their hands-on insights with their global and local perspectives. We're extremely excited speaker of the day. Mike hails from Brisbane and is an AI enthusiast working at AWS who is keen to share his insights on how we redefine the internet through autonomous AI systems. Ngā mihi nui, thank you everyone. It's you who make a community what it is, so please sit back and enjoy this, the first Oceanic Virtual AWS Community Day.
Hello, Kia ora. Thank you so much for inviting me here today to present at this amazing community day. My name's Mike Chambers, and I'm coming to you live from Meanjin on the east coast of Australia, the land of the Yagara and the Turrbal people. Let me tell you who I am. I'm going to press all of my buttons, and thank you, Paul, for the introduction. Let's hope that we all go off without any technical hitches today. My name's Mike Chambers, and I am a developer advocate for Amazon Web Services. So yes, I do work for AWS, but I do really think of myself as part of the community first. So I've worked for AWS for about 3 years now, very, very nearly 3 years. It's almost my anniversary, yay. But I've been part of the community around AWS in this part of the world for well over a decade. So I consider myself to be community first. So I tried to think about the kinds of things that I wanted to talk about with you here today. And so I'm going to try and blend these things together. I'd like to talk to you about the things that I've been working on in my day job that are making me particularly excited for technology at the moment, and the kinds of things that I want to share with you. Over the last couple of years, I've had the opportunity to do many things. And so I decided if I was going to try to sort of summarize it up into one slide, well, this one looked pretty decent. So I grabbed all of the images from the last couple of years from LinkedIn, and it's told me a couple of things. One, I need to post more things to LinkedIn because I think I should connect more. So connect with me and I will connect back on LinkedIn. I drink lots of tea. There's lots of images of me drinking tea in there, I've noticed. I've met some amazing people. I've traveled all over the place. If you have been watching any of the kinds of stuff that I've built, then you'll know that I'm pretty much focused. In fact, I'm solely focused on generative AI. But don't tune out. I understand that lots of people are talking about generative AI. But I'm not here to talk about large language models and all that kind of stuff. I want to talk about sort of looking into the future of what the future of our industry, AWS, and also just the kinds of things that we make. And so that's what I wanted to come here today and talk about. So if you give me a couple of minutes, I want to talk about this topic of the agentic web. And this is something that I've put together about a set of technologies that I'm super proud that I've been working on inside of AWS, and I just want to bring these to you. So I'm going to present the agentic web. And I'm going to start off with a quote from my boss. And so this is a data point which I'd like to talk about here. Generative AI is going to reinvent virtually every customer experience we know. Now, okay, you could say, well, Andy, yeah, okay, you would say that, wouldn't you? It's in your interest to talk about how generative AI and the technology is going to advance because you're part of AWS anyway. But you should know we are a very, very data-centric company, and we don't say these kinds of things because it's in our own self-interest. We say it because we really believe it to be true. And I believe it to be true as well. And so let me explain my theories on this. Let me show you a couple of slides that I've put together. So let's start, well, I've got to say it's kind of like a history lesson. We'll go back in time just a little bit here. That there are websites. Okay, there still are websites. You're using a website right now just to watch this. But people use web browsers to connect to websites. Okay, so this is the beginning of the internet, essentially. This is how things work. And so companies and service providers and community groups and whoever make websites to disseminate information, products, and services. I know that I'm not telling you anything you don't already know here, but this is how the internet's worked for a very, very long time. Let's move us on, and you'll see that I'm sort of tracking here a progression of technology. This is then what happened, or it still happens today, of course, is that people use other kinds of devices to connect to APIs. Now, they don't know that they're connecting to APIs. They don't need to know that. But through a mobile app, you might connect through an API, but to the same information, products, and services that were available and still are available through those websites. right? So this is the way that sort of technology has advanced a little bit over the last, I don't know, decade and a half or whatever. This is what we're quite used to this. We understand this. And so what I now want to do is I want to sort of project forward. You can see there's space on this slide. I want to project forward to the next couple of steps that might come beyond this. And the first of those is a step which is basically happening now. And that's that people are using chatbots to connect to those information, those products and those services. And I'm suggesting here a technology, and that's MCP. So Model Context Protocol. It's an open source protocol from Anthropic that is designed to help agentic workloads connecting with information. And I'm drawing a connection here that where we started off with websites and HTTP, we moved to APIs, and now this MCP layer on top of that, one thing it can do is it can expose APIs to a chatbot world. Let me put it that way. Now, in reality, right now, if this is happening, this is someone using Cursor or someone using Kiro or someone using a software development platform, an IDE, to connect to some services. That's where it's happening a lot. But it can and it could happen with everyday members of society, with consumers connecting to chatbots and connecting to those data sources. And we'll see that happening. I think I'm seeing customers starting to have that conversation right now about, well, we have some data, we'd like to make it available to this brand new world that we're looking at. Is making an MCP server the right way to do that? And I think that's the right conversation to have. I'm not here to say that that's definitely the right thing to do right now, but it's the right conversation to be having, to think about whether that's what you want to do. What I'm now going to suggest is one step beyond that. And for this, because I'm in the way, I need to just get rid of myself. There we go. Let me put another column into this diagram. And this is where we as consumers use agents to connect to other agents. And in the same way that I suggested MCP before, I'm going to suggest a technology here, and that's A2A. And so that's the agent-to-agent protocol, originally developed by Google, now fully open sourced. This is a way for agents to be able to discover and communicate with other agents. And what I'm going to suggest here, what I'm theorizing here, this is my thought on the future, is that we will use personal assistant agents to connect with agents which are out there, which are provided by the information products and service providers of the future. And so when people talk about multi-agents, as they want to do, they talk about these frameworks that are multi-agentic frameworks. When I think of multi-agents, I think of a distributed world of agents where we are connecting over the internet, we're connecting over the network to collaborate and communicate and to do the kinds of things that we would have done and we still do with the websites of, let's say, yesterday. This is what my vision is like for the future. And so what I want to talk about is how can we actually build those agents? How can we get those agents and start experimenting around with them now to build what this is going to be, this future? And so to do that and to sort of set the scene for that, I want to talk about what an agent actually is. Because it's absolutely no doubt that 2025 has been the year of agents. And actually, as I was putting these slides together, that's what I wanted to focus on. But I will just mention here, because models are coming out all the time. Large language models are coming out all the time. And of course, it is the large language model which powers the natural language understanding of agents, which essentially are just relatively simple pieces of code, if we're honest. And it's these large language models that get a lot of the headlines. And we've seen this week brand new models like GPT-5 coming out and people jumping right on it and getting excited and wanting to talk about it. And of course, we're all excited to take a look at these new models and what they're capable of doing. But for me, what I'm really excited about is what we do with those models. And 2025 has really been about what we do with models, and it's about building agents. And so That's my little sidestep away from the slides that I had to talk about. That's why I'm talking about this, because I really think that agents are the thing that we should be focused on. So an agent, it's a relatively simple piece of code that we connect into a large language model to give it its natural language understanding. So a large language model is important to this architecture. Other things that are really important are tools. So in order for an agent to have agency and therefore have the name agent, we need to give it access to be able to go and do things in the outside world. And so I'm just simply connecting it to a box called tools here, but you're probably aware of the kinds of things that we can do. So we could connect it into an email server, we could get it to check the weather, we can get the time, we could do a whole bunch of stuff. Basically anything that you can write in code, you can make a tool out of, and you can connect that to an agent. And now we have this intelligent capability which is able to reach out into the outside world through these tools. And so when we send our query in, the agent is able to use the large language model natural language understanding to figure out what it's being asked to do, and also that understanding to be able to call tools. And there's one more really important part of this architecture to talk about, and that's the loop. So we need to have the ability for the agent to perform what we call the agentic loop. So it can go and call a tool, get the response back, send that to the large language model, figure out, is that everything that we needed? Actually, no, I need to go and get something else. And without us querying any further, it can go off and use another tool and go and bring some other information back. And it can work through and figure out what's necessary before ultimately sending a response back to us. And so this really is what an agent is under the hood. This ability for this autonomous system to be able to use tools and the iterative flow with the natural language understanding to work on a query on our behalf. Now, something has happened pretty much over the last, I'll say, year. Something has happened. So it used to be that these agentic frameworks that we would use, basically the software frameworks to build agents, it used to be that we had to have a lot of information inside of the prompting and the templates of those agents to help a large language model understand, if I can use that language, how to use those tools and how to interact with the world, and gives it examples of what to do. But over the last year, and certainly this year, we've seen newer models, I'm going to say larger models, but more capable models that are launched specifically for the purpose of working in these agentic frameworks or in these agentic flows. So they already understand and have been fine-tuned and initially trained on how to use tools, on how to reason, and how to map through a plan, actions to take to work in an agentic flow. And this is a really important step for us because it puts all of that agentic capability in terms of its thinking inside of the large language model so that we get much more efficient in terms of our token usage and in terms of the way that we can build our agents. And it also means that the frameworks that we use can become much simpler. Okay, I want to throw this up on screen now. Hopefully you're aware of Amazon Q. So Amazon Q and Amazon Q CLI and now the Kiro IDE, they're all ways that we can use generative AI to help us do technical tasks, whether it be development or with Amazon Q CLI, where we're actually working on the command line of our own machine to be able to do whatever it is that we're doing there. And so Amazon Q, you can use it to, in this particular case, I'm going to do a demonstration here of querying how many S3 buckets that I have. And like I said, I've been working for AWS for a while. So when this comes up with a very large number, just forgive me for a second. The point here is that I'm using natural language to interact with the system. And you could use this to do many different things, not just AWS things. You could do it, ask it to interrogate your computer or do something with a Git repository or whatever it is you can't remember how to do yourself, but you can get the tool to help you do it. Now, I'm not bringing this up on screen because I want to dive deep now into QCLI. What I wanted to point out here is that this is an agent. Okay, so this has all of those components that we talked about on the other slide, where we had the code which sits in the middle. It connects into a large language model. In this case, it's Claude Sonnet model, and it connects to some tools. And in this case, those tools are to help you to do various things on your own machine, so on my machine in this case. So all of those pieces are in there. And so I have, and product teams and service teams that I work very closely with have a lot of experience with building these kinds of systems. And I'm going to ask a question here, and I'm fully aware. I can see you all, by the way. I can see you. Sorry if that is news to you. So I can see if you raise your hands. And so I want to ask this question. How long did it take the service team and the team that built Amazon Q Developer, how long did it take them to build and ship that product? And I can see that some of you are confused about, I haven't said which is which and I haven't got A, B, and C. Okay, so hands up if you think it's 3 weeks. Okay, I see some of you are doubting this, but hands up if you think it's 3 weeks. Okay, yes. As you probably guessed by now, because I wouldn't put the slide up any otherwise, yes, it actually took the service team 3 weeks to ship or to build and ship Amazon Q Developer CLI. And I think that's amazing. And there are a couple of reasons why this is the case. And it maps, first of all, back to what I was talking about before, that the models are now powerful enough to understand how to do all of this agentic work without us having to put lots of effort in at the templating layer of the agent framework itself. So we can put the power of the agentic loop basically in the hands of an LLM, and we can get out of the way of these frontier models which have been trained. And so they worked on a framework essentially to put this together and realized that they built something pretty cool. And then we worked to get this into your hands. And so we're able to launch agentic products in weeks by using Strands agents. And hopefully you've heard of Strands agents by now. If you haven't, then do me a favor and take a look at this. We launched it as version 1.0 just a couple of weeks ago, but it's been out there in a sort of preview version, if you like, for a little while. And this is a framework that we can all use to build agents really quickly, because it is a framework that puts the model first, and it allows the model to make those critical decisions essentially about how to operate the agent. You can still go in there, you can still put your system prompt in there, but there's far less prompting and few-shot learning and all that kind of stuff that you need to do with these newer models. And this framework concentrates on building agents that work in that way. Now, I'm not going to go into a huge amount of code during this session because it's first off in your day. You don't need me to be going too deep into this stuff. So I just wanted to show you at a high level how this stuff works. And so it is a Python framework for the moment. And so, yes, you can pip install it, of course. So pip install Strands agents. And so that installs your framework, your base framework. Now, if you remember before, we talked about tool usage and how we want our agents to be able to connect in with tools. And so to get some tools straight away without having to make them yourself, which of course you can, but to get started quickly, you can also install Strands Agents tools, which is an independent package of a bunch of tools which you can immediately start building into your agentic framework. Now, I won't use those in this particular next example. What I want to show you is how quick and easy it is to build an agent. And I know it sounds like a marketing thing, but this is genuinely great. I use this all the time. And this is basically all you need to create an agent, one of that agentic loop that we talked about before. So I can import agent from Strands, I can grab myself an agent, and I can invoke it. Admittedly, this won't do very much. This will be basically a super simple chatbot at this point. You notice we've got no tools created or anything like that. But you could do this, and this would make a functioning, super simple agent. Let's expand it out a little bit and see where else we can put some configuration. So we can put a system prompt in there and give it a name, do that kind of thing. The system prompt means that we get to give it a purpose and a personality so that it knows what its job is in life. But we still need to add some tools in. And so I'm going to do that too. So we can import tool as a decorator from the Strands library. And then all we need to do is create a tool. As in this case, I've got this Python function of my tool. Obviously, I reduced it and gotten rid of the execution code for the moment just because of the slide. But I'm decorating my tool function. I'm able then to pass that into the agent as a list of all the tools I've got. And this genuinely is a fully functioning agent. This is really all we need to do. And if you have a simple use case for an agent, this is it. Add some more tools in, maybe add some more prompts in, but this is all you need in order to be able to launch an agent. And so this is how the QCLI team was able to go from the idea to be able to ship and build and ship QCLI so quickly. This framework design. And so now it's in our hands too, and I do genuinely use this nearly every day to build various agents for myself anyway. And so the question that I get when I talk about Strands agents, and it's a very valid question, is yes, but that's running on my machine. The last time I looked, the W in AWS was web. So how do we actually get this to launch this at scale? How could we actually get an agent running in a production environment or cloud environment? Because that seems to make sense. And it's a very valid question. These essentially are the components that we need in order to be able to do just that. So we need to have memory. Memory is actually really important to an agent. So it needs to be able to remember the conversation that it's been having and what it's talked about in the recent past, with an option to also be able to remember what it's talked about in previous conversations as well. We talked about tools. We need to think about gateways. How do we actually interface between, say, a mobile app or a website and this agent that's running somewhere? Identity is a big one, and we don't have enough time to get into the full stretch of this conversation, but think about for a moment if I've got a person coming in and using an agent, and then that person then connects into, or that agent on behalf of that user uses a tool to connect in with data sources. We need to be able to figure out how to successfully and properly propagate that identity through so that we only get access to the information we should have access to. A runtime environment. We need to run the agent somewhere. We'll talk about that in a second. And finally, observability. So security and observability, hugely important to basically any workload. But observability is a little bit challenging when it comes to things like generative technologies, because they are non-deterministic sometimes, and they can do things that we don't expect sometimes. And so being able to watch that and get the metrics and understand the traces of various calls are an important job for us to do. So what I am now excited that we are talking about, and you may have seen this launch a couple of weeks ago, is Amazon Bedrock Agent Core. So Agent Core is a set of capabilities that allow us to do all of those things that we just looked at cloud scale, so that we can deploy our agents at cloud scale. And we can use Strands agents, but you can also use any framework that you might have been working on. So this is a super high level diagram of what Agent Core looks like. And I drew this up sort of to map into basically the way that the diagram looks at if you go into the console. But the thing I want to focus on here, I think, is a box at the top. We have this agent box here. So this is an agent that you have built. So imagine for a moment that this is the agent that we built with Strands agents. Yes, but it also could be an agent you built with any other framework. So it could be LangChain, it could be LangGraph, Crew AI, Llama Index. Actually, it could be a framework that you've just completely made up yourself, or a framework that I've never heard of. As long as it runs inside a container, you can use that with Amazon Bedrock Agent Core. So it's not locking you into any particular kind of agentic framework or into any particular model or anything like that. And so we can use this with the core components that we've got here. So let's just take a really quick look. I can take an agent that I've built with any particular code and put it inside of the Agent Core runtime. And why is this really exciting? Well, we don't talk enough about this. You here are at the birth of another kind of compute environment. So yes, we have EC2, yes, we have Lambda, yes, we have containers and ECS and that kind of thing. But we now have Amazon Bedrock Agent Core. Take a look at it. This is actually a lot like Lambda, but it's got some things that maybe we always wanted. So you can run this for up to 8 hours. And once you've invoked it, you can come back and invoke it again. This is actually a new kind of, essentially like a micro VM. We've never talked about this before. This is a new kind of compute environment. Definitely jump in and take a look. What else? So we can take various components here from Amazon Bedrock Agent Core and include them. If runtime is all we need, just use that. But if you also want to use the built-in memory, you can use that if you want to. I want to add in some tools. We can do that too if we want to. The point here is that each of these different capabilities are independent, and we can use just one of them or many of them, whatever we like. You could just use memory. You could just use runtime. You could just use identity. So that is Agent Core. And I just want to show you quickly here how you can get up and running with this. So it is an SDK is available for this called Bedrock Agent Core. We also have the Bedrock Agent Core Starter Toolkit. If we look at agentic code like we were looking at before, notice this isn't strands, it's just a theoretical framework. We can take this, and in order to get this into our runtime environment, we don't have to change our agent code at all. All we need to do is bring in the Agent Core SDK, create ourselves an app object, and then decorate our invocation. So if all we want is runtime, we don't have to change our code. It could be, as I said, strands or crew or anything else in between, and you can go and ship it into that runtime environment. To do it, you can use the Starter Toolkit. You can configure how the environment is configured. Of course, you can add in multiple configuration options there. You can launch it locally, and then finally, you can also launch it into the cloud. And this gets you up and running with the Starter Kit pretty quickly and gets you a runtime environment running up inside of your AWS account. Now, this is in preview right now, and I'm not going to sugarcoat this. There are a couple of rough edges in here, and I'm working on this as well as the service team to be able to polish these off, and would really, really like your inputs to come and help us to shape Agent Core to be what you need to be able to go and ship agentic workloads up into production and up in front of the people you're making solutions for. So that's the agentic web, and that's what I wanted to talk about here. I wanted to sort of hopefully paint a picture of what I'm excited about. And talking about painting pictures, I did. This is an image that I created. I will just reiterate what it says in the bottom corner here. This is a concept artwork, if you want to call it that. It's something that I put together. I want to suggest what the future might look like. You remember that diagram from the beginning where we had the agent to agent interaction as a personal assistant? But what if it looks like this? What if you've got an agent in your pocket and you're able to connect to other agents, say through an agent store, and this is how we connect with information, products and services in the future. I'm interested in doing more than just a developer use case for agentic use cases. I want to see this put into the hands of everyday people, my family. I want to help other people to be able to get access to this kind of technology. And so with everything that we've looked at here, I think now is the time to at the very least experiment with building the agentic web. If you're interested in playing around with some of these things that I've shown, Strands Agents, it's strandsagents.com. It's super simple to get to. There's a lot of great example code up on strandsagents.com, so take a look at that. And also Agent Core. Like I said, it's in preview. I'm giving you a QR code here straight into the samples. If you Google Agent Core, then you'll find the product page and you can read all about it. But this will take you straight into those sample code so that you can see how all of those different aspects, and there's lots of them, work with Agent Core. So that's what I've been working on. That's what I'm really excited about. That's what I wanted to share with you. Thank you so much for your time at the beginning of what I'm sure is going to be an amazing day. I'm going to be sticking around and watching more of the sessions today. Thank you, and have a fantastic rest of your day.
Yeah, hi everyone. I hope we are all set. You can hear me, you can see me. Yeah, thanks for the invite and for having me. I'm speaking to you from Germany and it's in 25 minutes at the midnight, but it's my passion, so I'm even in the office to have a better bandwidth. So now, yeah, the topic of my talk is event-driven architecture patterns in highly scalable image storage solution. And my name is Vadim, and serverless is one of my passion. So glad to share the stuff that we are doing in the company called IP Labs. But I'm not the only one who produced this talk. So my amazing colleague Firdavs also contributed a lot to this. And yeah, just to give you the context, I'm working for the company called IP Labs, and what we are doing, we are designing the product to purchase kind of photo products, photo book of the year, calendars, and so on. So the images or photos are at the core of our present of our business, and we need to deal with that kind of very efficiently. So that's the agenda. I will talk very briefly about the motivation why we do this, because the company, why we re-implemented this in the serverless way, because the company exists since 20 years. So we had previous solution. I will show you workflows and architectures, especially focusing on the event-driven patterns there. And there will be brief challenges and lessons learned on what to watch just to do that efficiently. So what is the motivation behind it? Once again, we had the monolithic solution back then, 20 years, and then starting from 2017, we migrated this to the cloud for certain reasons, scalability, just to roll out that globally. We have had still some monolithic parts, containers, and all that stuff. So that was kind of the evolution. We added a lot of elasticity just to benefit from the cloud, refactored many things to scale independently, but basically we faced the situation that our main application contains self-written e-commerce system. Yeah, because 20 years ago there were no Shopify's, Magentos, and all that stuff. So we have written this and we tied it together with our main logic. So we had this shop front end, shop back end, user management, and the things in the e-commerce basically put together. Yeah, we had APIs so that the partners could connect to their own shopping carts and so on. But it also had kind of maintenance cost or integration cost because we didn't support natively uh, solutions. And then the business expressed the need that we need to support Magento or Adobe Commerce now or Shopify natively. And yeah, we had that situation that architecture prevented us from doing this because it was once again part of the solution, but basically the image workflows, they were generic. So it was the point for us. We looked just how we can do that. Can we decouple what we can do? And then we decided we are now in the cloud. Let's re-architect this biggest, maybe one of the most important parts with all these builders and editors and workflows, uh, and just do it in the serverless way. Why? Because we started to experiment with serverless back 2018, one and a half years after starting the cloud migration. We probably were the pioneers in Europe with that, and we started with small internal projects and then we scaled it to the public facing products, and we saw a lot of benefit. Yeah, it just increased the speed of delivery. We could focus more on core capabilities and all that stuff. So basically serverless became kind of the culture, how we do new things basically. And we learn together and we shared. So lots of my colleagues visited the conferences and shared some pieces of how they did the stuff. So basically we became more and more proficient, but anyway, this was very crucial. The image solution is very crucial part. So of course we knew that it will be quite challenging to do, but anyway we decided just to do it that way. If I will be talking about image storage solution, this is the same. We call it internally consumer file storage or abbreviation CFS. It's all the same. It's about images. And this is kind of the extract of our architecture. And you see lots of Lambda functions, lots of other stuff. But basically, we have lots of different modules: file API, project API, ordering, config. I will briefly talk about them. Then I will be talking about the patterns. So we have well-defined APIs behind all this stuff. Yeah, and if we are talking about event-driven architectures, that will be about a simple queue service, simple notification service, event bridge, Kinesis data, DynamoDB. So all these services are kind of associated with event-driven architecture or asynchronous communication. And if you look into this diagram once again, you will see queues, you will see SNS, you will see event bridges, and you have here DynamoDB streams, and we have here scheduled events. So we have nearly everything. We have even Kinesis and some certain other parts, but not just for the sake of testing all these services, but they have different purposes, and we try to use the right tool for the job. So you may say, yeah, what's so difficult? You just do something with the images. But we have lots of different workflows. We have normal upload, just you simply upload your pictures, but we have also mobile upload. You simply can generate the QR code and send it to somebody else to upload the images into your storage. For example, you had vacation with friends and you shoot the images and you would like to just collect them with pictures of you, and you can just simply spread these QR codes to everybody who might have these images. Of course, if you design something like photo book, it takes sometimes weeks, something like photo book of the year, and you would like to save and load it. And sometimes you would like to share these saved projects, for example, with your parents, that they also can buy it, but even a bit change it. And of course, if you design the product and you put it into your basket, and it might be internal basket in case we have some integrations with the partner, it might be even external basket, because our partners don't only sell images through our system, they may sell flowers, furniture, and put everything via kind of in the shared basket. And we need also to deal with purchased items, and we need also to take care of all workflows like yeah, automated deletion of images with notification, even manual deletion, and the users say, I just don't want this save project to be there. So lots of different workflows, and that's why just there is a kind of complexity. So let's start with some patterns. And of course, SQS is simple queue services everywhere. And if you will look for the first use case of SQS, you will find the examples of creating the thumbnail. And the same is true for us. We create a lot of thumbnails because if you upload the image and then you would like to load it through the saved project or whatever, we don't want to load the originals. So if you upload them, we generate in the batches asynchronously these thumbnails. And we even might generate, the size might depend on the device. Are you on the mobile device, on the desktop? So we can detect this, and then we might even generate different sizes of thumbnails. So there is kind of a logic there, and you see we have kind of upload, the post upload lambda function, and the which then reads from this queue in batches and generates all that stuff. We'll test the performance so we know what is the throughput. Sometimes people upload and would like to see it, so that the delay is not very desirable, but we've fine-tuned that. Also, there are SQS, we have kind of this SQS queue with a very difficult name, file usage handling. And the reason is that we could decide, for example, one image can be present in different projects. You can upload it, then the image, and then design multiple photo books with the same image, and or even d- just do different stuff. And we decided not to copy the image, but to share the image if it's used in several projects. But it introduces then the challenge: if the product, save product, is, for example, deleted, can we delete all the images? And the question is, yeah, that is that we need to answer. And this queue handles that use case. If something is deleted, we check if there are references to all the images, and if no, we can mark them for deletion. If yes, then we know that we should keep the image, but maybe the reference that for only the products, for the products that it's not in use anymore. And the deletion is done also asynchronously. That's another story. So we simply mark the file in the DynamoDB just not in use, the picture, the image, and then there will be workflows. We'll be looking into that just to go through that and clean everything up. So lots of different use cases for SQS where it simply makes sense to do asynchronously, just that nobody is waiting. We even use FIFO not alone. You see here with that we are using in conjunction with other synchronous services, with Event Bridge, and then also with Lambda. So what's the use case and why FIFO? So sometimes we need to have some kind of workflow based on event. For example, user login or user logout. And of course, it's important to do it in the right order. Yeah, you don't want to do something work with the event logout before the login. And one of the use cases is, for example, people uploaded the photos, didn't store this in some kind of. There are mobile uploads only with a um, session duration because people don't want to pay for the storage or something like this. But in case you don't use these images and you log out yourself, then we need to clean those things up. The same is also for the cart items. You place something to the basket, you can save it, but if you don't save it and you do log out, we need to clean this up as well. And that's why we have this FIFO queue, which then handles these use cases. We do some other logic for the login, but it's important to have also here the ordering. FIFO queues offer a bit less throughput than a standard queue, but for our use case, it works very well. And yeah, we have here FIFO queue, and we have here different event bridge in between, and we have kind of two targets, two Lambda functions, which looks through the files on the project level, like if you save something or cart item for the ordering, or on the file level itself, like mobile upload. So we have two different targets serving to different places. And yeah, you can use here SNS because SNS also supports two Lambda function as a target. For us, it was more convenient to use something more event driven, but for this use case, both works, and SNS is sometimes even cheaper. So the third use case, we call it log pattern with DynamoDB streams and Lambda. So what's the use case here? We have requirements here, legal requirements. For example, there is a configuration file, how long the customers can have this saved projects. Uh, please, once again. Uh, yeah, is it now correctly? Yeah. Okay, maybe that's lost. So thank you. Yeah, so this log pattern with DynamoDB streams, we have here some legal requirements. So for example, there is a configuration, once again, how long the customers will store the safe project, like 30 days or 60 days. And there is back office there, somebody can change it. For example, if somebody, so our customers, uh, may go and change it to 1 day or 0, and then everything will be lost. So for us, it's very important just that we capture all these sensible changes. And so we can figure out what went wrong in case it went wrong. So for that, that's one use case. If we store and we store it in DynamoDB, there will be this DynamoDB streams event. We have some filters that we only filter the changes that are relevant for us, and then we store it in the single change log table. This is the one use case. The second one is sometimes we have the situation that the save project cannot be loaded anymore. For example, there have been changes on the product, like the options are not there and we cannot handle it properly, and the customer simply complaining, say, I just spent weeks and now I cannot load it. So we have customer support team to look into this, but what they can do is just to take this project and assign to their support users to investigate. Otherwise, they cannot see what's exactly happening. But this is GDPR requirement. That's very important. We are dealing with images of other people, so we need to have a log there. Yeah. So in case there will be the user owner change, then we also do the same stuff. We intercept that stuff and store this into the um, basically this change log table. In case somebody will complain, we can go and see, okay, this person took this to fix, and then he fixed that or she fixed that, and then change the owner to the previous owner. So very powerful pattern here, completely asynchronously. Nobody is just noticing something, and yeah, this is the power of this architectures. Of course, we have a lot of scheduled jobs. Yeah, like save projects after 30 days that needs to be expired. Yeah, and we have, of course, notification prior or even several notifications. So if you don't touch the project or you don't uh, buy this project, like say photo book, we will delete it because it's the storage also, and it costs money. And of course we have the scheduled events which go sometimes only one time per night, and just looking for the different levels. Yeah, we have two levels as always, like project level and the files between them, but we have also normal files like mobile uploads, and we need to clean things up. And you see the same stuff. There is event bridge in between, which triggers different lambda functions, which calculates that's on the different level. This is the same way how it works if we need to invoice our customers. Yeah, we are in the business to business. We have customers that have different configurations, and then the first day of the month you need just to see, okay, what purchases did we have, and what are the pricing conditions, what are the, yeah, yeah, it works for revenue share, but we have sometimes it just we invoice the storage. So the same stuff. This is kind of scheduled event which goes and trigger this calculation for all customers, pulling their contractual stuff, and then calculating that and putting that into the invoice. And yeah, invoice will be then delivered via email, or for that we have SNS topic, just to send emails with that. Yeah, we have. I only presented you the storage part, but of course we have more. It's ordering part, the shopping part, the product overview pages. These are not part of the system. This is the part of the monolithic system still, and we have even multi-tenancy there. So this monolithic system, we sometimes decouple it for different customers, so that they don't use even the common load balancer, so no storage is used. And with that, we have kind of copies of the system. And then we have central things like sending emails, which is not the part of the storage solution, but the central system is capable of sending different emails, not only about the storage, but also about ordering or user registration. So this is a part of the different system. And we need just to notify the right monolithic central system, which is dealing exactly with the type of customers. And for that, we have this fan out pattern. So this expiration notifications first go through SNS, which has a filter, target filter, and we have SQS queues listening to these topics only for their customers. And through this filtering, yeah, the SNS topic delivers this to the right SQS queue exactly for that type of customer. And then we have the logic which then generates email and sends it over. So once again, this is fan out pattern, one of the most popular, and we also make use for this for our, I would say, our requirements, how we build that system. Yeah, we have also one more. This is one-time thing. We had the old solution. We need to put the new one, and with that, we had the existing projects, and we needed to migrate them to this newer serverless architecture. And there are two modes: batch mode, where we simply just, yeah, for each customer we started on certain day, and it goes through all the old structure and puts it to the new one. And we have on demand, because this batch mode, it might take even hours or days to migrate everything for one customer, which can have thousands of clients kind of. And on demand stuff works like if somebody logs in, we see, okay, somebody is logged in, he might access the projects, and during the migration they will not be accessible. So we kind of say, okay, for you we will now start the migration in parallel, because you probably would like to need them. And the solution is here also we batch the project. So we add project metadata. It's a huge file. That's why we stored it on S3. Yeah, we take the customers or pull many customers together and pull the metadata of all their projects. We stored it in S3 because SQS, for example, had the limit of 256 kilobytes, which now has been increased last week to 1 megabyte, but it wasn't enough that time, so we decided to put it on S3. Then on create, event will be sent to SQS queue, and then we have Lambda function listening to those events, and then they read these files and then migrate the project where this metadata put in. We have here certain quotas, but this is very, very powerful. And if we have retries in case something didn't work, we send notification to the development team and say these are the project IDs, save project that could not be migrated. Please look into this. Is something correct? Maybe this outdated products there that we don't support and all that stuff. So I hope you see my sharing and go any further. So that have been 5 or 6 patterns. And yeah, I think that that doesn't work. Do you see me scrolling now, for example? Okay, so okay, so architect, the things that we learn, architect with serverless quotas and technical concepts in mind. So you need to understand serverless quotas are constraints, constraints, and each service has constraints. I hope you see another slide with serverless quota now, because yeah, and all there is AWS service which is called quotas. Yeah, and you can go there, pull the service that you need. For example, in this case, I'm searching for the quotas of AWS Lambda, and you can see all those quotas. For example, you see the main column is here just stability. I hope you see that slide. And if it's not adjustable, then you need to pay attention to this quote. Otherwise, you can provide the use case and even it's automatically working to adjust it on the account region level. For example, here's the concurrent executions quote, and you can see the graph even what values did you have in the CloudWatch that helps you to decide would you like to increase it or not. And if yes, you have here request increase button, and then you can make the request, and then you see here the whole history of request. This is one of our accounts, so you can increase it even by 10 100x if you can describe the use case. So this is basically, don't have too much time to go just to show you all these quotas, for example, for Lambda. But one of the reasons why asynchronous patterns are so popular is that you have limits and you cannot scale with synchronous communication forever because the concurrency limit of Lambda will not allow you to do that. That's why transforming to asynchronous architectures help, because standard queue supports nearly unlimited number of transactions per second. It's really powerful. Hundreds of thousands transactions are working for SQS queue. That's why this works, but it adds the beauty of polling from the queue, the beauty and the complexity of just standard queues. Yeah, you need to poll that, and this polling is controlled by AWS that scales, the poller queue scales with starting with 5 functions, and it adds up to 300 functions and so on. So this all these limits that you need to know, but yeah, it adds the complexity. You can control that with the memory or the batching behavior. So there are certain ways to deal with. I give the talk about serverless operations where I touch it, but basically you need to understand technical concepts. For example, talking bucket algorithm for API gateway, how synchronous pattern work, how retries work, and understand individual service specific terms like concurrency, transaction per second, throttling, burst limit, event source mapping, all that stuff. And you need to know, understand, and observe these service quotas, because once again, last week, the maximal message size of SQS queue has been increased 4 times. Yeah, and it kind of gives you the possibility to architect your system differently, and you can see that. And it's very important to know that those limits are per account and per region. So use different AWS accounts for development and testing for different microservices, especially if they belong to different teams, so they don't consume too much of these quotas. And of course, use AWS organizations that you can observe that stuff. So general architectural decisions, only 2 points. You need to understand, I hope you see me scrolling, when to use SQS, SNS, Kinesis in event bridge. They are totally different. Yeah, SQS is for polling, SNS is for push, and event bridge is for push. And especially SNS and event bridge have things in common, like you can connect certain Lambda functions to them. But of course, there are different stuff like archiving, replace, for example, SMS or emails are only supported by SNS. There are different latencies involved there, and there are different pricings. So you need to understand what is the use case. Sometimes it's clear what to use. Sometimes you have the choice, and you need to understand why you choose that. So I showed you the example that was several Lambda functions. You can use both SNS and Event Bridge. Another thing that you need to understand is, for example, database choice. We use DynamoDB, but it has certain reasons. We even started with Aurora V2, serverless V2, but we hit the limit, these quotas, and we could not do that. You can use RDS, but with serverless architectures, there are certain limits. And now we have a new service, Aurora the SQL, which has also certain trade-offs, and it supports only Postgres, but it adds something into the mix where we can use relational database, which is completely serverless and doesn't have this cold starts. It just works immediately, but there are other downsides. Or things that it doesn't support, like sequences and all that stuff. So trade-off, but you need to understand the capabilities. DynamoDB can be tough if you, for example, not so proficient in NoSQL. And the last piece is very challenging observability, and you need it. You need logging, monitoring, tracing, you need alerting, you need professional incident management, which AWS doesn't offer. So you need to look maybe Atlassian Ops, Genie, PagerDuty, all the things, because otherwise, if something goes wrong, you will not find what's the thing. But it might be expensive. All these tools are expensive. The observability in the serverless world, and even in microservices world, is expensive. And you have serverless, it's even, yeah, it's completely then microservice based. So maybe you will start to use sampling. It's up to you just to look into this. But if I look into our build, and observability cost us more than Lambdas and all that services together, and that has a reason. So there is certain complexities, but maybe to wrap that up, what is the benefit? Once again, focusing on the business value and the possibility to do everything, starting from the idea up to the operations and through all the cycles in development team. So basically, this type of architecture was developed by one team having only developers. Of course, they have their kind of things that they more focusing on, but they are all kind of DevOps people. And this is kind of a huge benefit, less coordination, more ownership, and then also ownership for the on-call duty for this stuff. So there are challenges, but once again, there are lots of advantages. So that's basically it. This is what I wanted to share with you, this kind of practical stuff, which is live since several years, and we're learning, reiterating, and I will continue sharing the knowledge on this. So thank you very much.
Hello everybody. The presentation that I'm going to make this afternoon is called Build Your Own Pluto TV with AWS Fast Channel using Media Live and Media Tailor. First of all, I'm going to present myself. My name is Luis Valdivia. I'm from Peru. I have 15 years of experience in software development. I have 4 certifications of AWS. I work as a CTO in +1 Design and Development, and I also am a part-time teacher at a local university here in Peru. I am certified cloud architect, and I'm a community builder. This is my 2nd year. The agenda we are going to talk about is, first of all, we have to define some key concepts. What is AWS Elemental Media Tailor? What is Elemental Media Live? An architecture that we are going to show, and then some examples that you can follow and you can test. The first key concept that we are going to define is what is HLS. HLS is a protocol like HTTP and the other crazy one that we use as architects. This protocol was developed by Apple for delivering audio and video over the internet, primarily used for video, for live and on-demand streaming. A clear example where we can use HLS is when we open a streaming app like Netflix, YouTube, and the others that we like. After we click and watch a video, a series, movies, and so on, that is HLS working. Second key concept, what is VOD? VOD stands for Video on Demand. It's a media distribution system that allows users to access video content whenever they choose, rather than being tied to a fixed broadcasting schedule. A clear example is when we go to YouTube, we look for a tutorial about Python, C++, or other crazy things that we want to use, and we select that video. That is VOD. Also, when you use Netflix, Amazon Prime, or even Crunchyroll, that is VOD. Third key concept, what is Fast TV? Fast TV is a free streaming service where users watch content on channels that use advertisement. For example, Pluto TV. Pluto TV is a free website and mobile app that you can download or you can open in your browser, and you choose a channel and you start watching. After some minutes, they put you on an ad. They live using ads. It's very different from Netflix or Amazon Prime. Our fourth key concept is what is a playlist. A playlist is a text-based file that uses HLS to tell the video player what segments to play and in what order. As many of us know, if we record a video in our mobile device, that is Android, and we send it to an Apple device or maybe to our smart TV, the format is not the same. An Android video is different from an Apple video and the other devices. With this playlist, we convert these files to a universal format that can be reproduced. And where do we see this file working? If you open your favorite streaming app, you can notice if you have a good internet connection, the quality of the video will be awesome. But if you have a poor internet connection, your quality will be very awful, terrible, and some other things. This playlist has that magic. This file decides if you are going to see a good quality, medium quality, or terrible quality. But maybe you will think, Luis, I'm a programmer, I know that this can be a conditional. I can detect the bandwidth that you have and I play a good video. If I have a not so good connection, I will play the not so good video. And if I have a poor connection, I will play the bad video. But this logic is not implemented by ourselves, it's implemented automatically. Maybe some of you know about WOSA. WOSA can create this file. In some more minutes, we are going to create this file and we are going to watch it in action, see it in action, and we are going to experiment some things also with Pluto TV. The first service we are going to talk about is AWS Elemental Media Live. Maybe the services that I'm going to talk about, they are not as popular as EC2, RDS, Lambda, containers, Docker, and so on. Elemental Media Live is a service that is cloud-based broadcast-grade video processing service with the ability to deploy a live channel in just minutes. This service is like a serverless service. You don't have to deploy an EC2, RDS, S3, and all the cool services that we have. And if you want, you can create your own Terraform or CloudFormation template to deploy this service. As I mentioned here, we are going to create a live channel in minutes. As I mentioned before, I mentioned this service, this software called WOSA. WOSA is like a Titan. It's the best software that you can have to deploy live streaming and make some crazy things with video. But the disadvantage that has WOSA is that you have to learn a lot. You have to do many things and maybe you need to spend a lot of time learning. With Elemental Media Live and the other service that I'm going to talk about, you only need to experiment and follow a wizard. Then you can customize a CloudFormation template or some crazy things that DevOps do. Then we have his brother, Elemental Media Tailor. Media Tailor is a service that lets you insert ads in video. For example, when you are watching a tutorial on YouTube and you are learning Python, after some minutes they place you an ad about Platzi, chicken, animes, or other things. Media Tailor allows this. And if you want to build like a linear channel with full content of VODs like Pluto, Tubi, or others, it has a little friend called Channel Assembly. With these two services, we are going to create a live streaming with this. This is the architecture we are going to develop. First of all, we have an S3 bucket. We know that S3 bucket you can place files, GS, assets, and many other things, even websites. Then we are going to create something called source location. Source location is like a repository of all the content we are going to use. Then we are going to deploy an Elemental Media Tailor, but the channel assembly. That is the one that is going to allow us to create like a timeline that we are going to place a lot of videos. And then this outcome will generate an input for the next service, that is the Media Live. And Media Live is going to create some things in another bucket. This bucket is point to a CloudForm distribution, because CloudForm distribution allows us to use all the good things that edge location has, and is the CDN. Maybe you can change the CDN for it, but we are using in this case CloudForm. And then we have the player. What is a player? Every time you start your streaming up in your device, that is the player. Now, if you want to follow the things that I'm going to do, these are two QRs. You can scan them. The first one is a repo of GitHub that are all the steps that I'm going to do, and some configuration that I need you to make before this, because I assume that all of us has an AWS account, know how to create an S3, how to play a little bit with IAM service, and these things. And this is the outcome that we are going to use. If you scan this, you will see like a slate with a frog, because I don't have any content yet. So let me some minutes to change our scheme. Yes. Yeah. As I mentioned you, we are going to discover where a playlist is used. This is Pluto TV. Pluto TV is a free website that you can enter and you can play, watch content, anything you want. But we know that I can do this. Right click, inspect, Chrome tools, developer tools, or in the browser that you are using. We go to network. In network, we can inspect assets, any other things. This is where you can do it, and we are going to use this one. If I open this tab, we are going to see that I am playing a video, but this video has an extension. I will open in incognito screen. If I try to open in another tab, it will download this file, an entry.ua file. This is the playlist. In the other tab, I can play the video because I have a particular extension that allows me to play this video. If I download this file, I will open it. You can see here. This file, as I mentioned you before, it has the logic that will change the quality of the video. If we have good internet or bad internet connection, it will show the video of that quality. But you will say, how can we do this? To do this, we are going to go to our AWS console. First, we are going to go to my S3 bucket. In this S3 bucket, I have two buckets. I have the one that is holding my videos. I have 5 videos of any content, and then I have this folder called convert. That convert has all my videos transformed. When you are trying to play content on HLS, you have to transform your videos. If you want to transform your videos, you have two choices. You can do it with Woza, and you can do it with AWS Media Convert. If you are following my repo, in my repo I have the example of if you want to convert the files using Media Convert. Media Converts work using like templates called jobs. If you want to check the job that I'm using is here. It's a simple JSON file that you can watch, you can test, and you can make any change that you want. I have used Media Convert because Media Converts allow me to convert these files in around from 1 minute to 5 minutes. It depends on the quantity of the duration of my videos. After we have this, we are going to go to a service called Media Tailor. Media Tailor has two friends. The ad insertion that we are not going to use, this allows me to insert ads, and we are going to go to channel assembly. The first thing we need to do is, after we converted our videos, we have to create this location. I'm going to create a location This is test. And we are going to point to the location where it is. I'm using S3. This S3 has a CloudFront distribution there. I'm going to copy the CloudFront distribution that I have. That is this. I copy the CloudFront. Yeah, I create source location. This is, I have created my first source location. I can have a VOD and live source location. In this case, we are going to use VOD, but you can test the live source. To add a live VOD source is very easy. Click here. We have a name. I will call it test. Here you can leave this like this. You can it's like a you write a name to. Is a name that you can do like a tag when you are creating an EC2 or RDS. We are using HLS. You can use dash. I prefer to use HLS because it's more popular and it's more used. And here we have to point to the entry U8 file that we have created. In this example, I will go to this folder called dandan, and I will look for this file. What I need to do is to point to the folder that is my file, where are my files. In this case, dandan is located in convert dandan. Convert dandan and the file. You can change the name in the job that I shared with you. You can change the name and you can do some crazy things. Then add VOD source. We have created a VOD source and we have added a video. Always remember, if you want to use media tailor, you have to convert all your videos using HLS. You can reproduce M334 files or AV files or any other kind of files. Then we need to create a channel. This channel is the one that I created to share the repo of Bitbucket, but I will create one with you. Create channels. We can call it test. We have two tiers here, basic or standard. If we follow the documentation, the standards allow us to create a fast channel using VODs and live streaming. Maybe in some other talk I will show you how to use both of them. But in this example, we will use basic. What is required? This is a filler state. Filler state is like a video that you are going to use when you don't have any content. If you are playing the QR that I shared a few minutes ago, you will see that I'm showing this. This is my slate. It's a temporary content that you put to if you have any difficulty, any trouble, or you don't have any content. I will choose VOD. What is that one? And my slate is called loop. Next. Here we put a name. I normally use playlist M3UA. Next, attach a policy. In this example, like it's a proof of contents, I'm doing it public. In a production environment, you need to do it with little bit more careful. Create channel. Sorry, that's the name. I will use this one. I will use this one. This one is the one that I created before. As you can see, I have a filler state because I don't have any content. How I'm going to add it content? Right click in add program, a name that is called, for example, dandan. I choose my source location. I will use dandan. Next. If I wanted to place it right now, I use relative. If I want to schedule it, to appear in a specific date and time, I can do it like here. I will do it relative. Relative, I will use all the content, next, and add program. My program was already created. We have to wait some seconds. I will create another one. This will call it blue log. I choose my source location. I use log. Next, I will put it relative, but after the program. If I select after the program, I place it before. I place it after done. Next, add program. Let's wait some minutes. Let's refresh this. Let's wait some more minutes until it refresh. Let's wait. If you are watching this, if you scanned the QR that I shared with you before, this video is already playing. Sorry, I have to mute it because I forgot that had sound. After this video ends, it will start the one that I call it blue log. Then you can add more and more and more and more and more. If you want to add more and more, you only have to do add program. I will call this solo leveling BOD solo. After program, blue log, next, add program. Let's create one more mashup. BOD mashup. After solo level, next. With this, you can create all the content that you want. For example, I use blue log, solo leveling, mashup, and so on and so on. If I go to my URL, it will end this, and then we start solo leveling and the other. I'm doing this in the AWS console, but you can do this by using AWS CLA. You can do it. You can program all the content from your day, from 1 day, week, month, maybe a year. It depends on how you are going to plan to upload this content. We have used elemental media tailor, but elemental media tailor generates an outcome. The outcome is this. How we are going to use it? Using media life. We go to media life, and the first thing that we need to do is create an input. To create an input is very easy. Create input, a name, HLS, because we are generating at HLS, and you will set, Luis, how are we going to connect Taylor with media life? Easy. You go to your channel in media Taylor, goes to outputs, copy the URL, we paste it. One thing that you have to be very careful is about pricing. In media, if you are working with this service in media Taylor has around a cost of $200 per month if you are running 24/7. If you are going to use media life inputs cost around $100 to $300. It depends of the input class. In input class, you can use single input or standard input. Standard input is if you want to use those inputs at the same time. In this case, I'm going to use only one. I create an input. The input is already created. I'm going to a channel, create a channel. One thing that you have to be very clear is one input per channel. An input is not shared between other channels. One input to one channel. If you want to check But the thing that I am saying, you can go to input attachment, add, choose an input. I have two, but it only shows me one. Test input. Confirm. Here you can create all the qualities that you want. But to make this a little bit more easy for you, in the repo that I shared, you have inside this folder config, you have a JSON called strip. In this, I'm only giving you one quality because it's a proof of content, it's a demo. If you want to have more qualities, you can change this file to add as many as you want. In this case, I'm only using one. Select custom template, strip. We put a name, test, and create channel. Create channel. We wait a little bit, and our channel is going to be created. Here is. And our channel is showing us like a little preview. If we go to the URL that we're using, here is the streaming. As you can see, we have created like a small anime fast channel in around 10 minutes, maybe more, maybe less, but around 10 minutes. With this, you can create your own Pluto TV. Well, you have created like the streaming of your fast channel. If you want to create all this UI UX experience, you have to do some backend and front-end development. But with this, you have created. If you want to check if I have created an NTU file, you can do. We copy this, we open an incognito tab, we download it, and it's smaller than the one that is using Pluto, because Pluto has a lot of more customization, but this is the basic one that you have created. You only followed a wizard, and you have deployed a small fast channel of animes that I like. Let me change this. Here are the QRs if you want to scan it or take a screenshot. What other things we can do? We can use both of the friends of Media Tailor, the config and the assembly, and we can add a live location. Maybe in this small channel that I have deployed with you, maybe we can add this streaming where you are watching us. Maybe in some other example. Other thing that you can do is, for example, this small channel that we have created, we can send it to a cable provider. We follow all the things that we have used: stream, location, Media Tailor assembly, config, Media Live. But the new service that maybe you are going to need is called Media Connect. Media Connect allows you to send this streaming in other protocols that is used for cable providers. And if you want to do other crazy things, you can use Lambda, SageMaker, Bedrock, and the other service. Because when we are in AWS is like a basic ice cream. Every new service that we use is a topping, so we can use the toppings that we want. Thanks a lot. I hope this demo you will find it interesting. You will follow it, and maybe you make some customizations. These are my social media if you want to follow me, and LinkedIn and GitHub. And I don't know if any of you have any questions about these services or anything that you want to talk about. I can hear you. I can hear you. I I can hear you. I can hear you.
I did have a question here.
Mm-hmm. Yeah.
So basically, appreciating that your demo was live and using the console, this is from Paul Dunlop on YouTube. If I wanted to do this in future myself, would you recommend using infrastructure as code to set things up, or continue to just use the console?
If you are going live to a production environment, I recommend you to use maybe a Terraform, CloudFormation, or maybe a backend that is connected to AWS ELA, and it's going to deploy all the things that you want.
Brilliant. Okay, I think that's the only question that we've got for now. Thanks very much, Luis.
Thank you. Thanks a lot.
Morning, everyone. I'm Dmitry Sion, and today I'll walk you through the from chaos to control, scaling DevOps excellence in a fintech environment. Let's dive straight in. This agenda is simple. I'll briefly introduce myself, start from how the project began, and walk through our DevOps journey. Think of it as a stages from toddlerhood to adolescence. We'll cover lessons learned, future plans, and wrap up with a Q&A. Please drop your questions to the chat. I'll do best. I'll do my best to answer all of them. In this session, I tried to cover 5 years of the project life in a 30-minute session. But honestly, every single month or sometimes even a week was a dedicated session. I'm Ukrainian, so yes, you might notice this terrible accent. I'm leading the AWS user group on the Gold Coast. I'm AWS community builder and hold 15 active AWS certifications. I've been in IT since 1996, so I'm kind of dinosaur, and I've seen quite a bit along the way. My team's journey kicked off in April 2019. I joined a few months later in September. Take a look on this picture. It's well-known meme, and it quite a good illustrates the state of the fintech product we inherited. Lots of legacy elements. The client's team were about 100 of people. Roughly a third were developers and Q&A. And we were just 2.5 DevOps engineers, as I was only partially involved from the beginning. We handled everything. Infrastructure, 24/7 incident responses, security, compliance, and developer support. From the engineering standpoint, we had tens of EC2 instances with self-hosted MySQL, Elasticsearch, Redis, Memcache, and all of this were hosted alongside with application. We used Bitbucket at our source control, Bamboo for CI/CD, and we had even some Beanstalk applications. The team we inherited infrastructure from just started migration to Kubernetes. It was early stage of the product on Kubernetes for the team, and none of the developers had experience how to work with containerized application. To make everything even more spicy, application was written with PHP, and big part of the code was based on a self-made framework. But developers started to use Laravel aside of it. I almost forgot. To manage new clients, to onboard new clients and perform configuration for each of the client, we had a self-made API on a Python, which is a piece of script. Of course, it's about the code, not a Python itself. And this API is still in place for now. So we are at the toddlerhood phase. We started by getting to know the product, which was an 8-year-old, fairly large financial CRM with roughly 300 customers. 300 customers doesn't sound like something quite big, but each customer is a business with hundreds or even thousands users who are using this CRM, what makes it quite a highly loaded system. The good thing, all the clients were located in USA, so we had like wide maintenance window. We were able to maintain our infrastructure during the off-business time. Given our small team, we moved as much as we could to managed services. For example, we replaced self-hosted MySQL with RDS, Redis, and Memcache migrated to the Elasticsearch. Elasticache, Elasticsearch became managed with following migration to the OpenSearch. In other words, we adopted managed AWS services wherever it possible. We also phased out Puppet and brought in Terraform because we had not much expertise in Puppet. Another thing we introduced was so-called postmortems or post-incident analysis to learn from each event. And we had quite a bit of them in the beginning. Meanwhile, we have a PCI DSS audit on the horizon that kicked off in October, and our team was spread across the European time zones, US and European time zones, which limited our overlap. It wasn't easy to onboard this project, but it laid the groundwork. Next 2 years, we were in our so-called childhood stage. At this point, we introduced chaos engineering. Since then, we have a weekly cross-team trainings with the DevOps team and lead developers, where we started stress testing each component of the infrastructure to find single points of failure. The result of each session was a run book, Jira tickets for improvements, and ideas for the next session or next exercise. That gave us a much more clear picture of how everything interconnected and where we need improvements, whether on the application side or infrastructure side. In the beginning, when we shut down or limited one of the components, the whole infrastructure went down. Application was unusable, and we started to decouple our components as much as possible on the way. We also ran into open source Terraform limitations. As a startup, we were limited in a budget, so we tried to build everything on open source tools. So we layered Terrorant, which is a wrapper on top of the Terraform, and helps us keep our code dry and reduce the blast radius by separating state files. At that time, we got one more DevOps in our team, but turned us into the 3.5 DevOpses. We started using AWS Business Support heavily. It was nice time without AI to lean on. That support saved us a lot of time by validating ideas and offering structured responses as well as help during the incidents. It was typical for us raise several tickets end of the working day, and in the morning you got fully full answer, like all the information you need to start your day with analysis of the problem, with some links that will help with save time. Of course, as the product grew and management came to us with great news that from now on, we had to comply with SOC 2 and HIPAA on top of PCI DSS. And it was not the last news for us. They decided to sign a strictest SLA with the customers. So from now on, any new outage affected the client will cost us astonishing 30K per client. shifted priorities from cost optimization to resilience even more. We started to think about to become multi-regional. We started to work on our disaster recovery procedures and testing our disaster recovery procedures. Having infrastructure in a second region just doubled our costs, and it was much harder to move all the data, keep it in sync between regions. For example, our MySQL database cluster has about 35 terabytes of data, and just syncing this data over the regions costs a lot for us. I tried to put on a graph number of incidents we had. In 2019, you see like 0 minor outage. It's not really true. It's just because we didn't notice, we had no time to write down all the minor outages because we had quite a lot of major outages. But then things started to be better, and in 2021 we had only one major outage which affected the clients, and just two minor outages, which was just a slowness for clients, not really a full outage. Moving on to the middle childhood phase. In 2022, we were acquired by a larger company, which expanded our team to over 500 people and gave us a dedicated security, networking, and compliance teams. We signed an AWS EDP with enterprise support and adopted even more managed services, consolidating our infrastructure and focusing on platform engineering and cloud security. We started to use Logs.io for collecting logs, Fastly's CDN and web, Cloud WAN for better networking, and some others. But at the same time, with the larger team and new on-premises requirements, we had to ensure all our tools work both on-prem and in AWS. Having more stakeholders added complexity to the decision making. Also, with the global customers and team members who are using product 24/7, we were limited in maintenance windows. We can do it only on weekend and should inform our customers about it in 2 weeks before we starting to work. Also, there are some other challenges with a bigger team. Along with acquisition of our company, this bigger company acquired 6 more companies with our. And after the acquisition, they did inspection, like throughout audit, internal audit of the all infrastructures, all the teams, all the products they bought, and identified our infrastructure as a leader, the best practices implemented in our AWS infrastructure. So we started to be like an example how everything will work in the future. So we spent a lot of time trying to consolidate 6 different accounts in different clouds under the one standard. And it took a lot of time for us. However, despite of the challenges, we minimized major outages with only minor issues cropping up occasionally. You can see that since 2022, we had no any outage anymore. And there are just a minor slowness we registered over the time, which were worked out. We had like post-incident analysis and made improvements to not have the same problem anymore in the future. On the final slide, the lessons learned. What worked well for us was a managed services. They were absolutely worth the investment. Without managed service, we simply couldn't have scaled this effectively with a small team. Chaos engineering gave us deeper insight into our platform and trained everyone to handle issues confidently. Cross-team communication was vital. You can't build anything big without it. Investing in a training kept us innovative. Every time some of the teammates visiting conference or taking workshop had a chat outside of the company with colleagues, bring new information to our team about the tools available, practices that worked well and working not well. Another crucial lesson is a blameless culture. We had it from the day one, and it allowed the team to fail and learn together. It's really helped us improve. I know that some companies starting to blame engineers if something went south. But in our team, we're just learning our lessons. And the main goal to not have the same incident twice. If we had some outage, we worked out it, we made changes to the infrastructure, to the application, just to make sure we will not face the same issue one more time. Of course, we still have annoying challenges, like the reality that there is no perfect infrastructure as code tool. If you know anything, if you can advise something that works best for you on a scale, I'm happy to learn from you. Businesses often prioritize quick fixes over ideal infrastructure. I can understand it, but my inner engineer crying every time when it happens. I always trying to have a perfect infrastructure, but business doesn't care about it. Scaling always bring bigger version of the same problems, and observability at scale can get costly. And if you have some small problem with your infrastructure, it will scale when you scale your infrastructure. So small problem in the beginning with the scaling became a big problem on a scale. Now we are focusing on building a robust platform engineering team, doing continuous training and exploring AI tools, which is in a good hands, can help a lot. We're starting to build scripts for AI and build it in insert it into our projects to help developers build the product which is more ready for production use. These scripts explain to the AI tools we are using how to make the application, how to decorize it properly, what expectations we have to the login formats, how we want to, which metrics we want to collect, and all other things. So when developers working with AI tools then can ask to review the requirements from the SRE team, from the platform engineering team, and ensure they made everything as required. We have a pretty strict CI/CD based on GitLab CI, which has all the scanning for security, SEST, DEST. We have SonarQube. So any new release, which happens like several, up to 5 times per day, do not require any attention from our SRE team. We just having a notice that another release just happened, and if there are no any alerts, everything good, because we trust our pipelines and our developer teams can release whenever they want. We do not have restrictions to release on Friday. They can do release whenever they want. And that's probably it for today. And it's time to questions. Let me check if I have any in the chat. Meanwhile, feel free to connect with me on LinkedIn and reach me out if any questions or ideas for collaboration. Okay, great. So if any questions, just make sure you drop them either in a chat or directly to me, and I will respond any question you have. And have,
Thanks so much for that. We will we'll move on to our Thanks again.
okay, thank you.
All right. Well, thank you all for coming. Today I'm going to be presenting a session called AI Agents in Action, how to build cloud-ready AI agents using AWS Strands. My name is Dale Orders, and I'm very excited to be here with you today at the first ever Oceanic Community Day virtual edition. So to start, I'm just going to introduce myself. As I said, my name is Dale Orders. I graduated with a Bachelor of Computer Science from Deakin University in 2021. After graduating, I went and completed the AWS TechQ graduate program. I currently work as a software engineer at Five9, which is a telecommunications company in the US. I specialize in infrastructure code, containers, and serverless. And I currently serve as a community builder in the containers category. And you'll see here on the right-hand side, I do have a QR code, so you're very welcome to connect with me on LinkedIn. Certainly happy to field any questions around those areas if you ever want to reach out and discuss anything tech-related. Always happy to. So for today's session, you'll see on the screen we have the agenda. We're going to start by looking at exactly what are Strands agents. So I'm going to provide you with a very quick overview of this particular SDK. We're then going to delve into some of the key components of a Strands agent. We're then going to build a basic Strands agent before looking at some of the features, particularly around tooling, models, logging, and memory. I'm then going to discuss Model Context Protocol, or MCP, which is a very important concept that you need to know when building a Strands agent. I'm then going to present a couple of multi-agent AI designs that you may be interested in using yourself before we conclude with a short demo. So that is the schedule for today's session. So as I said, we're going to start by defining exactly what it means when we say a Strands agent. So what is a Strands agent? So a Strands agent is an agent that has been built using open source SDK software. So this here is an AWS framework. It's designed to enable you to build simple yet powerful custom AI applications. It easily integrates with third-party tooling. So we will see in the examples later, you can use Strands agents with an array of different third-party tooling. It is flexible enough that it allows you to use any number of language learning models, as well as MCP, which I mentioned earlier. And finally, it has a very flexible design and enables you to build the agent with minimal code. So we will see that later. You're able to build an agent in only a few lines of code. So it has this particular benefit, and we will see just how powerful that is later when we start to build some of these agents. So to start, we'll have a look at the basic outline of an agent. So you'll see here on the screen, we have a user. The user is going to interact with an agent, which is on the right. The agent has some instructions, so we call these instructions a prompt. The prompt is going to give it context around what it is that the agent is to do. The agent is to fulfill these requirements using both actions and knowledge bases. So a knowledge base is all of the data and information that the agent can refer to in order to be able to successfully process the user's query. And of course, as I mentioned earlier, agents are driven by models. So in this case, and throughout most of the examples today, we will be using models which are served by Amazon Bedrock. So let's look at an actual example of this. So we have here a meeting assistant. The user can converse with the assistant. As I said, we have the instructions that serve to provide context to the agent. We have both the meeting actions and the utility actions. So these define the requirements that the meeting assistant has to fulfill. So in this case, the user may be asking for a list of action items. The agent itself is going to process that request using both of these two actions and is then going to return a response. So at a brief overview, that is what we mean when we're talking about agents. Let's looking at a little bit more of a complex example. So in this case here, the agent is going to use both a knowledge base and actions in order to fulfill the request. So we have a user. In this case, the user is going to ask a question such as, how much vacation do I get per year? We have an agent, which we've called a HR policy assistant. We've got the instructions where the assistant has been told that it is a HR agent and that it has to help employees understand HR policies and manage vacation time. So we have that context provided. The agent is then going to utilize the knowledge base, which in this case may be the vacation policy of the company, and is also going to then perform a series of actions. So it's going to request vacation time. So the input data may be the start date and the end date, and the output data may be the approval status and the remaining balance. And we can see here on the left-hand side how that conversation may play out from the user's perspective. So that is how an agent functions, but what are the key components? So you'll see here on the right-hand side, we have some components. This is very, very simplified version of how an agent is structured. In an agent, you're going to have a prompt. So the prompt it's those instructions that we spoke of earlier that guides the agent's behavior. The agent is going to coordinate the language learning model, the tools, and the system prompts, and perform operations as a single callable unit. You're also going to have tools, and a tool is simply a function that is registered using the @tool decorator, and we're going to see some examples of this in just a moment. And finally, we have the model, and we spoke about this at the start. It is a language learning model which processes the input data and returns a response. So these components work together in what's called an agentic loop. So you'll see here on the right-hand side, we have an example of an agentic loop. In this loop, the agent is going to perform all of the tasks. It's going to coordinate the tasks amongst the model and the tools, answering questions, planning, and optimizing the use of these components. As I said, it's a model-driven approach, so we are using the model almost as it's the brains of the agent who's going to be orchestrating the output. Together, these components work in a loop, so they continuously interact until the user's request has been fulfilled and a response has been returned. And the Strands agent is going to be executing both of the tools and the operation of the model, and it's going to oversee this loop until such time as the request has been fulfilled. So that is the agentic loop. Let's look at how it is that you can actually build a Strands agent. So the great thing about the Strands SDK is that it requires very few lines of code. So you'll see here on the screen that within 3 lines of code, we've actually built a Strands agent. So the first line you'll see, we have to import the agent. The following line, we set up the agent, and then finally we have to provide a task, or the agent with a task. So in this case, we're telling the agent that they have to tell us about the array of AWS AI agents. So that in 3 lines of codes, we've been able to actually build a Strands agent. But that itself is obviously not going to be enough. We want the agent to be able to undertake tasks. And to do so, we need to use tooling. So we're going to be using the Strands Agent Tools repository. This particular repository offers pre-built tools that you can import. You can also create custom tools using the @tool decorator, and we will be doing that today. You'll see some examples. We have an inbuilt tool, a range of inbuilt tools, such as a calculator tool, and we'll see that in the example on the right. So if we delve into this example, we can see that we start by importing the tools. So you'll see here that I'm importing the calculator. That is an inbuilt tool. I'm also importing the tool functionality so I can create my own custom tools. Underneath that, I'm going to use the @tool decorator so I can create my own custom tool. In this case, this tool is going to, it's called random number, and it's going to generate a random number between 1 and 10. I'm then going to input those tools into the agent. So you'll see there, beforehand we had the agent, there were no parameters. Now we have tools, and I'm going to be passing through both the calculator and the random number tool. And I'm also going to be providing a system prompt. So in this case, you're a helpful assistant. You can do simple math calculations and generate random numbers. So that's my context. And then finally, I'm going to query the agent, and I'm going to ask it to generate a random number between 1 and 10 and to tell me what is 10 times 6. So it's going to be using both of those 2 tools in order to perform that function. And then, of course, it will return the response. So that is a very simple example of how we can use Strands tooling. But we don't just want to use tooling, we want to also be able to use models. So Strands agents actually support multiple models. So in all of the examples so far, I've been using Bedrock, but you can use others. So providers include Anthropic, Light, LLM, Llama API or Llama, Open API, and a range of custom ones that are available. The default provider, so you would have seen in the first example, I didn't specify a model. If you don't specify a model, it is going to use by default Claude for Sonnet, and it's also going to use whatever AWS region you've configured. So those are the defaults. But of course, you can specify a different Amazon model by providing its model ID. So let's see how you would do that. So of course, we start by importing our libraries. We're going to import the Bedrock model. We're going to create a Bedrock model. So in this case, I don't want to use the default settings. I want to use Claude 3.7 Sonnet. And I want to use the US West 2 region. So I'm going to specify that in my configuration. And then I'm going to pass through the model into my agent. So very simple example of how you can configure a custom model. Let's look at logging, because obviously logging is very important. It's something we want to ensure that we do for good practice. So Strands SDK provides a logging module for visibility. You can enable debug logs by configuring the Strands logger. It supports varying log levels, so there's debug, warning, and error. And you can obviously change log level or format depending upon your requirements. So let's see a simple example of that. We start, of course, by importing the logging library. We want to set the strands debug level. So I've got this as debug. You can obviously use logging error or logging warning, depending upon what it is that you're hoping to do. You can format the logging as you'll see there. So I've got the specific formats, and that is going to output the logs to the error stream. So that is a very simple example of how you can implement logging. We also want to consider memory. So memory is very important if we want to ensure that there's persistent memory. If we want to ensure that there's persistent memory between invocations of the agent, we have to use something called mem0 memory. So this is a particular library that allows you to maintain context between interactions. Mem0 provides persistent contextual memory to help AI assistants adapt over time. It can store and retrieve information, meaning that you're able to use your agent to better satisfy the user requirements or user queries. And it supports 3 backends. So it supports OpenSearch, FAS, and Mem0 platforms. So I'm not going to delve into those today, but it's good to know that there are options of how exactly you can implement this. So let's look at an example. So as before, we're going to import our dependencies. We have the Mem0 memory. That is the tooling that we're going to need. Underneath that, we're going to create 2 custom tools, the first of which is going to take the user input and store it as the value of X. The second is going to retrieve that value when the function recall is made. Underneath that, you'll see that I'm going to input the both of the tools as well as the Mem0 memory tooling into the agent. And finally, I'm going to use this by invoking the agent, the first of which is going to use the store function to input hi into the agent. The second is going to recall that using the recall tool. So it's going to retrieve the value of X, which in this case is hi. So that very quickly demonstrates the power of using persistent memory with the Mem0 memory tooling. Next, we're going to talk about Model Context Protocol. So, Model Context Protocol provides an interface connecting AI models to diverse data sources and tooling. So you'll see on the right-hand side, we have our host with the MCP client. It is going to communicate with MCP servers using the MCP protocol, and that is going to enable the application to more easily access local data sources as well as remote data sources, and it provides that level of functionality that we wouldn't normally have, meaning that we can more easily customize our application. So the Strands AI SDK integrates natively with MCP, and it enables these agents to interact with external MCP servers and their tools. The MCP servers can supply agents with additional ready-to-use tools and workflows. So this enables you to create more customizable applications that can perform a greater array of functionality. So this is a very, very important concept to know, and something we will be looking at a little bit more in detail. Next, we're going to talk about multi-agent AI design. So there's a number of different ways that you can design your application if you're using multiple agents. I'm only going to discuss two today, the first of which is sequence. So you'll see here on the left-hand side, we have input, and it's a very simple example. We have the input from the user. We're going to have that input is then going to be sequentially passed through two agents before an output is returned. So that's the first example of how it is that you could structure your AI design. You could also use the second, which is a supervisor design. So in this case, we have an agent called a root agent or an orchestrator. This agent will process the incoming query, and it will route it to any number of agents. So in this case, if the query relates to a weather request, it could direct that to the weather agent. If it's a request that somehow pertains to stock, it would then direct that to the stock agent or to the newsletter agent, depending upon the way in which you design the application. So that is a different approach that you could take when designing an application that uses multiple AI agents. So now we've gone through some of the key features of a Strands agent. Let's look at how this works as a demo. So I'm just going to bring up VS Code. Okay, so you should see on the screen, I'll just resize this. So on the left-hand side here, this is going to be, the first example I'm going to show you is a sequence multi-agent design. So that is where you take an input and you pass it sequentially through multiple agents before receiving an output. So for this example here, I'm obviously going to import all of my dependencies at the top, you'll see. I'm then going to have prompts. So in this case, I'm going to use two system prompts, the first of which is going to take the user input and it's going to make a HTTP call to Wikipedia using the country name. It's going to return the capital city of the country and a description of the country. So it's going to return those two things. And finally, it's also going to return the total word count. So I'm giving the context, I'm specifying the API call I want it to make, and then of course I'm indicating or I'm outlining exactly what I want the response to be. So that is the first prompt. The second will be a currency converter. So this one is going to convert from New Zealand dollars into a currency of your choice. So again, I'm going to specify the API call I want it to make. And in this case, it's going to use the input currency code, and it's going to return the conversion. So those are the two prompts. I'm going to use tooling. So this here is going to be a word count tooling, and it's just going to count the words in the given text. I'm going to use a Bedrock model. So I'm using Claude 3.5 Haiku. And then I'm going to instantiate both of my agents. So the first one is going to be the geo agent that is going to be providing me with country information and word counts using Wikipedia. And the second, of course, is going to be the currency converter. And of course, each has its own prompt. Both are using, well, the first one is using word count tooling. The second one obviously doesn't need it. But they are also using the same model. If you wanted to, you could actually create a second model here and you could have each using a different model, but I've decided to keep it simple. And then I have an orchestrator. Now the orchestrator is going to go through, actually I'll, provide here. oops, this one here, sorry. The orchestrator is actually going to go through and it's going to receive the response, receive the input, and it's going to, from the input, it's going to decide whether to direct that that query to either the geo agent or the currency agent, depending upon the contents of the query. And it's going to return that to the user. So I'm going to just do this. Sorry. So there we go. I'm going to start the server. So here we go. I will say that all of these, that this GitLab code is I will provide you with the QR code at the end. You can access this yourself and go through this in your own time if you wished. So I've started the server and I'm now going to just demonstrate. So I'm going to take this prompt and I'm going to make a HTTP call. So in this one, I'm asking the Strands API to convert 100 New Zealand dollars to Japanese yen. And you can see here, based on the current exchange rate, 100 New Zealand dollars is equal to approximately 8.796.2 Japanese yen. So you can see it has correctly performed that task. I'm going to try again. This time I'm actually going to ask it to tell me about New Zealand. So I'm going to paste in that call. Okay, and let's see if it can do that. And yes, it does. So here it says the capital city is Wellington. It gives me information about the country, and then it gives me a word count, which in this case is 107 words. So you can see it's been able to correctly process both of my API requests, API calls, using the correct agent. So that there is an example of how we can use a simple API, we can use a simple Strands agent to effectively process and return the correct information. So let's look at a different way that you could potentially design your application. So in this case here, I'll just get to the next section. So workflow agent. Okay, so in this one here, we have, again, we start by importing our dependencies. We set up logging. So we spoke about logging before, so you can see that I'm using that here. I'm going to be using 3 agents. So I'm going to use 3 prompts. The first, so this application I've designed to be a travel planner. So the first agent is going to, it's going to take the user input and recommend a single holiday destination. The second agent is going to create a 5-day itinerary for tourists that are visiting the location, including key activities and places to visit. And then finally, the last agent is going to develop a 5-day holiday itinerary with a budget estimation. So that's going to be the total cost of the holiday, and it has to be, those costs have to be specified in US dollars. So I'm using 3 prompts. As before, I have my tools. I'm using Claude 3. I'm using the same model as before. I'm going to use that model for all 3 of my agents. Each agent is obviously going to have its own prompt. And then I have my workflow orchestrator here. So in this case, I want the user input to go through each agent sequentially. So it's going to be passed through to the first agent, which obviously has to find the holiday destination. It then goes to the second agent, who is going to create 5-day itinerary, and then finally the information of the output of that agent goes to the third agent, which is then going to create the budget. So it's going to go through each agent individually, and it's then going to be returned to the user. So let's try that. So I'm just going to cancel that. So I'm going to go to the bottom here. I'm going to start my server. This time it's going to be on port 8002. So I'm going to paste that. Okay, so the application has started. I've got an example here. So in this prompt here, I want a relaxing beach holiday with cultural experiences. So I'm going to paste that in. And let's see what it suggests. Okay, so it has suggested Bali, Indonesia. So the first agent has found the destination. So they're recommending Bali, Indonesia. I've got the 5-day itinerary, which we can see here. So morning, afternoon, and evening activities are provided. So I can see a lot of information here. You can obviously be a little bit more precise in your prompts if you want to have something that's not quite as detailed. In this case, I've just asked for as much information as I can get about this destination. It's obviously provided a lot. And then at the end, the final agent has calculated a budget. So that is the budget if I wanted to do a moderate, and it's even actually broken down the costing of each individual activity. So you can go through all of that information. That there is an example of how we can coordinate agents to actually work together to produce an output. Now, obviously this is great, but we don't want this running locally. We do want to be able to deploy this to AWS. So I'm going to take this example here. I'll just close this screen, close that. Okay, and I'm now going to take this example, this travel planner, and I'm going to deploy this to AWS. Now, there's various ways that you could do this. You could containerize the application. You could run it on a VM. Considering we have little time, the easiest, probably the fastest way is actually to deploy it as a serverless application, and I'm going to do so using SAM. So I'm going to do that. I'll start that now whilst we have a look at some of the code. So this is my SAM application. So you'll see here I have, I'm just going to write it here. I have the same code that I had before. This is my application. Give it a name. I'm going to call my app Travel App. I'm going to US East 1. Yep. Notification. Okay, I don't need any authentication for this, testing purposes. And so I'm just going to wait for that to deploy. So when I look at the SAM application, I'll just open the template here. So you'll see that we need to a template. So this is going to create a function called deployment function. Going to be, I've said it can, this is not best practice because I'm allowing it access to all of my Bedrock models across all of my environments. But if you have a specific model, you would obviously want to specify it here. And then it's going to return the API, so I can then invoke the application. So that is how we are going to be deploying our application. I'll give it a few seconds to finish. You'll see here it is performing, we're using cloud formation to actually create these resources, so you can see exactly what those resources are. And then once that finishes, we'll then be able to invoke our agent using an API call. So this is going to be my request. I'm going to ask my agent to plan a relaxing beach vacation in Australia for a family of 4, and we're going to see exactly what it recommends. So I'm going to take that, I'm going to paste it. Now, this one I'm obviously going to need my API. So, oops, I'm going to go here, paste in my API. We don't want a space. And then, okay. So we give that a few seconds. In terms of the actual, this is available on GitHub, but you can see also in addition to the application, we're going to need to provide the libraries. So in this case, these are the ones we're going to be using for this application. We also have our configuration. So that there is also part of the SAM deployment. And this is what it's recommended. So you'll see here, it's a lot of information. It has recommended a holiday in Byron Bay, Australia, given me a description. I've got a 5-day itinerary, and then I will have the last agent, which is calculating a budget. So that there is an example, very, very simple example of how you can create a multi-agent application and then deploy it to AWS. Obviously, you could have deployed it in other ways. You could use CDK, you can use Terraform, you can use various ways, but for the sake of time, I decided to go with serverless application deployment. And you can see we were able to do that fairly quickly. So I'm just going to return to the PowerPoint. You can see. So we've gone through an example of both of these designs. And that is the end of my presentation. I hope you found it helpful. I hope it provided you with a good introduction to what the AWS Strands AI SDK can do in terms of developing and deploying AI agents. If you're interested in knowing more, you're very welcome to contact me on LinkedIn. I've also got there the GitHub code. So all of that code that I use today is on GitHub. You can go through, the steps are provided, so you can go through and you can do this yourself. Obviously, if you wanted to make any modifications, you can certainly do so, maybe add additional agents or try and see if you can create something a little bit more complex. So you certainly feel free. You're certainly welcome to do that yourself. But thank you for attending, and I hope to see you again soon.
Hello everyone. A very good day to you. It's very early morning here in India, but yeah, I wish you a very good day in whichever part you're watching this virtual connect, virtual edition. This is the first virtual edition that AWS Community Day Oceanic has done. So great job, team. Um, uh, Let me give you a little quick about for what topic I gonna speak today. That is Cloud 10. How you wanna stash your AWS cloud bill. So a little bit about me. Hey everyone, this is Varsha Verma, transformation specialist at Accenture, meaning I manage the operations and delivery. I work at AWS environment only. So yeah, I'm also AWS community builder. Hey, I'm multi-cloud certified. I love speaking at public events. I have done a couple of AWS events earlier last year. So this year it's going to be the first virtual event. So I was very excited to be a part of it. I also love writing technical articles, technical blogs. So you can check out all those article blogs in my LinkedIn and let me know like how you like it. So before running to the topic, like what topics we're gonna cover it, like why is really cost optimization needed? Like why it is needed? A lot of question might come to your mind. So one picture which conclude all of this thoughts, like is it needed? Why it is needed? Is this? Yes, I really love this movie. So obviously we don't gonna end up running our EC2 instance. That's the first thing when we start our AWS journey. That's the first thing that we know about is EC2, right? So we launch EC2 servers, and sometimes I think 99% of time I have heard people that they have left their EC2 instance on, and which cost them a lot. Like trust me, a lot. So their free tier, whatever number of hours they're getting, they have exceeded that. So they get a surprise bill on that. So you don't want to end up there, right? So that's where like how I want to show you some strategies, some AWS services which you will be useful for you to make your bill a little less as compared to what you're getting as a surprise bill. So yeah. So these were some of the topics that I gonna cover today. These are my favorite cost optimization topics. These are services actually. So I gonna brief you a little bit about each of these, and you will be knowing, okay, like wow, this feature is the like what I was looking for, but somehow I was not using it. So it will be useful for you. Trust me on that. So trust me on that. We have trusted advisor as well. So let's quickly get into the first one. AWS Cost Explorer, like the name itself is like that, Cost Explorer. It's gonna show you a dashboard. Dashboards are cool into like AWS accounts, right? You don't have to read through all of the logs, like where it is going, what and all. It is segregating a lot for you, like based on your need, your filter, like be it service, linked accounts, region, instance type, like how you are using the resources, that as well. So AWS Cost Explorer, it's a tool that enables dashboard, which you're gonna see the picture clearly into the screen right now, to visualize and analyze the cost usage of resources with multiple filters. It provides granularity over the resource level, like you can segregate using the filters with the resource as well, like be it S3, EC2, inside EC2, you can also segregate depending upon the instance types. So it can be hourly data, it can be multi-year data. So it's very helpful in getting the history checked with this trend. So in AWS Cost Explorer, you're going to see the last 13 months of the data, which will help you in analyzing for the what happens in the history, and which will help you forecast like what will be your upcoming spend. Um, then You also see in the lower section, there will be cost and usage breakdown, right? So it's like what the service you're using, what will be the service total, depending upon like multiple months. Here I have taken data from March 24 till August 24. So you can also download this. It's really cool, right? So you can also download it. Okay, next one is like this, my again favorite meme from The Office, Dwight Schrute, the Trust Me guy. You have the Trust Me service in AWS that is named as, yeah, AWS Trusted Advisor. It's a really cool thing because it will show you like the complete optimization thing. Like you can trust this data. It has segregated depending upon the cost optimization. On the front screenshot, you can see that performance, security, fault tolerance, and service limits. On the second screenshot, you see a bit detail about the cost optimization section, like what's the potential monthly saving, what action AWS has recommended you to work upon, what are the investigation recommended, your some of the things are having no problem, so it is detecting that info as well, and what checks you need to do. So it will also give you suggestion like which instance type you need to change or which volume is over provision, something like that. So it's really cool. I really love it. So a little bit about each of the section I want to cover. First one is the cost optimization. It will this recommendation can potentially save you a lot of money. This checks highly unlike like what are the unused resources and opportunities where you can reduce your bill. Second one is performance. The recommendation can improve the speed and responsiveness for your application. Security, very important part of it. So it recommendations for the security settings that makes your AWS solution more secure. Then we have fault tolerant. So this helps in increase the resiliency of the AWS solution. These checks highlights redundancy and shortfalls like of the overused resources. Service limits, like you might be knowing that there are certain limits up to which you have to use a particular service, right? So this will help you in checking the usage of your AWS account, whether your account approaches or exceeded the limit. You can also get this in the form of quotas, like any specific quota you have. So it will show up there. So you can always get these sections helpful for you depending upon your need. Then there is one more, operational excellence. This will help you get the operate your AWS account environment effectively and at scale. So in the lower section, if you see, it is showing that Amazon EBS over provision volume. So there can be the different volumes. IDs, it will show like how many of it are used and what are the saving opportunities in that. You can save up a lot, trust me. So one feature of it that I like it helps you provide the best practice for AWS by inspecting your overall AWS environment and helpful in saving money. Like not only saving money, but also improving the system performance and reliability. So it closes the security gaps in case any of these are there into your account. Well, everyone talks about like if you're working on-prem, so you have to move to cloud because why? It reduces cost, right? And you have unlimited resource to work upon, and voila, you will get a surprising 500,000 bill. Not exactly 500,000, but many of you folks will be resembling with this kind of situation because whenever we are making any free tier account into AWS, and we are using the services in and out, like the first one which I talked about, like EC2 instance, we launched. Maybe we are not launching it into a smaller instance type, maybe a bigger one, and then we left it running. Unknowingly, if even if we are shutting it down, still it is using the volume which is there. So it will cost you accordingly, and you will get a bill, and then you have to see like what you can do, because you're using free tier account and you will get a surprise bill. So in that case, budget comes into picture. Like, we have to make a budget, how we gonna use it. So you can also set up the custom budget track to get your cost usage from the simplest to the most complex use cases. Budgets are very essential. Like, why? Because instead of relying on the reports to detect when the expenses are about to exceed, we can't keep a check every time, right? Okay, this much we have left still, this much we are using it. So it's really difficult for us to get the check the report. So instead of that, we can simply create AWS budget alarms, which will alert and warn us and the appropriate individual triggers automatically to get the restrict to get us know, like, okay, this the hard limit, like I have reached it, and now I have to see what more I can do. So budget helps us to keep ourselves into the track, like how much we are using. So basically, there are 6 types of AWS budgets. Depending upon what your criteria is, you can choose accordingly. First one is cost budget. It will allow you to specify a fixed or variable amount you're willing to spend. It's the most simplest one. Second one will be depending upon the usage, like what volume of usage you are having for your AWS account, depending upon like number of hours or the amount of storage. Depending upon volume, you can use the second one. Then they have RI utilization budgets. RI is nothing but the reserve instances, which I'm going to cover in the later part of the so you have to define a threshold, and you will receive a alert when your reserve instant usage drops below that. Then we have the fourth one, RI coverage budgets. These will alert too much of your instance usage isn't covered. So these are some of the sections that you might feel like what RI are about. So you have to just hold up there. I will cover the RI section really soon. Fifth one will be saving plan utilization. As the name suggests, you will get the alert when your saving plan usage falls below a threshold. Then you have saving plan coverage. So you will get alert when your usage is covered by saving plans fall below a threshold. These are some of the types of AWS budgets. Apart from this, there are also like in a multi-account AWS environment, depending upon the organization governance structure, what it is, there can be 2 patterns for managing these budgets. First one is the centralized one. You might have heard of it. Second one will be decentralized one. So in the centralized one, the budget is set for the management account and for all of its AWS member account. So there will be a centralized budget, right? Second one will be a decentralized, where you don't have to manage for the management account, but the budget is for the individual AWS member account. So depending upon which plan you want to go for, these are the 2 more types. All right. I was talking about the reserved instance. That came very quick. So AWS reserved instances are like you have to give your commitment. For this much time, I'm gonna use the instances, which will be helpful in saving up a lot of cost. So based upon that, there are three types of RIs. Standard, you have to specify a term of 1 to 3 years. And AWS region, AZs, easy to instance specification, all of things you have to provide them earlier. That has to remain unchanged throughout. So you can't change any of the instance family type, you can't change their region, AZ, availability zone, nothing. And the payment option can be upfront, partial, or no upfront cost. This is the first type where you will get up to 75% off on demand. So this one is really great, but this doesn't give you any flexibility to change any of the instance type or AWS region. Second one is convertible. Okay, here you have a little bit of flexibility because this is similar to the standard reserved instances. But here the catch is you can change the instance family type. Suppose initially you were using T2.micro, later you want to change it, you can do that into convertible RIs. You can also change the OS tenancy and the payment option. Here you will get a little bit less discount as compared to the standard one because it gives you a little flexibility. So here it will be somewhere around 54% as compared to the on demand. Then third one is this schedule. So these can be launched within reserved time windows, allowing you to align capacity reservation with a predictable recurring schedule. So if your workloads are like that, go for schedule one. Like only a part of a day is needed, a week or a month. So this is again a little bit more expensive as compared to the standard and convertible ones. So what are the advantages? Like while switching the instance type or family, which might not be beneficial due to RI usage commitment, you can still utilize its flexible workload transfers. RI allow you to sell unused commitments. Yes, you heard it right. You can sell your unused commitments onto reserve instance marketplace, which is not an option with the savings plan. Then there is a significant discount as compared to your on-demand servers. There's a significant discount. Like for RIs, there are approximately up to 75%, right? Convertible, it is little less than that, but yeah, there are discounts when while paying your upfront cost for 1 or 3 years. Okay, but with advantages, there always comes some limitations. So RIs are complex and it requires careful planning because if you are into standard, you can't switch again to convertible. You have to plan accordingly, like what your workload gonna be. So you have to be very firm with that decision. You must run instances for approximately 774 hours. I just take a number, 774 hours per month with an RI commitment. So during the commitment, changing plans or benefiting from discounts may not be possible as RIs lock you into a specific instance commitment. So you have to choose wisely which one you're going to select. Okay, next one is the AWS spot instances. Okay, so these are very short-term scaling of the services to reduce cost. These comes very handy when you are using the spot instances, which may be reclaimed within a 2 minutes of notice. Like AWS will warn you that within 2 minutes, your EC2 instance will be terminated, right? So this is required when you have like fault tolerant or stateless application. It don't use it for the applications which doesn't have the fault tolerance. So this is spot instances are mainly for the requirement where your application can be fault tolerant and it is stateless. So you have to see on that part. Amazon EC2 spot instance also allow you to access the unused EC2 capacity at up to 90% of on-demand prices. Why? Because it's not running 24/7, right? It will comes up with a bidding cost, like this much you have bidded, and if it hits that, your spot instance will be up and running. If it is somewhere more than that, then it will be terminated and it will give you 2 minutes. Don't worry about it. It will give you 2 minutes notice that it's gonna terminate soon. So you can reclaim it depending upon the need. Next up is AWS auto scaling. Like everyone has heard of it. Like why auto scaling is needed? Because if traffic goes beyond certain specified limit that you have thought of, so you don't want your application to break, right? It helps to you to cater to the larger audience as well, depending upon the what duration or what is your traffic is about. For example, during sales, like they have a lot of sales going on, Black Friday sale and year-end sales. So in that case, what needed is suppose every day there are 10,000 people going to that website and the traffic is for 10,000 people, right? But during sale, it can go maximum up to 10 lakhs as well. So in that case, you don't want your servers to break because that will cost you a lot. And if your website is not working, then how are you gonna make money during sale? So auto scaling comes into picture for that part because it allows automatic adjustment of the AWS resources based upon demands. It scales computing power or storage up when needed, and when it is not needed, it scales down. So this screenshot show you pretty much similar what I explained you. So you have to define a minimum size, and if traffic goes beyond that, your EC2 servers will scale depending upon the requirement, and it can also scale down if the traffic is not that much. So there are three types of auto scaling. So there are three types of auto scaling types. I would want to tell you that there are dynamic, there are predictive, and there are schedule scaling. So in dynamic one, it will adjust the instance automatically based upon the specific criteria. Then there will be configurable policies like target tracking scaling. It will track your target and it will scale when it is needed. Simple scaling, you will be defining like on what basis the scaling should be. So that is simple scaling. And step scaling. Suppose traffic hits by let's say 1 lakh people. So two more EC2 instances required in that case. So it will spin up two more EC2 instances as you have defined. Second one is predictive. So adjust the instance based on the historic traffic patterns, and it will like help you with the daily or weekly trends. So in that case, you have to use the predictive scaling. Third one is scheduling. So as a name suggests, it scales instance according to the predefined schedules, and you're good to go on that part when it needs to be scaled in or scaled out. Then next is cost allocation tag. So cost allocation tags, it helps you get the uh, tags. Like tags are very important into AWS, whether it is AWS generated tags or it is user defined tags, right? Tags are nothing but it's a combination of key and value pair. So think of it whenever you are spinning up any new EC2 instance. You might see that there are some of the tags which will come by default, like the instance type. So key will be instance type, and there will be some instance ID associated with it, right? I hyphen XYZ. So those are values. So this will automatically generate it as soon as you spin up your EC2 instance. But some of the tags that you are defining for your convenience, like name tags, you want to name your EC2 server as test one. So key will be name and value will be test one. So this is user defined tags that you are defining for your own convenience. In this screenshot, if you see, there are two servers, instance one and instance two, and there are some tags associated with it on the very right side. So when you want to check only the database admin owner, you can segregate, and with the tags itself, it will show you like how many instances are there with that tag, how many instances are there with the maybe test, prod, QA. You want to segregate, you can use tags. Tags are really powerful, and you have to define it accordingly because it will save up a lot if you have like great tags in place, and the filtering process, everything will be very easy for you. So that's why like tags are really important, and you can define whatever tags you want to. Like you want to go for some application based on tag, go ahead. Define cost center, go ahead. Like use it according to like how you want it to be. You want it making it more simpler, and it will be very helpful for you. Like tags are very underdog thing that a lot of people are thinking that okay, it is a like a tag is like okay, a name tag only, but it's much beyond that. So use it effectively and you will see like how it is making your life easier. My favorite, serverless architectures. So this is the last one. Whenever you are thinking serverless, whenever you are talking it with anyone, everyone is like serverless. It's not no server. It's no server for you to manage. Like serverless is not like everyone is thinking of that there will be no servers for that particular service, but it's not like that. Like it gives you leverage. that you don't have to manage the server, but whatever you want to do with your creativity, be it a code feature, you want to make it more effective, that part you have to work more on, not like launching a EC2 instance and all. The very, very, very great example for this is Lambda functions, right? So whenever a certain like trigger is getting done, like maybe anything you want S3 bucket, you're uploading anything to your S3 bucket, and depending upon that, any action needs to be taken, right? So you don't have to do it manually. You just make a Lambda function and it does it for you. It's that simple. So these are some of the serverless services that we have into AWS, like Amazon API Gateway, Amazon CloudFront, Amazon S3, DynamoDB, Amazon RDS, SNS, SQS, Event Bridge, Lambda, and Step Function. So what strategies like to optimize cost while maintaining the performance, and how these serverless thing can help you? So firstly, you have to right size your function. It shouldn't be underdone. It shouldn't be overdone. It should be rightly done. So it should be well thought of, right? You have to minimize the external calls, like it is mostly based upon the API calls, which I'm talking about. So you have to minimize the external calls, minimize any unnecessary invocation. Like it shouldn't be like invocating anything, right? Because it's gonna cost you depending upon the API calls it is making and how the triggers. So you have to really thought about it and make the function more effective with that. You have to optimize the initialization overhead, monitor and tune the memory usage, like what memory you will be giving to those services. Then you have to also use the variables. It is very important. So any of the example you can take, again Lambda, you have to use the variables as a local cache. Avoid calling Lambda from Lambda. No, don't do it. Then optimize logging output and its retention, like how long the logs are needed. So logs are gonna place somewhere, and if you don't need log for that particular period of time, maybe it is only needed for a month, then don't keep it for a year, because it again costs you, because AWS is holding data for you, right? So you have to think about that as well. Then optimize function configuration to reduce cost. Obviously, these are the AWS services like Lambda, step functions are there to help you. So you have to optimize the function to help you to reduce the cost. It shouldn't be the other way around, that you are getting more cost because of AWS, Lambda, or any of the services you are using here, right? Like the CloudFront, it is mostly using for caching data to get the data really quick. So you have to think it accordingly, like how you want it be useful for you. And yeah, depending upon that, it is a great help. With that note, like whatever I have explained, it's very basic, like what services you are using there. So I think that's pretty much understandable what you got it, and you can connect with me on LinkedIn, like this my code that I'm putting up over here. So it's really lovely to be a part of the first virtual event from AWS. So I am very excited, and on that note, I want to conclude it, and thank you very much. And if you have any questions, anything, we can get it. Mike.
And kia ora koutou. Welcome everyone. This is a talk about my top 5 security tips for developers in AWS. My name is Stefan Evans and my real passion is in web development and AWS Cloud. I work for CyberCX and based in Wellington, New Zealand. And I'm not going to lie to you, it's been really cold this morning, freezing, so I'm more than happy to be inside, nice and warm, and talking to you guys online. So grab a coffee, hot chocolate, get comfortable, and I'll take you through my experience in building applications in AWS, and more importantly, some tips to help you make your applications more secure too. Right, so let's start with an example application. I've gone with something nice and simple, a serverless-based architecture, but this could be replaced with anything in the cloud. Right, so you've been working hard, you've built this application, you've got some users starting to use it. The way I've set this application up is I've used an API gateway. You could use a load balancer, something similar. You've got some business logic from a serverless point of view. I've used Lambda. You could use EC2, something similar. And then also a database. I've used DynamoDB in this case. You could use any database you like. And because GenAI is so popular at the moment, let's throw it into the application and use it along with some business logic too. So great, you've built your application, it's all set up, you've deployed, and you're going live. And this is what I thought, you just put it out into the internet, and the internet is a nice friendly place. That's your application, like a house in the middle of rainbows and unicorns. But what I soon discovered is the internet's not like this at all. It's a bit more like this. It's a bit of a scary place. There's bad actors all over the place. These are scripts, bots looking to attack your website. You've really got to protect yourself in terms of what you've put out there. So just going back to your application at a high level, I'm going to talk about 5 tips, and I'm just going to summarize them here to help you with your security of your website. So the first tip is around identity, and identity matters. So it's really important that you think about who's accessing your website and how, and also where they are logging in from. In terms of firewalls, what sort of traffic is coming into your application, just to make sure you've got good traffic coming in and you're avoiding bots and those sort of things too. The next thing I'm going to talk about is permissions. So basically, say worst case scenario, a bad actor did get into your website or your application. How are you preventing them from doing damage inside that application? The fourth thing I'm going to talk about is backups. So how are you backing up your information? What sort of things are you doing to make sure you can restore your environment if something does go wrong? And the last thing I want to dig into is generative AI. So how are you using generative AI? What sort of services are you using? Are you not accidentally giving away important information? So let's get into it. The first tip is around identity and why identity matters. What's the risk here? So the AWS console, it's great. You can log into it from anywhere, but not only can you log into it, but anyone can log into it from all around the world. So you have to be super careful how you set up your access to your AWS console and make sure that your identity is important. If you've got, say, a weak password, that's not great, because basically if you can get in, then anyone else can. And if someone does get into your environment, then they can take ownership of it without you knowing. So it's a really important thing to get right. And how do we go about preventing this? Well, MFA is your friend, or multi-factor authentication. This can really help you with protecting your identity, people logging into your environments. So MFA, it's pretty easy these days. You can get an app, you can put it on your phone. It gives you typically a 6-digit number that changes randomly every 30 seconds. And it's basically something that you have along with your password that can prevent other people logging into your AWS account that you don't want to. Next thing I would sort of recommend is a strong password. It's very easy to take the same password and use that again and again for different websites, but try and avoid this as much as you can. Ideally, get a password manager. This is a bit of software that you can install on your laptop, on your phone, and this is a central place to manage that password or passwords and make those passwords long and complicated so they're more difficult to take over. And then the last thing is creating IAM users. So IAM is a really important service within AWS. Typically people start up with their account and they just use a root user. This is kind of the keys to the kingdom, and you only want to use this root user initially to set things up because it's hard to audit the root user. They've got full access. You're much better off creating individual IAM users in that service and making sure that those users have only got the permissions to use to. Make sure those users have got MFA and strong passwords. And this will help to make your identity harder to break and more secure. So just for the first tip, remember these things. A password is something you know, and MFA is something you have. So there's two things there. Always think about those things. And apart from this initial setup, I would not really use the root user unless you need to use like a break glass situation. So definitely set up IAM users and only use your root user if you need to. My next tip is around firewalls. And why do firewalls matter? What's the risk there? So when you launch your website, you've got to expect the unexpected, particularly around bots. There's lots of scripts. Just a recent example with one of our customers was we spun up they had an EC2 instance spun up with a public IP address. And while doing a check over that, I noticed there's all sorts of traffic coming in from all over the place. And these are common attacks. Basically, this could be scripts. A good example is brute force. And a brute force is basically bots from around the world coming into your environment and trying various different usernames and passwords to log into a, say, Unix box that's exposed. And if they get in there, then they can start jumping around other areas. So it's really important to put firewalls in around those sort of environments. Another common attack is something called a SQL injection. Same sort of idea. You've got basically bots running SQL queries on your website, potentially getting into your data, either stealing that data or changing that data. And that's a pretty common attack too. And the one you've probably heard a lot about is DDoS attacks, or distributed denial of service. I like to think of this as basically having a house where you've tricked a whole bunch of couriers to turn up at your house at the same time, hundreds, thousands of couriers, and they've taken over your front lawn. You can't get in and out of your house. It's a similar thing with a website. So these are, again, automated attacks set up from around the world to take down your service. How do you prevent these things? This is where services like AWS Cloud can be really helpful. So AWS CloudFront, is a CDN, content delivery network, and that's it. Basically, the idea is it sets up servers throughout the world to prevent these sorts of attacks and basically stop bots and other machines sort of slowing down or closing down your environment. Try and limit access as much as you can for your users. So if you're expecting, say, your users to come in from New Zealand or Australia, but not other countries, try and limit access to those users. And how do you do that? Well, AWS WAF, or Web Application Firewall, is super helpful for this sort of thing. AWS WAF, you can put on with CloudFront, you can put it with your API gateway. Super helpful for checking for common attacks. And also you can limit your user base to certain countries if that's where you're expecting your users from. So just remember firewalls. Don't just expose your app and hope. Use things like AWS WAF and AWS CloudFront. to help protect your environment. It's definitely worth it. One of the cool things about these services, like most AWS services, is you pay for what you use. So initially you launch your website. If you're not getting as much traffic as you're expecting, then you won't pay as much. So it's definitely worth setting this stuff up. Right, tip number 3 is permissions. So what's the risk here? So let's say worst case scenario, a bad actor's got into your website, into your environment or your environment, AWS environment, and they're starting to play around with things. What sort of damage could be done inside your environment, and have you got good segmentation? And what I mean by segmentation is if one component of your website can talk to another component, say an application can talk to a database, but nothing else, that's generally good segmentation. You're separating things from each other. So to sort of prevent problems inside your environment, we tend to look at how different components can talk to each other. So starting with networking, you can use VPC or virtual private cloud and subnets. So a really good way to do this is, say, put your database in a private subnet isolated from other areas, so only your application can get into it. This is really important and comes about in your design. Also security groups. So the security groups are basically like little firewalls around your instances, and they can block traffic coming in. They can expose certain ports, and that prevents other traffic coming in. So if you're, say, got a database and you're expecting traffic in from a certain port, then the security group should be set up in a way that only expects that sort of traffic coming in. So just trying to focus on things. Another cool thing about security groups is you can set it up so traffic only comes from another security group. So if you've got your application in a security group and your data in a security group, you can just segment both of those, which is pretty cool. So really think about those sort of network setups and what traffic can get where. Going into permissions and IAM, the really good thing about AWS is you can get granular permissions between services. So only some services are allowed permission to others, and you can set this up with roles and policies. So I'd avoid wildcards as much as possible. I know when you're first developing and you just want to get things working, it's easy to put a wildcard asterisk into a policy just so one service can talk to the other. That's great, but it's not great if an actor gets into your environment. So you really want to tighten up those permissions. You want to remove those wildcards as much as possible. If one service wants to talk to another, just keep that tight as possible. Only allow permissions for what you need. So just remember, with permissions, use VPCs and subnets wisely. Make sure that your database is in a private subnet, not exposed to the world. Use VPCs as much as possible too. Also, just be mindful of that network design. You're not going to get it right first time, and like anything, the more you do it, the more you learn about it, and basically you gain experience with it. Tighten up security groups, only allow traffic in on ports that you're expecting it from. Again, this makes a massive difference for reducing access. If you have to access an environment, just make sure you use an IP address range which that suits for you, not just opening that service up to the world. And then just the last tip to remember on permissions is tightening up those IAM policies. If your EC2 instance wants to talk to a database, specify that database. And my fourth tip is around backups. So what I recommend here is if a bad actor gets to your data, what do you do to make sure that that's been backed up correctly, and could they delete that data? And worst case, could they get hold of you to hold your users to ransom with that data too? So what So it's really important to back up that data. How do you prevent this sort of thing in terms of access to data, deleting data from bad actors? There's a really good service called AWS Backup, and that really helps with backing up your data, particularly with DynamoDB. There's a lot of really cool things you can do in terms of backing up data, potentially restore that data into another environment, and that sort of saves that hassle. I'd also recommend using infrastructure as code as much as possible. What happens if, say, a bad actor does get into your environment and then they basically destroy a lot of your components? Well, that's not cool at all, and that's when you want to make sure that your infrastructure can be redeployed quickly as required. Also think about the types of data you're using. So if you've got critical business data, you're protecting that, and that's specific to your environment and your application, great. But what happens if there's data that you don't really need to get hold of, and you can store somewhere else? This is where federation for users can be really helpful. So if you want to share your access with other users, you can federate across. So one thing you can do is basically federate or sync up user access with, say, Google or Microsoft. Let them basically manage the user to log in, and then you don't have to worry about that user data. Same with, say, credit cards and the like too. If you can find a third party to manage credit card or really sensitive data, it's really good to offload that, and then you don't have to worry about it. And then just the third thing to sort of prevent any sort of concerns with backing up data is encrypt that data the best you can. AWS KMS keys, which is key management service, is really helpful for encrypting data, and there's different forms of that, but basically it means it's an extra layer to keep your data safe. So just remember those tips. Backing up data, super important. Ideally, you want to restore that data and test it in one of your test environments. Make sure you obfuscate any sensitive data when you do that. So that will basically test a restore, which is really important when backing up. And then also use infrastructure as code as much as you can. So it's a bit of a hassle to start with, but once you get the hang of it, it's really useful, and you can then deploy your application to any environment you like. So worst case scenario, if your environment was corrupt or taken over by a hacker or bad actor, then you could restore that environment and data into another environment and bring your service back up again. Really think about types of data. If you've got users logging in, federate off to other providers, these identity providers. Basically do a full-time job of managing your users' sensitive data and about their identity. So offload that as much as you can, just focus on your data. Same with credit card data too. If you can find a third party, you really want to keep that stuff safe. And then the third tip is around encryption. Encrypt your data as much as you can, particularly sensitive data, and using AWS KMS can really help you do that. It's really useful. And now just for my 5 tip, let's talk a bit about generative AI. So why does Gen AI matter, and what's the risk here? Well, it's obviously relatively new, and more apps are taking advantage of generative AI. And why wouldn't you? I mean, it's amazing capabilities. You can connect into it from, say, your Lambda or EC2 over to something like Amazon Bedrock. Really easy to use with an SDK. But there's also a lack of awareness with this type of technology too, and it's just something to be mindful of, that you're not basically uploading sensitive information to other environments by mistake. So to prevent this sort of thing, you've just got to be super mindful of what sort of information is going and where that information is going to. So really think about, hey, if it's generic information, that's cool. I can jump into ChatGPT, I can ask some queries and things like that. But what happens if it's information about my application or my users? Am I sending that data up to ChatGPT, and who knows where that could be going, or some sort of third party? So this is where tools like Amazon Q Developer come in, and Amazon Bedrock. So Q Developer for me has been an amazing tool. You can keep it in your IDE as you code and ask it questions about your specific application. And the good thing too is you can connect it into a AWS account, so you know that it's safe and you're not sending your data off to somewhere else. So just be mindful of that. It's really about the types of questions, the prompts you're asking AI, and the results you're getting back, and what sensitive data you might be sharing with that AI model. Same goes with Amazon Bedrock. Fantastic, multiple models you can use in there and connect to quite easily with your application, and it's also in a safe environment. So I recommend those two things when working with sensitive information that you don't want to share publicly. And then the last thing is around RAG, or Retrieval Augment Generation. And that's really a way of taking a model but augmenting that model response with additional information that might be sensitive to your organization. So if you're, say, bringing in stuff from your internal documentation, basically Amazon Bedrock can help you with that in terms of bringing in using RAG to provide sensitive information, containing it within your application. So just remember, be smart about where your information is going. Just use common sense. If it's generic questions, great, no problem. If it's sensitive data, I'd recommend using services like Amazon Q Developer and Amazon Bedrock to keep your information within your AWS account, so it's not shared with other parties. And again, just be mindful of those things, mindful of that information. So let's just go back to our application. So you've launched it. It's going really well. It's a good setup. You've got real users using it. Hopefully through this session, you've just learnt about these sort of 5 tips that can make you think a little bit more about security if you haven't already. The first one being identity. How have you set up your passwords, and are you using MFA? And are you using the IAM service? So hopefully by now you've set up strong passwords. You started to use MFA to protect the identity, so it's not easy for someone else to potentially log into your environment. Next one was firewalls. So just being really mindful of the traffic coming into your website and how you can protect it. You don't want to expose your services directly to the internet. You want to put things like AWS CloudFront and AWS FAF, the WAF, Web Application Firewall. Start using those, try them out. They're not expensive, that you pay as you use them, and they can potentially prevent some of those common attacks around brute force, DDoS, SQL injections, all those things that are pretty nasty, and you just don't really want to have make yourself an easy target. Third thing is permissions. Have you still got wildcards for all your permissions and your policies? Have you got all your security groups open? This is a good time to tighten those security groups up. Make sure your subnets are appropriate, and also that your permissions between services are as specific as you can. Go for least privilege, only the privileges that you need. It's not too hard to just go through, tighten things up, make things a little bit tighter, so if a bad actor does get in, they can do minimal damage inside that environment. Fourth, you started thinking about backups. What happens if I lose that data that's coming in from my users? That would be devastating for your web application. So start looking at tools like AWS Backup. Really easy to use, integrates well with most of the AWS services. And it's growing every day, just makes it so much easier. And then also think about testing a restore of your backup into a non-production environment. Just check, if worst came to worst, could you recover your environment? Recommend you use infrastructure as code to rebuild that environment if need be. It's more work up front, but it saves you more time later on. And then the last thing, if you've introduced generative AI into your application, have a think about what services you're using. Again, Amazon Bedrock's great for that. It integrates well with other services, and just make sure you're not uploading sensitive information, potentially through up to a third party through that LLM. Just be mindful of what you're using and how you integrate with those types of services. So I hope this helps. I mean, when I started developing in AWS, I didn't think about much of this stuff at all. And in terms of being a developer building, that's what they do. They build stuff and they get it out into the environment. They don't really think about security. And I'm just hoping with these 5 tips, it's just sort of made you think a little bit about, how my website's working, but what happens if something, if it gets hacked or there's some sort of cyber attack, what sort of things can I just do to tighten things up, give my web application a good chance in an environment? It's definitely something to think, particularly from a developer mindset. These are typically things you don't consider as much. So not only are you building great applications in AWS, but you're making them as secure as you can and starting to have that security mindset. So thank you so much again. I'm open to any questions that come through the chat. It's really nice to talk to you and share my thoughts on this Sunday. And again, please reach out to me. I'm on LinkedIn, and then I'm also based at CyberCX here in Wellington, New Zealand, and my name is Stefan Evans. And thank you very much. Have a great day.
Hey, hi, everyone. Myself Avinash. Myself Avinash Shashikant Ravi. So I am a AWS community builder and youth leader of AWS Bengaluru. Also, I do a couple of activities like Community One, and I work as the senior staff engineer at Newship Technology, where I'm working on some building some healthcare products. And today I'm going to share my learning in terms of by building a product, why I came across with the specific ECS service connect and how it came across. Also, that's a kind of small journey I'm going to talk about it. With that, not take much time. Let's start with the actual presentation. Yeah. So let's start with the some kind of thought experiment, which I actually also gone through a similar way, right? So let me take you through. So, a quick question, like, how do you wire the multiple services? When I say multiple services, like, right? So, if we have a public endpoint which is running on the one ECS task and some other internal services which can be a parallelly or asynchronously working on, right? So, those kind of things I'm mentioning about the multiple services, right? So, how do we, in general, wire? There might be multiple reasons, like either you use environment variables within your service URL, like you hard coded those values into environment variables, and these are the URLs, and you connect it to each other. That's how the first approach in the we use it. Then we might spin up some internal load balancer, which doesn't have a public access, but it has internal connectivities will be there. Okay, that is one of the things will be there. That's the way you can have the expose the DNS and which can call the DNS through the services. Either you manually manage a host name in a config file. That's another way to do it. So these are the things which we generally do a wire up multiple servers, right? So let me just twist the mode here. So the thing about it, like I came across with this post, I think recently only, and it is almost like 5 years old post where somebody's asked about like, is it possible to communicate the A and B through the internal endpoint? Like, so this is the one thing which where something was not there. If you are going to talk about it, so they have asked, okay, they have some services called graph services, portal, and everything, and they wanted to connect those internal services, like service to connect handshake. I think you might know about it, how Lambda talk to each other by either by SNS, SQL, or Lambda to Lambda triggers calls, right? That is how the expectation in a ECS one was there. That's the major part, right? And this is how exactly things were started also only 5 years back. So in 2022, AWS launched something called eService Connect, which is the right away and what you can say the right approach to have a native way to handle the service to service communication in ECS. And that's how the news which they have launched is like around 22 back. I think still you might see this is the old news, but yes, many people doesn't know about it. These services help and how it can be. That's why we are going to talk more into the this part. Before you jump into that, right? In general, like we have seen that, like how do you wire the services? There are multiple approaches, which I have mentioned three only. There might be multiple approaches to the wiring out because uh, inside the AWS, we can find out many ways to do it, like using that. But there are few some classic dilemma will be there. Like first is like environment variable, where you set up the variable which work until it doesn't work. Sometimes it have to maintain for each and every services, not services, is for each environment. So you maintain those each environment variables in your ECS task definitions or all this part, right? Second will be public ALB routing, like sometimes you use the internal, but still use the public one to connect with that. And when you go to the ALB one, obviously, it has a cost attached to it because it's run continuously, right? It has a cost attached to it. Then internal ALB also adds some cost around that. So again, that's the dilemma to choose it. Obviously, if you want to go through the internal service terminal, you have to use some other way, like using the lattice, some other way, pointed out. You have a private IP to the CS star, register to the IP somewhere else, and then connect to each other. And when you restart the container, you may have landed into that. Okay, I need to update back that IP address, right? That's how the complexity will come out, right? So in general, whenever you're setting up something on the ECS task, where service to service task want to do that, the basic things generally people will have that in a dilemma. So what general basic need is like service A is there, service talk to ALB, target group, and service B, or it can be something else, right? So problem with the approach is like, obviously, don't look at the number of the $20 month per ALB. It can be wrong also, but it is the X dollar per month ALB, number of internal services. Second problem will be extra network hop for the every internal call. So you have to, when you use a DNS call, it goes to our network and it call has. You have the extra loop to go that one. Then obviously the managing target group, health check, routing rules, and blah 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 will be there. Along with that, obviously the single point of failures and service communication. So reliability is also very less in that approaches, right? So there is one thing is failed, you're gone. So that is how the major current problem look at. So we have seen that what you want to wire it, how you want to do it, and now what was the problem with the current approach also, like without the service connector. So how evolution of my thinking also goes. Like when I actually landed on the track about the question and how I came across with the service connect, which I was also not aware about that. Even if the release is a 4 year back, right? I was not aware about it. I'm using the successful data day in day out, but still I was not aware of. So I also landed on a similar way only, and that's how the evaluation thinking might start. So let's start like our human evaluations. So 1919, like I used to use the environment variable for, and that's how I use it. Then 2020, maybe I might need service discovery solutions. 2021, maybe I'll use AWS service discovery. That's how the start things work. And when we came to the 2022, yeah, that's how the service things connect to us. So let me just, I think slides. Yeah. So how exactly really work? So now we've gone through the how thinking will go over, right? How really it work? I put up some notes from my diagram. Sorry for that, my handwriting. But yes, take example of any services. Like now I'm taking an example of I'm building a social media app which has the I'm going to create a post. Which post has the text and the images. Okay, so you start from the client, you draft your post and attach the images or video or whatever it is, and you post it along that using the API, which actually talks to the public ALB, which will be a post API, which has ECS task, which is the public one, which does the work of writing the post. When it's writing a post, it's writing a data into DB or the S3 or any NoSQL database, whatever you are going to use, right? That's the general behavior of the post API, which will do that. But along with that one, I do many other tasks parallelly, not parallelly, asynchronously, because I don't want my user to wait until the other things are finished. So when somebody posted on the social media app, the immediately API should respond back with, okay, you're done. Your post is live. But there are other things like, suppose I have to reduce or decide the sizes of the images to serve on the mobile and desktop on the low network. So I will choose a media hyphen processor as another ECS service under the another task. Okay, not in service, another task that will have another service will. So how internal service will work out. Second will be whenever the post is getting saved, it should go to the all fan out. When I fan out, right, whoever following you, it should push to their feed. Okay, that's the second service will go there. Third service will be kind of notification. So somebody liked, somebody commented, whatever, right? Before that, actually your post is live. Okay, that notification you can do that. I think you might be using the Instagram and LinkedIn, you know that when you post something, you get a notification, your post is live now, right? So those notifications will be another next level of the services. So these are the internal services. So I'm just taking an example to have a better understanding where we're going to talk it. And when you also correlate a similar architecture in your product or in that, you know that, okay, where I can use the ECS Service Connect. So in this case, the media hyphen processor, the feed hyphen fan out, and notification service are the internal services, which doesn't have a public endpoint and doesn't export to the public all the internal backend process, which need to be asynchronously work. Okay, so this is the high level diagram. So let's take example when we're writing the code before the ECS Service Connect was there. So you used to write this is a Python code. I'm a big fan of Python and PHP, so I use the Python as example. So example of OS environment.get payment service or something like that in the localhost 3001 the port number, and then you give the response API back. After the service connect, it has little change, so you don't need to do much things. Like you just simply like HTTP payment service. So as we seen in last example, it was their notification or feed hyphen fan out, right? Those you can do it. So HTTP:// feed hyphen fan out / whatever API in the custom route you're putting in, and that you can use it. So with this one, you can directly connect it, and you don't need to manage the different environment variable because it's a purely based on ECS. So ECS has the one feed hyphen fan out the services, right? It will be same name in another environment also, another QA environment or a production environment also, right? So you don't need to maintain those URLs. Automatically the services will call will happen. How exactly actually work it? So this is the official diagram from the AWS blog also. So I did not put up my different diagram because it's a very clear diagram. So user A, as we discussed just now in my drawing, one of the drawing, right? User A come, it goes to the elastic load balancer, then it's landed to the EKS one, where we have a cluster with the cluster running as service A, service B, service C, and D. There are multiple ones. It actually talks to the service connect. So there is a specifically service connected option is there. So using the cloud map, you have to connect their one. I'll walk through the steps, and it will give you what you can say the names, what you want to have call it out the connect name. So a dot service is basically connect like that. We in our case, the feed hyphen fan out or notifications can be there, or the multimedia processor, and each has a port attached to it based on the what processor is using it. If you have a socket one, it has a different port. If you have the normal HTTP protocol, it has a 81. And it has this is registered under the cloud map under the namespace of. So whenever you create the entry into cloud map one, it will generate that virtual name which can be used to service connect one. That is simple one. So do you think it's a complex one? It's very straightforward. You don't have to do much changes in your ECS infra if you are currently using it. Just go to the cloud map, create a service entry, just map it in the code, update the code to talk to each of the API calls and the HTTP calls over the public endpoint or the internal endpoint. Just map it to the virtual world. That's a simple change you have to do it. You can see that the payment service, event services, and user services can be used like that. The mapping will be there in the cloud map. So what it takes to set up this one? So you first define the cloud map namespace that's called app.local. In our case, feed hyphen fan out, or maybe app.social media network / feed hyphen fan out. Whatever your convenient things are there, we can define the cloud map namespace. Then you add a service connect configuration to your EC service. So each service has the option to go to select one, select service and go to one, and you will have the options to that to select this particular service connect map. Then you register each service with the port name so that we know what are going to use it. And then set the one client only server or server. So it has options called either you can choose the client only network or you can have a server. Okay. In one of the use cases, I remember I was reading around that one of the fintech company, I use the Redis server as the backend server. There is no client information was there, so it was exposed to do caching around the background, and whenever the API endpoint was the fetching details, it was taking out the caching. Like, so instead of doing the on the fly when the request comes, right, it went right in the cache, it was doing in the background. So that's how it really. I have given links in a reference section later. You can take a screenshot. I'll share into chat also. This is generally we take to set up the things. I think AWS has wrote a very good blog on how to do it, so you can always use those. So when it's coming to because when we do a architecture design, right, so you always have to know that before what is it's giving, like in terms of that, not what is not giving. So other side of angles. So I want to focus that also when not to use Service Connect, because we have talked about the use cases, we have talked about the social media network example also where we can use it, but it's also important at the same time to understand when not to use the Service Connect, right? So when you're doing external service communications, like EC to EC2 communication, only like only you're talking around the HTTP protocol over the public internet, that doesn't need to have used the Service Connect, because as I mentioned, it's purely only on the internal Service Connect handshake. So it is like you have some private phone in your houses, right? You talk to the only family like that. Or another example, in your apartment also sometimes the internal intercom will be there, right? Those only allowed you to talk to the flat to flat. But if you want to talk to the outside of the apartment, it doesn't allow it, right? That's the simple anomaly you can use it. Okay, so when you read that one, that should avoid the Service Connect one. The second part is like obviously that when you're doing a cross region communication, currently not about well, and you can use it. So Service Connect work with a single region currently, and use the API gateway or maybe a direct LB call for the cross region. When you are dealing with the legacy service integrations like service not running on the ECS, can't participate, consider hybrid approach for doing migration, that you can use it. When you have a complex requirement, like you want to have very diversified traffic diverging also, which you want to split based on the simple load balancing tactics, let's not use that there. When you have complex application according to the rule, let's not use it. So I'm still not used in my productions one, the real one, but it is actually learned from the couple of blogs which people has already used it, and those learning from those. Obviously, I'm going to share the ones we have. I also implement in the real way. So what's the migrant strategy will be look like, right? So you have internet services, like as you sort out, right? Just keep in the mind the anomaly of your apartment intercom. Same way, the internal services service connect work well. Keep LB for the only external traffic. No LB for the internal traffic so that you can save the cost. Yeah. Disclaimer here, Service Connect also come up with some small cost, but still it's much better than the ALB. And Cloud Map record is free for Service Connect on the ECS one. Obviously, when you gradually upgrade and have the different services, that time you can choose that option to go or not go. That's a simple strategy. We can use it. So how do I will start it? Like if I want to do this, my already code already available in ECS target and task using the Flask one. So how do I do it? Right? If I'm already doing the microservice based architecture, or if specifically services are divided in such a way that it can be separate out. Let's see how it works. So begin with the internal admin tools. Give a try on your internal admin tools or any tools which is the background running processes. Use that one. graduate to business critical services, and slowly move it to the critical services which actually are required. Internal communication currently might be running on other way of around that. That is all. Don't directly jump on the doing the every implementation, and that's what I am also going to do it. So I told you, right. I'm also building a similar kind of social media platform. So I will not go for all the critical services. I will go which the non-critical one which require that. So like if suppose somebody admin approved a specific content, that might be I can use it. So that's how you can have a small, small baby step to do it, and then go to the next level to have a adult level of changes. Monitor extensively during the transition. Make sure that you're monitored properly. And as the quote says, don't bait the farm on your first attempt. Like, as I said, start with the small services, start with the internal admin tool. Okay, this is a very important thing which is clearly recommended also, and I'm going to use it similar. And obviously, you are also going to use similar when you are building using the easiest task service connect. So some critical checkpoint you have to add it because it has a kind of failure mechanism also. So make sure your grace period seconds will be 10 seconds for the too aggressive services, which like just go and finish the work. Okay, like this notification. Some might like image processing where you are taking the image from the social media post, right? And you are dividing those into the multiple different resizing mechanism, which might take time. Or if you are uploading a video which wound up some processing using the FMG package, which required a huge amount of time. Based on that, you can check your health check rate. Don't just blindly follow 60 seconds or maybe 100 seconds. Like follow based on what is the need of your task and then set that health check one, because health check is very critical in terms of knowing that your internal services are running enough, because here your endpoint will not be there in public. So you can configure into your monitor system like any other New Lake or any other platform if you're using it for the monitoring, right? Or ping them, right? You can't do it. That's how the major critical part is to focus on the healthcare, specifically based on the how much time is required for your service to finish. Right here and there, yes. What's the naming convention? Obviously, naming convention very critical, play critical roles into that one. Don't use a specifically AWS service name basis. Obviously, something might already exist, so let's not do it. As I said, it's a bad services practices. Don't use SQS hyphen processor. Use a specific to your services. What is it that you're doing? Like as I mentioned there, here also order processor services. In my case, which we are displaying just now, is like fan or feed fan out notifications or multimedia processor, right? So accordingly, you can choose the specific name because that's how the will easy to connect it. Otherwise, if you get collagen with the existing naming convention, it might break your service. Right? So even if you look like okay, this is something is simple one to a fan out, but a simple one sometimes make a bigger mistake. So that's why I wanted to highlight this one. It's a very important part of this. Obviously, you have to set up the monitor. So CPU, memory usage, you should set up the monitor connect and using the service connect agent so that you monitor that how it exactly is scaling, how exactly is working it, so that you use a right scaling mechanism and task placement that is there. And use the connection push analytics, retry and circuit breaker methods also to know that is there anywhere where circuit break is happening it or task getting suddenly drained out due to some other issue, not able to connect it. Because when you break your internal services suddenly, right, you might lose some of your backend services. You have to make sure that your cloud watch and everything is placed in the right way. So enough of now the explanations about how it does, what can we do, how to do it, and what is the best practice to use it, like that, right? So who actually using it? We might be surprising, right? Wow, like if somebody is using it, right? So one of the best use case which I came across is like Open Healthcare Network, the backed by GitHub one, which heavily use this Service Connect, and they have mentioned in their article also where Service Connect simplify their configuration management, which reduce the architecture complexity for them. As I mentioned, what is the complexity was there? It was earlier was like ALB and public endpoint, internet provide cost and blah 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 blah, which were there. Which along with that regarding pricing, Service Connect is a cost effective as they have said that using the cloud map. And it, as I said, right, cloud map is free to along with the Service Connect. So it removed the ALB for the Redis. They have cut down the cost and simplify all the internal entity. This blog is available if you want to read about it. Their services are already available. I will give you the link in the reference section also. But very interesting blog they have talked about it where they are using it. And along with that, there are few couple of financial solutions also built using the service connected, which they have claimed that because of the by default TLS and MTLS one connection, they were able to make it a very smooth transition. This is the real world case. I did not mention my case because I still had to develop it. So to be on the more realistic side. So I think that's how we are coming to the slowly to the end of that. So why this matters and what is the final takeaway we can take from this one, right? So as I answered, top blind following. As I said, top duct taping service communication. You don't need to really wire. It's a service with the ALB and variable fragile DNS anymore. The easiest service connect is your the good friend for you to communicate with the internal services. Service Connect has a built-in security also. It's cost effective, as I said. It is not huge compared to the ALB one, but it has the cost effective approach. Obviously, native service discoveries, health aware routing are there, as I mentioned that. IAM control is there. So, as I mentioned, no extra infrastructure. It's simple setup. You just set up, as I mentioned, right? Go to the cloud map, set up the call configuration, just go to the ACS one, connect using the service connect, and choose client or server, and then you're done with the work. You do not need to change your existing infrastructure much. It's small changes. So start small, scale clean, as I mentioned. Start with a small internal one. So that's how you have to do it. Service can be used for the internal traffic majorly and migrate gradually. And that's how you develop experience and open up the benefit for the client. Where you can try this. Okay, so simple things, like same thing. I'm repeating again and again because that's the more important part when you architecting, when you try to jump on a specific thing, when you hate something or other, right? So do you use HX service need to talk to each other internally? So figure out in your architecture design is of any of the services are internally talking to each other. Any of the services are heavily loaded currently, are doing more than what's supposed to be do. Like suppose if you only the right is important at the time, so you can use it. Are you aware about like maybe a cap theorem? It's like consistency, availability, and I forgot about P. But based on that, so whatever is needed on a real-time basis, only keep that logic in that particular API and remove all the logic to the background process so that it can run on silo. Okay, and that you can design such a way that internal services which can talk to you in the service connect. Or are you spinning on the internal LB for just for internal API? Then you can do a if you're doing a manually updating service, you are doing a deployed, then you can try it out that. And do you want to build any health aware specific services or discovery, like any internal? Whenever something hit, just call any services that you can build using the service connect. Also, there's a small use case of service connect that you can. But majorly, I mentioned right, you can note down what is required in services and then figure out okay which can be intra services and cap and beam. So you can just do that using the ECS service connect. Yes, and obviously I say that try ECS service connect. I'm going to try it out. I'm really excited about this one. I think hopefully in coming days I'll be publishing the blog also and like what was my takeaway on the overall this one. Let's try service connect. So these are references. I'll share in the chat also, but you can take a photo if you want to. Take a screenshot of this one. So this has a blog about the OSG, how they have built service connected. This has a blog about deep dive into the service, which I have gone through on that. I talk about the fintech use cases, right? The 5XL IO, they are doing lots of the ECS based building application. And they have very interesting use cases about using the encryption for the MLTS using the service connect. And obviously the AWS official blogs about that, how can we use it. how to roll it out. That's why I did not cover the how to step one, because it's already available. I make sure that I try to give the insight which can you take away and try to utilize in your use cases. And with this, I'm done with my talks. Thank you so much. It's a QR code. I know it's on virtually can't scan a QR code, but I think you can search over the LinkedIn or in social media, the Arena the full stack developer. You can find out, or you can follow my YouTube channels and Instagram account, AWS Product Builder, where I actually talk about AWS Product Builder, because I came from the full stack developer, product building, startup fan. So I keep on inventing how AWS can be used for the building the products, for the cost-effective scaling point of view, how easy can be a developer point of view, right? I keep on sharing many things there, blogs and the videos also. You can stay tuned to that. With this, I think over to host. Thank you.
Hello everyone, this is Rahul. I'm based out of Texas, USA. I'm a network engineer, delivery manager, working in Kairos Technologies. I've got about 12 years plus experience in the infrastructure industry. And today I would like to talk about AI and ML integration into the modern infrastructure. So yeah, here's my presentation. It's basically, and it's how do we integrate AI and ML into the network routing and explore more ideas and benefits, advantages, and also some of those disadvantages while we integrate AI into the traditional networking. So I'm going to talk about the little bit of the foundation, implementation, security, integrations, and kind of a little bit of the future roadmap. If anybody wants to, take this route and implement AI, ML in the in the traditional network environments. So let's talk about the evolution of the network routing. So in this context, we basically compare the traditional with the ML enhanced routings. In the traditional network routing, it's more of a everything is manual based on the requirements. Like you configure static configurations with more limited adaptations or and predefined metrics, so you know what's the max you can configure and based on the current hop counts and the bandwidths, and also reactive to the network changes, and everything, all the protocols such as EIGRP, BGP, OSPF, they basically rely on the fixed algorithms rather than any uh, predictive uh, uh, predictive and adaptive learning patterns, which we look in the ML enhanced routing, and periodic route calculations, which are more traditional. When we compare it with the machine learning enhanced routing, the decisions are more dynamic. Decisions are basically done mainly on the real time data, where it's more the models, AI models kind of learn the pattern of the route, the traffic, and adapt to that particular patterns and make decisions rather than just following the static configurations which happen in the traditional network routing. And mainly a lot of companies face this congestion issues when there is a lot of traffic in the network and their application don't work. So here in the ML enhanced routing, everything is more that the models learn and kind of predict and adjust the routing and adapt to the current requirements. So there's a very good predictive congestion management, and it more is like self-optimized, no manual intervention required. It will it will adjust the performance based on the traffic and refine the congestion. And so the AI driven, how AI driven routing works. So as in a traditional network routing, everything starts with data collection. So even in the ML based ML and AI based routing, it starts with the data collection, like network telemetry, traffic patterns, performance metrics, and historic behaviors are learned and kind of stored in the brain of the module, and they get trained over the period of time. It's not like you implement this and everything's working. Definitely there are some of the standard learned models which actually work, but every company is different, every client is different, every requirement is different. So even though when we implement the pre-built models, the models have to learn the way the traffic patterns and performance metrics and the behavior, and then optimize uh, their paths. So that's where ML model training comes in, where the modules learn optimal paths based on multiple variables and performance outcomes, and then the performance analysis. And the continuous monitoring and model refinement based on the actual network performance. So same thing, it takes time for it to actually analyze and monitor and try to develop the patterns which are suitable for the business, and then take the intelligent path selection by the dynamic routing based on the optimized way of the optimized taking the optimized routes with the conditions, with the predictive insights and analysis. Unlike the traditional protocols that use fixed metrics, ML-based routing leverages complex patterns and recognition to optimize for multiple objectives simultaneously, which is really a groundbreaking and a very useful for a company which is adapting this technology. And technical advantages of the ML enhanced routing. So like we spoke about earlier, adaptive congestion management, which is the most important, in finance industry. Every microsecond counts with as the transaction happen. So as like millions and billions of transactions happen at a time. So the congestion management is really, really important. So the predictive rerouting of the traffics before the congestion occurs based on the historical patterns and real-time indicators happen like a flick of a second. And the multiple objective optimization simultaneously balances competing metrics like latency, throughput, reliability, and energy efficiency. And anomaly detection identifies this is a really important and very, very highly sorted anomaly detection, because there's a lot of threats and unusual traffic patterns which may be observed in the traditional environment. So here the AI model basically learns and identifies the unusual traffic patterns and kind of flags it, and either it reroutes the traffic or kind of blocks it from the security threats. And application awareness routing. So in the traditional, we kind of prioritize and put the preferences on the how much traffic or how much bandwidth is required for each application, but here it prioritizes itself with the requirement and the business importance. These capabilities enable networks to dynamically optimize for specific business objectives rather than purely technical metrics. Early implementation experience by the industries like financial services. So most important is the low latency trading networks. So so any latency in the financial services will lead to lot of losses. So it's a really, really regulated industry. So we need to be careful when we are dealing with the networks and everything. Here with the ML models, the latency is if there is any latency that can be observed by the patterns, the before the latency occurs, the routes and the optimal decisions are taken by the ML model. And and then the regulatory compliance requirements, high security security and sensitivity. By adopting the ML model, 46% reduction in the transaction latency is achieved. In the manufacturing industry, IoT device integration is the hot topic in the manufacturing industry. A lot of the manufacturers are using IoT devices for manufacturing or packaging or any sort of any sort of manufacturing things in the real-time production system. So by adopting the ML AI-based routing, 38% improvement in the network reliability is achieved. And in the healthcare, the data life critical applications are used, and the data immediate access of the data is required, and the lot of medical devices are integrated to the application. So by adopting this, 52% faster access to the data is achieved. Convergence behavior, and we're talking about the convergence behavior, traditional versus ML based routing. Traditional convergence, fixed algorithms with predetermined update intervals. Average convergence time is 5 to 30 seconds. Uniform behavior all across the network events because everything is manually configured. There is no predefined patterns learning, or everything is based on interpretation or previously observed network patterns by the network engineers, which may be sometimes work, which may don't work sometime. So, but in the ML enhanced convergence, it's more adaptive and adaptive, and it's more optimized based on the patterns which the ML model has learned. So the average convergence time reduced from 5 to 0.5 seconds to 10 seconds. So by handling the prioritized paths, ML system can prioritize critical services paths during the convergence, maintaining essential services while recomputing less critical routes. So it's like every technology or every new cutting edge technology or anything, there is always a challenge and cons. And same with ML based routing also, we have some security challenges. So adversarial attacks. Attackers can deliberately manipulate the input data to cause the ML model to make incorrect routing decisions. And data poisoning, introducing malicious training data that causes the ML to learn harmful patterns, which may impact the business and also cause data breach. And model extraction, interfering with the ML model's parameters to predict and manipulate like its behavior incorrectly. Explainability gaps, difficulty in understanding why the model made specific routing decisions. Yeah, this happens even in the regular case scenario, but in the ML based routing, it is more evident that we never know why the model has taken this particular decision, but the researchers are still they are working on also resolving this gap, which may be resolved within a couple of few years. Defensive strategies for secure ML routing. Input validation. Apply statistical anomaly detection to identify potentially manipulated telemetry data before it reaches the ML systems. So before it reaches the ML system, any kind of manipulated data can be identified by doing the input validation and decision verification. Implement parallel traditional routing algorithms to validate ML decisions before deployment. This one may increase the cost of implementation, but this is the initial phases, so we might have to adapt this an additional parallel routing algorithms to validate the ML decisions. Continuous monitoring. Deploy specialized monitoring for ML models drift, unusual decision patterns, and outliner behaviors. Similar to the decision verification, even here we need to deploy a separate monitoring models to basically train the actual ML model so that it doesn't take any unusual decision patterns or outliner behaviors. Rollback mechanism. Maintain the ability to rapidly revert to the traditional routing protocol if anonymous behavior is detected. And organizations implementing ML routing require a defense in depth approach that addresses both traditional network threats and ML specific vulnerabilities. Integration with existing infrastructure. Successful deployments typically begin with an ML routing overlay that operates alongside traditional protocols. So any client or company adapting to the ML based routing, the successful way to implement is to implement the ML based routing parallel to the traditional protocols and gradually expanding after the confidence is increased and the models learn the patterns and try to develop optimized work paths. This approach may minimize disruption while allowing for careful validation at each stage. Most organizations maintain legacy routing protocols at the network boundaries, using ML routing primarily within specific domains where its advantages are most significant. The global case study, global financial services firm. We talk about the implementation approach in a financial services industry. Initial deployment in non-critical data center interconnects. So deploying the ML-based routing directly into the production environment is not suggested, as this is the evolving technology, and so it's more safer to train this in a non-critical data centers and interconnects, and 6-month parallel operation with traditional routing. So always, like we discussed before, always it's suggested to implement along with the traditional routing rather than going for the fully blown ML routing and gradually expanding to the trading infrastructures. Custom security monitoring framework development. So the parallel to the ML routing, always good to have a separate custom security monitoring frameworks so that there is no the ML don't take unpopular decisions. Integrating with the existing NetOps workflow. So basically automating the ML models to perform the task. So by this approach, we may get the following results, like 73% reduction in the routing related incidents and 42% improvement in the cross data center throughput. And it's an industry average cost it will save about $4.2 million. This is taking into consideration the current base scenario, and the 4.2 million is also taking into consideration like medium to large scale industries. We're going when considering larger companies, it may even be more. Evaluation framework for an organization. So always technical assessment is the key. Always technical assessment need to be performed. That the complexity of the network is to be assessed and the current pain points are to be identified, and the data need to be requirements are to be defined in a perfect manner to achieve the optimized objectives. Operational readiness. Net ops need to have a really good ML knowledge and have a good monitoring infrastructure and good incident response procedures and the change management procedure to have a successful framework for the ML framework. And risk assessment, critical service requirements, and compliance and rollback capabilities and threat modeling need to be assessed prior. By this, there is a 86% success rate. Organizations that conduct pilot implementations in non-critical segments, like we discussed before, and on an average, it takes about 12 months after the initial assessment and implementation to the production. ML model can kind of perform its optimized behavior. And the average return is 3.4% over the 3 years if the implementation is successful. And it's always good to explore and as this technology is evolving, so anybody who's like to introduce this into their clients or companies, it's really good to have a network assessment, data collection framework, and pilot planning done with a good team, investing in a net ops capable teams is really important for the ML network routing implementation. Thank you, everyone. Thank you for giving me this opportunity today, and really appreciate it. Have a great day.
Hello, everyone. Great to see you all joining from around the world. And let me start with a simple question first. Have you all written a Lambda function and a loop, actually a for loop in it, which tries to process hundreds of items, and everything is working fine, and when you, especially locally, and then when you deploy it as a Lambda function, you're trying to process probably even more number of items, and it times out, and you break your head saying, "Oh my God, what just happened?" And that is a crazy place in the moment to be in, isn't it? So today's session, I'll be talking about from Lambda loops to step function maps, transitioning from code complexity to workflow simplicity. I'm Srishit Repakula, Head of Engineering at Confab, AWS and an AWS Serverless Hero. So if you ever hit that issue of timeouts, especially when you're trying to loop something through an item, or sorry, hundreds of thousands of items, then do let us know. Now, what you see here is about maybe 20 or approximately 20 plus AWS serverless services that are available on AWS, right? Now, individually, they are very powerful. They can do a lot of things. They can do crazy things for you. But today we'll be talking about step functions. Step functions is an orchestrator of all of these services, if you think about it, right? As I told you, individually they are amazing, but when you stitch them together, that is when you get the actual final solution. And with step functions, you'll be able to do it much more efficiently, where you can combine different AWS services and be able to achieve what you want. And the first question, what is a step function, especially if you're new into this entire service? So as I told you, AWS Step Function is an orchestrator which helps you define a workflow for you to be able to execute something in a particular flow or a particular steps and manner, right? And it is a serverless service, obviously. I'm talking about an AWS service, and it has to be serverless, right? Just kidding. It is a serverless service. That means you only pay as you go, and it scales. You don't have to manage any infrastructure because AWS is going to take care of it. And that is a very big headache off our heads, isn't it? The next biggest advantage about step functions, apart from its ability and capability to, connect different services, is its ease of use. You can see it is like building a flow chart. If you have not tried out step functions in the AWS console, you should give it a try. As you can see in the diagram here, there are a bunch of actions on the left hand side, and you have the flow chart in the middle. You can simply drag and drop whatever services you want, and automatically the ASL gets built. So either you can create a step function via the drag and drop feature, or you can write it in ASL, which you can write it in JSON. And the next advantage is the built-in error handling. I mean, how many times you would have got into a situation, especially in your dev environment when you're trying something out, and in production environment where something unexpected happens, right? I mean, let's be honest. We all write good code, but it's not foolproof, or I mean to say bug free, right? And a lot of times it does happen, or you get into a situation or a scenario where your code misbehaves. It gets into an unhandled exception or stuff like that. Now, what do you do in such scenarios? Is That's where step functions built-in capabilities for error handling comes into the picture. I will be touching upon that in my slides today. And then the next biggest advantage is it can integrate over 200 AWS services. Now that is huge. You have an application, or you have an idea of orchestrating a bunch of services together. Step functions is the way to go. And today I'll be walking you through a few lessons learned and a particular use case of ours, and we can see how step functions helped us solve that particular problem. Now, before we jump in further, a quick recap to folks who are probably new. There are two kinds of step functions. One is the standard workflow, and then the next one is Express. So let me quickly touch upon the differences between the two. Standard workflows are long lasting. And when I say long, it is long. It can run up to a year. Can you imagine something that is running for up to a year? And it is serverless, unlike Lambda functions that can time out in 15 minutes. This can run for about a year. And standard workflows are asynchronous in nature and they run exactly once. And AWS guarantees that it can only run exactly once. Whereas express workflows are used or to be used when you want high throughput, when you want it to be cost effective, and you are okay to be able to get into a situation where it can run more than once, and therefore AWS guarantees at least once execution. It is generally for short durations, right? It depends on your use case. You can choose either standard or express. If you have something mission critical, or you have something that's probably going to take longer to run or execute, then you would go with standard workflows. Whereas if you have something that is okay to be, I mean, when I say okay to be run more than once, that means you have built in idempotency into your application. Then in such cases, and you are very particular about cost because you are running this hundreds and hundreds of times, therefore, and in such cases, you can go with the express workflow. And one tip here for the folks is it doesn't have to be that you can only write a standard workflow or only an express. You can always choose to mix and match to kind of bring the best of both worlds. So where you can probably have a standard workflow at the outer level, and then you can branch out. I'll be talking about a bunch of these things as we go forward, but just giving you a sneak peek, right? So when you run multiple things in parallel, you can choose those multiple executions, map states, all those things I'll be talking about as express workflows. So with that, what would happen is you bring in the best of both worlds, and you can keep a check on the cost as well. Talking about the cost, here's a quick comparison between the two, the standard and the express workflows. The left-hand side is the standard workflows pricing point, where you are charged based on the state transitions. So every step in the step function is a state, and when you transition from step 1 to step 2, that is one transition. Step 2 to step 3, that is another, excuse me, that is another transition. So you will be charged based on the number of transitions in your step function. Whereas the express workflow, as I told you, is much more cost effective. It rather depends, or its pricing is very similar to how a Lambda function's pricing is, right? It is a combination of the amount of time in milliseconds that is run and the memory allotted to it. As you can see here, it is a combination of the two. So depending on your use case, you can choose what is best, or as I said, you can mix both of them and then have the best of both worlds. Now, let me jump into what is the specific problem that we were trying to solve and how step functions came to the rescue. The problem statement is trigger payouts to event organizers and then notify them. A quick background so that you are all able to connect to the problem statement I'm going to talk about. As I told you, I work at Confub. Confub is an event ticketing platform where organizers come and host their events. Participants can buy tickets, and organizers can organize the event, blah blah blah, and at the end or on periodic intervals, Confub settles the amount or pays out the amount to the organizer, which is of course theirs, by taking a small cut, right? So essentially what happens is there are people who are buying tickets, and there is Confub who holds the money for a brief period, takes a cut out of it, and then settles the rest of the money to the organizer. A simple example, let's say a participant is buying a ticket for $100 and Confub's fee, let's say it's 2%, then Confub holds $2 and the rest $98 has to be settled or paid out to the organizer. So that's pretty much it. As you can see here, we first fetch the list of events. Seems straightforward, simple, right? Yeah, true. Fetch the bank details for the organizers. Yeah, not bad, not shouldn't be too difficult. Send the email if it is if the bank details are missing, just to make sure that we only settle to the organizers who have given us the bank details, and notify them to fill their bank details so that the next cycle they can get it. Trigger the payout API. Now we are talking to third-party services, right? So now it's getting out of completely. I mean, it's not completely only in our control. Now we are dependent on a third-party service. So we are expecting someone else to be good to us. That's a little tricky, right? And then sending an email whenever it is successful or the payout is failed. Now, what do you guys think? This must be simple. This must be easy. Yes, that's what we thought too. And if you look at it in this simple workflow of a chart, it does look straightforward. You do a bunch of DB calls to fetch the list of events, to fetch the bank details, call an API, and be done with it, and send an email. How hard could it be, right? Well, we were also thinking the same, and we could not be more wrong. So, what were the challenges? The first thing is, as whatever I explained in the previous slide, we did everything in a single Lambda function. Okay. Now, as I told you initially, when you're running locally, when you are in your dev environment or your staging, you're not really talking to production data, right? Now, everything seems to be wonderful, right? Yeah, that's what we thought. But then, as we started to make sure that it works with a simulated production environment, then we realized that we were nowhere close to what it is in the real world. The first problem is, it was, as I told you, the workflow. We simply ran it in a loop. But that loop was to be executed for hundreds of events, because there are hundreds and thousands of events that are organized on Config, and there are hundreds and thousands of people purchasing tickets, and hundreds and thousands of people, organizers to whom the money has to be settled. So the simple loop, yes, now became much more complex because we are running it over hundreds and thousands of items. And the looping logic became more complex, not because what we are doing inside, but to make sure that whenever we are looping through something, if something fails, we know where it failed, right? Because think about it. Let's say we have, for the sake of simplicity, let's say we have 100 events, right? Now we process each event, and the 56th event failed. Now I cannot stop the entire process, right? Just because there was some issue with 56th event, that doesn't mean the rest of the events may not be processed. Possibly the same error can happen to the rest 44, if my math is right, 44 events, but maybe not. We never know, right? So what happens is, in the code, we have to catch everything so that it can still proceed forward and try to complete the processing for all the 100 events. And that was getting crazy because there are multiple points of failure, right? It's not just in one place, but multiple places. And therefore, the logic was becoming complex, throttling limits of downstream services. As I told you, we are calling a third-party API to be able to make the payout. And we were throttling them. As I keep telling in my sessions, just because your application is serverless and it can scale, terms and conditions applied, it can scale, doesn't mean your downstream services or your third-party APIs can do the same, right? So you have to be aware of all the downstream services and make sure that you are not overwhelming them. And we hate that, especially because we were talking to a payment gateway and they were much more sensitive to all these things. The next problem was the wait time. So we are doing a wire transfer, a bank transfer. As you all know, it is not instantaneous. It is not like I'm calling, a third-party API or a weather API to get what is the weather, which is instant most times rather than not, right? But I'm calling a bank's or a payment gateways API, which is going to take a bit of time to process, right? I mean, the API call, the request itself may be instant, but the transfer to happen can take some time, especially in India, depending on the type of transfer that you do. It can take anywhere between a few minutes to a few hours because it is banking, right? Now, it does take some time. Now we have to make sure that before we notify the organizers that, we have done your payment, you should have received it in your bank account, we had to wait to make sure we get a confirmation from the payment gateway whether it was a success or a failure, right? Now, and then error handling and retries, I talked about it. The 56th one fails. Now, how do I make sure that 56th is retried and I'm not retrying all the other 99 other events that probably successfully processed, right? It was a big headache. And the last one is the Lambda timeout, which is 15 minutes maximum. Especially the third point, which is the wait time, was a huge contributor for to push hard this Lambda's timeout. Now, we were very easily hitting the 15-minute timeout, especially because of the number of events that we were trying to process. We tried to parallelize it. Our code is written in Python. If you're aware, we use thread pools and all those things. We tried everything to make sure that the code is executable as quickly as possible. But damn, it was not, because it was not just our code. We were relying on third-party services as well, right? And it was crazy. And that is where step functions came into the picture. And we thought, before we even thought about step functions, as I told you, we were trying out all of this in our lower environments, non-production yet. And then we thought to ourselves, now, this is not the way of solving it. There should be a better way. And then we did a bit of our research. Then we found step functions, and the step function that I'm showing you is the actual step function execution from our production environment that I've put out. I am not sure if it is visible or not, but let me try and quickly explain what it is. So we fetch the list of events, and then we decide whether is there any event that needs to be processed or not, and if it is processable, we segregate that. If it is unprocessable, we segregate that into another category. I'm not going to get into details of what is processable and non-processable, but as I told you, this is coming from production. I didn't want to change anything. There's some business logic behind the scenes. And then what we do is, for all the processable events, we run a loop, not in the code, in the step function using the map state. And then we fetch the bank details. If the bank details is not present, we send out an email reminding the organizer to add it. If the bank details is present, we make a payout. And then we wait. We wait for the third-party API, the payment gateway, to actually tell us whether it's a success or a failure. Depending on that, we send a notification. Now, I'll be talking about specific challenges at each individual excuse me, sorry for that, at individual points, and which features of step functions has helped us solve that. Challenge number one, processing for hundreds of events resulting complex looping logic. That was our first problem statement, right, or challenge. Solution is step functions map state. So what is a map state? A step function map state lets you run a set of steps for each item in a list. Our for loop, just that it's not in our code, it's in the step function, right? Similar to a for loop, but in a scalable and a parallel way. Now, what is the biggest advantage of this is you're not looping in your application code, but your orchestrator, which is the step function, is looping through a Lambda function against a bunch of inputs, and the same input is executed. Each of those inputs is executed in parallel. So what is the advantage, before I jump into that? What is the advantage it gave us was, now, instead of processing hundreds of events in one single Lambda function's execution, we are only processing one event, right? And this way, we could significantly reduce the execution time. And more importantly, I know, or I would rather know, if anything fails, and I can immediately go to that particular execution to figure out what has happened. Now, in the map state, there are a couple of settings that you need to be aware of. One is the inline mode, and the second one is the distributed mode. So depending on your use case, you will have to choose what best suits for you, right? In the inline mode, it accepts a JSON array, a proper JSON array passed as the input from the previous state into your map state. And step function will loop through each of these items. it can run up to 40 iterations as concurrently as possible. That means you can imagine that 40 branches would come out irrespective of the number of items in your array, and step function will try to process it. Let's say there are 40 running, and then let's say the third one is completed, then another one comes into the third branch of sorts, right? Enforces a limit of 256 KB on the input payload size. So your input that each item, right, that is passed to the map state can only be up to 256 KB. And then 25,000 entries in the execution event history. So if you have tried out step functions, that you would know that, that there's a history of executions, and in the inline mode, you can only have 25,000 of those as a history. Not from the execution standpoint, but if you want to go back and look what happened, you can only see 25,000 of those. Whereas the distributed mode is for much more scalable options where you have much more complex things working on. And what happens in this mode is essentially JSON array can be passed just similar to the inline mode, but you can also have a file in S3, which is a JSON file, and tell step functions that, I want you to map or loop through the items that is stored as a JSON file in S3. So you don't even have to pass that as an input to your map state. Instead, the function will automatically fetch it from S3 and loop through it. It could be a CSV file in S3 bucket, and there are a couple of options. Now, this one lets us run up to 10,000 parallel child workflows, 10,000 branches, right? Whereas in inline it is 40, here is 10,000 workflows. Now, depending on your use case, you can choose inline versus distributed, especially if you have something heavier input that you need to process, then you probably go with distributed map, where you can have the array stored on S3. Whereas if it is a smaller input, you can go with inline. And if you want to parallelly process much more items, then you probably go with distributed, or you can go with inline. In our case, we had to choose distributed map because the data that we were trying to loop over was exceeding 256 KB. We had a huge data per event, by the way, not across this one, right? And then, sorry, my bad. The workflows execution event history exceeds 25,000. As I told you, there are thousands of events where we have to run, so we need to do that, and we wanted to make sure that we had a concurrency of more than 40 parallel iterations. So this is the one single map state execution. That is, this is running for one single event, where we first fetch the bank details, check if the bank details is present or not. If not, you can branch out. So this is like a choice state, right? Where if the answer is no, then it goes to missing bank details state, sends out an email to the organizer asking them to fill their details so that the next cycle it processes. If it is there, it goes here. This is more of a zoomed in version of what I talked about, but this is per event. The second one is throttling limits of downstream services. Now, as I told you, we were talking to a payment gateway via the APIs, and because we had hundreds of thousands of events, and step functions was able to map through so many in parallel, we hit concurrency limits and throttling limits when calling the third-party API, because we were just calling too many of them. Now, how do we solve that? One is, of course, at your application level, but now in your application, you can't do it because in your application is essentially, when I say not able to do it, not easily able to do it, because we are now running one execution per event, right? So this execution is not aware of the other, this is not aware of the other, it's all stateless, right? Now, how do we do it? So the answer is map states max concurrency. So what is max concurrency? It basically specifies the number of child workflow executions that can run in parallel. The interpreter only allows up to the specified number of parallel child workflow executions. So what it essentially means is that your step functions has the capability, especially the distributed mode, to be able to run up to 10,000 parallel executions, but you can tell step function that, dude, I know you can do a lot more, but my downstream services cannot handle so much, so please limit it. So we have limited the number of parallel executions to a smaller number that is not overwhelming our third-party services. Now, whatever I'm talking about, the map state, the max concurrency, none of this is in my application. None of this is in my Python code. All of it is in the step functions configuration. The third one is the wait time to get the confirmation from the payment gateway provider. As I told you, the payment gateway takes some time to confirm whether a particular payout was successful or not, right? And we can't wait for long because step function has a maximum timeout of 15 minutes. And I told you that sometimes it can take a few minutes or a few hours. We never really know, right? So what is the solution for that? And we didn't want to pay to AWS for simply waiting inside the Lambda functions. That's, I mean, we are a startup, and the startup folks would very much resonate with me. I'm not saying that the enterprise folks would not, but money is very, very important when you are a startup, right? So it was very crucial, not just from the timer perspective, but we didn't want to pay for idle time, and that's essentially against the entire serverless principles as well, right? So what we did, we leveraged something called as the callback pattern of step functions, which is basically what it is callback tasks provide a way to pause a workflow until a task token is returned. That means imagine a real world example where let's say you have to apply for a leave and you have an application where you have submitted your leave, and sometimes it happens, right? You have to nudge your manager to actually tell you I've submitted my leave application, can you please quickly check and let me know if it is good or not, if you can approve it, right? So and then you wait for your manager to take some action, and once he takes an action, then you can either be happy, that is resumption, either be happy or sad depending on the outcome of your manager's decision, right? Which is very similar to the callback pattern in step functions, where in the state where we're calling the payout API, we have that as a callback task. And what we do is we call the third-party API and then we wait the step function. Essentially, we pause it. As I told you, step functions can run up to 1 year, right? Of course, it's not going to take that long, and but we have a timeout for that as well. So what we do is we call the payment gateway API, we pass the step function, and once there is a response from the payment gateway, whether it's a success or a failure, we resume the step function to either take the success path or the failure path, right? So that is essentially the purpose of the callback, where you want to rely on a third party or an external system to decide how you want to proceed forward. And this was a big winner for us because we didn't have to wait in the Lambda function. We didn't have to do anything in the code. We didn't have to pay AWS for the idle time. That's great, right? And all of this is out of the box. You just have to configure your step function to be able to do it. Isn't that crazy and amazing? Now, the fourth challenge is errors and retries. Excuse me. So as I told you, we are relying on third-party services. And let's be honest, as I told you earlier, it's not that always your code runs as expected, right? There will be errors, unhandled exceptions. You have to make sure that you gracefully catch them and gracefully handle them, right? So what we did was, since we are looping through multiple events in the step function now, and we have the opportunity or the capability to be able to understand which particular execution is failing, we have the option of retrying that particular one. And with step function retries, so what we do is we can automatically retry the failed status, like when a Lambda function fails or an API call fails and stuff like that. You can handle it. Just like how you have try-catch blocks in your code, you can have try-catch blocks for the tasks as well, or states as well. A few of them I've mentioned here. Error equals. So you're basically telling step function that if the error that is thrown is this, then do this. Or interval seconds, the number of seconds before the first retry attempt. So you can decide, let's say I'm calling the third party API, right? In this case, the payment gateway. Now imagine that there is a problem, or I have, even after my max concurrency configuration, I'm throttling them. So you got a throttling exception. And then what you do is you wait. You wait for a few seconds, and then you retry, right? So that capability is available out of the box with step function. Maximum attempts, the number of times you want to retry, back off rate, exponential back off multiplier, all of this not in your code, but in the lambda in the step functions configuration, and helps handle transient errors like timeouts or throttling. As I told you, keeps the retry logic out of your code, right? I mean, you would have certain try catch blocks in your application layer as well. I'm not saying that this would completely eliminate all of that, but the ability to retry depending on something that happens, right? Reacting, you are basically in a better position to react better depending on what is happening in the lambda function with step functions itself. And the fallback states, like I told you, the previous slide was about retries. Now this is about catch blocks, right? So fallbacks. So what you can do is you can change the workflow. If something fails, then you can have a separate branch with the catch block. And then this helps you gracefully handle service failures, validation issues, unexpected errors, and stuff like that. And this is much, both the catches and retries essentially go hand in hand, and you use them both together to be able to have a much more a cleaner, safer, and better execution of the step functions. Before I conclude, one last thing about the best practices and points to remember, right? It is important to choose between standard and express workflows because they directly not only impact how your workflows are going to be executed, but also has a direct impact on your AWS bill as well. So it is very important you understand your use case and choose what you want, or as I told you, mix both of them if needed. Leverage S3 instead of passing larger payloads. As I told you, in the map state, in the distributed map, you have an option to loop through items that is stored in S3. Use timeouts to avoid stuck executions. So what happens is, as I told you, as a standard workflow can run up to a year, right? And I can call a third-party payment gateway API, and I can wait using that callback state. But that doesn't mean that I have to wait till 1 year. So I can, as I told you, we have timeouts. So it doesn't wait for eternity in this case for 1 year, but rather it waits for certain hours. And if there's no response from the third-party system or the external system, then we throw an error or we handle it differently. So don't wait for too long. You cut things off if you think that it's taking way too long for it to proceed forward. Move out retry, wait time, conditional execution from your application layer to the step function configuration, right? So this way what happens is your application layer logic is much more simpler, and the complexity of doing this heavy lifting of non-business logic, but the logic that is very important to be able to execute your code in the best possible manner lies with step functions and its configuration. Use task tokens to await for responses from third-party APIs. We discussed that. Idempotency, very important. Idempotency for Express workflows, because as I told you, Express workflows guarantees only at least once execution. That means it is possible that the same input can be passed again. Right. So before I close my session, a few of you might be thinking that, you know what, it's very nice, cool for me be able to move out all these logic from my application layer into my step functions configuration, right? But is it worth it? But do I have to do it? I would like to answer that with a couple of points. The first one is, if you're running something complex like us, like our scenario, I would say it's 100% worth it, right? Because your application code becomes much more slim. When it is much more slim, it is much more easier to maintain, much more easier to make it scalable, much more easier to be able to debug, and much more easier to be monitoring it, right? And most importantly, your next developer will be happy that he or she doesn't have to maintain messy code, right? And you are basically elevating all of this complex looping, retrying, catching, all that logic into step functions, right? The immediate question I get is, or I ask myself is, I am introducing another AWS service into my architecture. That means I have to learn another service. That means I have to monitor another service. I have to pay for another service, right? So as I told you, if you're running something complex and you want to orchestrate different kinds of AWS services, in my specific example, it has always been Lambda functions, but it doesn't have to be in your case, right? It could be multiple others. So it is very important for you to understand this and decide whether step functions is the right choice for you or not. And within step functions, you have multiple things to even decide. So I hope this was an informative session and you can take something out of it, especially with subfunctions. And with that, I'd like to conclude my session. Thank you so much, everyone, for joining us today virtually across the world, and I look forward to connecting with you either on LinkedIn or on X. Here are the links. Please feel free to reach out to me if you want to talk about anything serverless or AWS in that for that matter. So thank you so much for having here, and it was a really nice session.
Good morning, everyone, and thanks for joining AWS Community Day, Oceanic, the first virtual edition. Okay, so today we are diving into the Amazon Aurora, a cutting-edge cloud-native relation database designed for speed, reliability, and a global scale. We will explore Aurora's architecture, how to set up a multi-region cluster, and the best practices to handle conflicts in distributed environments. Plus, there is a hands-on workshop where you will be get to configure a test a real-time multi-region setup yourself. By the end of this session, you'll be ready to deploy highly available, scalable Aurora databases for your application. So, without any further delay, let's jump in and get started. So before that, I would like to introduce myself. So myself, Rajaram. I work as a cloud ops lead in a fintech organization, and also I'm an AWS community builder. And along with that, I do write a blogs on cloud on a Medium. So I'm a technical blogger as well. So this session is all about, like, before we talk about Aurora DSQL, let's learn what is the RDS, the existing RDS, right? So let's talk about the RDS, and which is also known as AWS Relation Database Service. So RDS is a managed cloud service designed to simplify the setup, operation, and the scaling of a relation database in the cloud. So with the RDS, you don't have to worry about the time-consuming administrative tasks. It takes care of automated backups, regular patching, and ensure high availability. So here, if you can see the advantages of RDS, right? So we do have a cost effective. We only pay for what you use, and you avoid upfront cost associated with the hardware and licensing. And then comes with the automated backups. So RDS automatically backs up your data, helping you recover easily if something goes wrong. And also this supports multiple database engines like MySQL, PostgreSQL, Oracle, and SQL Server, giving you more flexibility. And also we can have a more in terms of observability metrics and monitoring, so it gives a monitoring so you can keep track of performance and health. And also we can integrate these RDS with the multiple services, like you can connect with the services like EC2, Lambda, and S3. So and also it is a fully managed service. AWS handles maintained tasks, saving your time and valuable time. So scalability, easily scale up your database up or down without downtime. So there is a slight downtime would be there, but still it's better than the native databases. And also it comes with a highly availability. So RDS offers features like multi-agent deployments, ensuring your database is always accessible. So now let's talk about Aurora DSQL. So Aurora DSQL is a breakthrough in serverless distributed SQL databases from AWS. So Aurora DSQL offers a fully serverless distributed SQL database experience. It is designed to simplify a database management with no infrastructure concerns, just focus on your applications. So the key features includes, virtually unlimited scalability. The architecture automatically scales to handle workloads of any size, for small apps to massive global enterprises. And also it comes with a high availability. It is built with a active high availability, supporting up to 99.99% availability within the single region, and an even higher 99.999% with the multi-region availability. And this ensures your application is always running, crucial for mission critical uploads. And also this comes with a zero downtime maintenance. Automated patching and upgrades mean your database remains up to date without impacting high availability. No scheduled downtime, no manual intervention. So here, let's look at the difference between the Aurora DSQL, RDS and the DSQL. So here the architecture, like when it comes to the RDS, like you have to provision your infrastructure with what is the CPU and memory, and what is the storage you have to allocate, and what is the IO piece you have to allocate. All these things comes with the architecture when it comes to the RDS. Whereas when you talk about DSQL, it's everything is being handled by AWS itself. You just need to provide your cluster name. That's enough for you, and which region you want to launch that DSQL. And then the next thing, which the feature would comes with the scaling. So here we need to manual auto scaling when it comes to the storage or IOPs. So we need to adjust these limitations accordingly, and how many replications. And whereas when it comes to the DSQL, so where we can have a virtually unlimited automated scaling. So again, this handles by AWS itself. And infrastructures, as we talk about it requires provisioning and maintenance. Like when there is any upgrades are happening, you need to take it intervention, and then you need to take a downtime from the client to upgrade that softwares, and then you need to take the backups, all these things. But whereas in DSQL, you don't need to worry about that. Everything will be handled by AWS because we don't need to worry about the infrastructure management. And the last one feature comes with the management. So there is some manual maintenance and patching. So the patches, all these things you need to apply it manually, and also you need to adjust some parameters to work efficiently. And whereas for a DSQL, it's a completely fully serverless, and the patchings won't be there. So which means there is a zero downtime. So let's talk about the like what we can the features of this. And Aurora DSQL, this comes with a huge set of parameters. Like this Aurora DSQL offers automatic scaling, so it grows with your workload and no manual intervention is needed. So, and also it's a serverless, fully serverless, and no infrastructure or patching to manage. Just use it and let AWS handles the rest. And it comes with the active and multi-region, so which means supports strong transactions across multiple regions for high availability. And along with that, it comes with a PostgreSQL compatible, work seamlessly with the Postgres tools and ORMs, And the last one, I like Arrow DSQL delivers a scalable, serverless, highly available database with a familiar PostgreSQL compatibility, making modern cloud workloads simple and reliable. So let's talk about the internal architecture, like how it works with the like we do have a few terminals with the DSQL. So one of them is a journal. So think of the journal as a never-ending ledger. So which means every change is recorded, nothing is lost, and the entire history is preserved. So this log-based approach is what allows Aurora to be durable and recover rapidly from failures, since everything is in the journal. It can always rebuild and restore. So importantly, the journal is an internal log server. It's invisible to customers, which means you cannot see the journal where it exactly lies in the table, but absolutely central to how AWS manages data reliability behind the scenes. And then we talk about the adjudicator. And whenever multiple transactions try to modify the same data at the same time, right? So the adjudicator steps into the prevent conflicts. So only non-conflicting transactions are allowed to commit, ensuring data consistency. And for instance, like if two transactions try to insert the same primary key, that adjudicator decides which one succeeds. Okay. And only approved transactions move forward to the journal and database. The adjudicator is a key of maintaining isolation and consistency by preventing conflicting changes in error. So to understand in detail about like how the adjudicator works and all, like we do have a workshop at the end, and I'll be showing the how AWS DSQL is being handled, this kind of a conflicts. And this is the complete internal architecture of an DSQL and how it works. So let's assume, like imagining two clients trying to okay, instead of clients, imagine two database users are trying to insert a record with the same primary key simultaneously. Normally this could be a cause of a conflict, right? So that's where Aurora as an adjudicator comes in. So think of it as a traffic controller for transactions. It checks request, detects potential conflicts, and ensures only one succeeds. So which means whichever gets succeeded first. So preserving isolation and consistency. So only transactions that pass the adjudicator are allowed to proceed. So they're then recorded in the journal, which is a invisible log. So which acts as an immutable log for all operations. This makes sure no data is lost and recovery is finally at any point. So finally, these changes are safely written to Aurora's storage layer, the durable distributed data store. So Aurora's architecture relies on the adjudicator to resolve conflicts early, maintain data integrity, and deliver the high consistency and reliability essential for modern cloud databases. And let's talk about the pricing and when we can use and where it is being available as of now. So earlier it was with the preview mode, like where you can do a end-to-end testing with the preview mode. And recently on May 27th, the AWS has made that preview mode to general mode, which means where this DSQL is being you can be able to spin up this infrastructure on a couple of regions. So especially when it comes to the US East one and US East regions, and Asia Pacific, it's in Osaka and Tokyo and Seoul. And in Europe, it's available in Ireland and London, and as well as Paris. So whereas when it comes to the pricing, so obviously when we talk about AWS, obviously it comes with the performance and then pricing, right? So the pricing for it is built based on the DPUs. So DPUs known as distributed processing units. So per 1 million units, the cost of this the cost of this SQL would be $8 per $8. Okay, so here it is not being calculated based on hours; it is calculated based on a distributed processing units. And whereas for the storage, it's a per GB it is 0.33 GB. I mean $33 per GB. So let's dive deep into the demo, like how we can set up, how we can navigate, and how we can provision the infrastructure using DSQL. So the use case of this particular session is like we'll be spinning up the multi-region DSQL and through a console, and let's see how we can deal with it. So here, if you can see this screenshot, like so one of them is referring to the North Virginia region, other one is with the Ohio region. So here I'm just clicking on the clusters, and then if I just type Aurora DSQL, and then if you click on this, so this is the basic page you can see. So here, if you can see, there are no resources displayed because we haven't provisioned anything. So how to provision that, and all these things comes into the picture. Let's deal how simple, like in case if you guys are if you have ever spin up the RDS, like when you're spinning up the RDS, there is a lot of factors come into the picture. Like when you want to spin up the RDS infrastructure, so you need to know like what is the shape of RDS, and what is the storage it has to be allocated, and what is the IOPS it has to be allocated, whether it has to be auto scaling, has to be increased to the certain storage limits, and the environment variables, whether you have to use the custom parameter group or the default parameter groups, and does it has to have any replicas, right? So there are a lot of things come into the picture when you have this, and there are a lot of details, whether you need to have a downtime and the maintenance window, and the patches has to be applicable, and the passwords, you need to set up your password, or you have to store it in the secret manager. So this comes with the RDS, whereas when we talk about DSQL, it is very straightforward. Okay, so let's see how it's very straightforward, and how it is easy to cloud infrastructure engineer to provision this infrastructure without having any concerning about all this infrastructure specs. So let's move to the next one. So here, if you can see this, like if I click on create cluster, it will pop up with the two options. You need to have a do you want to provision this DSQL with a single region or the multi-region? So where I want to test it with the HA, so that's where I am going with the multi-region. So when I click on multi-region, so this new page gets pop up, so the left side. So here, all the thing you need to do is you can just click on enable deletion protection as part of protecting your database. And here the witness region, you just need to choose it either to Oregon or something Ohio. And the only thing you need to bother here is you need to use like what is the cluster name you have to set up for this a cluster when you're launching a DSQL. Okay, and we talk about witness region, what it happens and what is its role in this DSQL. So I just need to click on provide the name, and then just click on create cluster. So that's it. I don't need to mention any CPU and any memory and what is the storage, all these things. When I click on create cluster, so this shows as a pending setup. Okay, because we are setting up a HA which is not dependent with single region, so we need to set up the same thing in another region as well. Okay, so that's where it's the status shows as a pending setup. So what you need to do is you just need to click on complete multi-region cluster setup, which is highlighted on with the orange color, or you can click on the notification which is showing as a warning. So you can, if you click on that, right, so it will navigate to the another console. Okay, and then here when we click on this, the cluster which has created in North Virginia, there will be a peers, so which acts as a witness region. Okay, so this again I'll take you to the next slide, and I'll in some time I'll let you know like what is the role of this witness. And then we were talking about the like creating the another cluster. So I just need to choose from the create cluster and another region, and where I have to launch it. So it will be in a use EC2, which is known as Ohio. I just need to choose from the drop down and click on create cluster. And here also it will ask me to set up what is the username, I mean what is the cluster name. So I'm just providing the cluster name and then creating a cluster. So here again, even after creating a multi-region, like in both the regions from North Virginia and then Ohio, so the status still shows pending. This is because of we have launched two different clusters in two different regions, but we haven't set up a peering connection between these two clusters within the multi-region, right? So that's where peering connection comes into the picture. So that's where it is showing an notification, I mean with the warning sign to peer it with the North Virginia, because we have launched this cluster in Ohio. So it will ask us to pair it with North Virginia because that's where we have launched the first cluster. So you just need to click on pair cluster, and then it will ask you to clear cluster here. And this you can get the same from North Virginia. You can just click on confirm. So as soon as you click on confirm, it start creating in both North Virginia as well as Ohio regions. Okay, so within few minutes your cluster will be in available mode, and where you can able to see the status is active. So, and also here, if you can see this, right here, you don't see like RDS, the traditional RDS, like you will not be having a lot of details over here. So all you can see is the cluster ID and the KMS key used by default. I mean, when you're spinning up, you can choose the custom KMS as well, but I just use the default one. And also related protection has been on. And when we click on the peers, right, so this is where the peering connection, which is on Ohio region. So this is, we can call it as a replication between region to region. So that's how it is, the cluster details. And the metrics, usually you can see like the same, I mean the utilization, all these things, and the storage, all this part. Anyhow, that will be taken care by AWS. So next, I was talking of the witness region, right? So if you go to the Oregon region where we have launched the witness region, if you go and search there, it will not be showing any kind of a resource because it doesn't exist at all. So the main reason for having a witness region is whenever there is a write operation transaction logs are being generated, writing from master to a replica, from region to region replication. So it will also store the temporary transaction logs in that witness region. So in case of there is a region failure, so it will act as a where we can restore that information. So restore that information from the witness region. Okay. So that's where the witness region comes into the picture, where you'll not be losing any kind of a data, and only you can retrieve this information when there is kind of a multi-region failure. So that rarely happens. In that kind of scenario, like the witness region acts as a retrieving this information or restoring this information into the another region. And okay, so the cluster settings, we are seeing it in Ohio region. And like how to connect to this cluster. Okay, so like we just created the setup. Now we want to know how to connect to this cluster database, right? So when you go to the cluster, when you just click on this cluster, and then there is an actions options, and you need to click on open cloud shell, so where you can have a cloud shell will be opened, and as well as you will be having the tokens which will be generated over here for the connecting to a database. I'll show you like what is the password you will be getting over there. And here, if you can see this, when you click on get token, right? So this is the token which will be generated as part of your temporary password, which will be validated only for 15 minutes. Okay. So, and then that's how you connect to a database, and this is how you see the cloud shell. So here, let's run a few queries to know the conflicts and how we can run it, and then how fast the replication is between these two clusters. So here I'm just running the select star from ACD Oceanic 2025. So when I run this query in the US reach region, it shows the database is, I mean, the table does not exist, right? So, and in the same way, when I run it on US2, it gives the same information. So now what we need to do, we just need to create a table so that we can see how these queries and then database logs are being added into the another region. So I'm just creating a sample database with an internal, I mean, inter primary key with the first name and as well as last name, and the topic we are just creating a varchar with 100 characters. And I'm just running it, and just I created the table in the US1, and I'm running the same query in the US2 within a fraction of seconds. And here, if you can see this, right, it says this already exists because we already inserted in the US1. So the replication is that, I mean, the return from region to region is very fast. Okay, it's a milliseconds, I can say. And whereas when I run this query and it shows select again, if I run the same select query, it shows 0 queries, obviously because we just created the table. We haven't inserted any kind of table inserted that information. So that's why even if I run the select query, it's the same, like from the US East 1 and US East 2, it will give the same information. So now let's insert one table to see how the results comes into the picture. So here I'm just inserting the region in the US East 1. And as well as I'm running the same select query in the US2. So I can see one table has been inserted, And also what I'm doing a vice versa. I'm just inserting another table in USIS2, and I'm just running the select query in a USIS1. And here, if I can see that there are two tables has been added over here, inserted over here. And then we just want to, like we were talking of the how this conflicts come to the picture, right? And this, like all these transactions, right? So all these transactions, the one which we are inserting all these things, all these transaction logs are being stored in a journal, where we have talked about earlier, which is a invisible log. I mean, where you cannot able to see it, but all this information is being stored at the log level, as known as journal. And let's talk about the educator, where how these conflicts are being handled by a DSQL. Okay, so that's where we want to update one query for one of the tables which we have inserted. So I'm just changing the topic Aurora DSQL to our AWS Aurora DSQL. Okay, so I'm just doing a select star from doing it, and then I'm updating in the Cloud Shell on the US EC2. So I'm just adding the topic, and then if you can see this, the information has been added AWS Aurora DSQL instead of Aurora DSQL. And let's do the same thing with another transactions, right? So whenever we run with a query in a database, we begin with the begin, and then where it start having a transaction starts logging it. And when I click on begin, and then I'm running the same update command, and then I'm doing a commit. Okay, and when I run it, it got successful and the two rows has been updated, whereas I'm doing the same command and the same table, I'm updating it. So here, if you can see this, right, it shows the change conflicts with another transaction. So please try. So this is how the conflict is being handled by a educator as well as the uh, DSQL. So even if multiple users are trying on updating the same topic, so it will be updated. It will start logging this information in the journal, and then the educator deals with the multiple transactions if it's running on the same table, and if the whichever is gets successful, so that will act as the latest information, and you cannot update the same thing on the another region. So that's how the conflicts are being handled by a educator. And then, like we have till now we were talking about like what is the RDS and what is the DSQL, and what is the difference between this RDS and DSQL and the features of this. And we have also seen the pricing of the DSQL, I mean DSQL, how it is being used and where it is being available. And also we have seen the hands-on sessions, how to launch a multi-region cluster in using a DSQL. And the next part which comes is like, obviously when we hear about, when we are comparing with the two different services, obviously the next thing which comes into our mind is like when to choose a watch, right? So when to choose RDS and then when to choose the DSQL. So if you want to use a DSQL, right, so you need to, if you want to have a highly scalable and then availability, and then the applications require high performance and the low latency, in this case you can go for a or a DSQL. And as well as you can also go with a DSQL when you don't want to if you don't want to have in case you don't have an exact idea like how much data is being ingested into your database every day, and then sometimes there will be a lot of data will be coming into your application, and then the logs and the storage keeps filling up. And then every time you want to spin up the new if you want to spin up increase the infra of a storage, so DSQL handles these kind of things efficiently without having any downtime, because you don't need to pay, I mean you don't need to worry about the storage, especially here, because it has an inbuilt capability of an auto scaling, where it can spin up the infrastructure, where it can spin up the storage as part of the data is being ingesting every day. Okay, and whereas when it comes to the RDS, so it comes with the service like to support like in case if you want to have a various databases, if you want to go with the MySQL, or if you want to go with the Oracle. So if you want to go with the different flavors of the database, and then you can choose the RDS, because DSQL as of now it's supporting this only the Postgres compatible versions. And the managing infrastructure, all these things, when it comes to picture, you can go with the RDS. So whereas when it comes to the RDS and DSQL, like there are a lot of differences between this, as already we have discussed. But DSQL acts because when it comes to the RDS, you cannot have an auto scaling for the storage here, right? You need to take a downtime and then you need to spin up, and each and every time, even if you keep auto scaling up to max this storage, and then still you need to, after ending up with a huge storage, so you need to spin up, you need to change the changes. I mean, you need to increase the infra when we are talking of the RDS. And then whereas the DSQL, you don't need to worry about any of these things with the infrastructure management. So everything will be handled by DSQL. And also it's a fully serverless, and you don't need to worry about the maintenance or the backups. So everything will be handled by DSQL. So that's all about Aurora DSQL, which currently it's generally available for few of the regions. Feel free to explore it. And if you have any queries relevant to this DSQL or the containers part, feel free to reach out to me. I would be happy to assist you on this. And also, in case if you want to set up this cluster, all these things, I'll be sharing in detail a Medium blog in a Medium blog for this launching of this DSQL. I'll be sharing it over LinkedIn, so you can follow up over there. So to get hands-on workshop how this DSQL works. All right. So that's come to end of this session, and thanks for your time and hearing with us.
Are we going to go live now? Okay. So, hi everyone. Today, I'm going to talk about building a secure AWS data pipeline with Glue, Lake Formation, and Amazon QCLI. The session is about how to build the secure AWS data pipeline. And before that, I am introducing myself. I'm Abhinaya. I hold 3 years of experience, and I'm working as an associate at PwC Acceleration Center, and I'm an AWS community builder, and I'm part of AWS Women in Tech Chennai. You can spot me in Women in Tech Chennai events. I co-organize the events along, which is leading by Sridevi. And apart from that, I do bite-sized podcasts along with one of my friends from community, and I was writing the blog once, like I was continuously writing the tech blogs. Now it is on pause. So and then apart from this, I do art, I do doodling, and I do illustrations. Whatever, I love to do paintings. That's it. This is what about me. And before starting the topic, so I want to touch base on few things. What is data pipeline? Why data pipeline is needed? And so AWS Glue and Lake Formation, and then I will go to the data pipeline part. So basically, what's data pipeline? So why data pipeline is needed for the firm or organization? So basically, what's data pipeline is about? It's extracting the data from source, the various sources. It can be live streaming of data. It can be from batch processing. It can be from like application data. It can be from API, from wherever it is. It can be from any sources. So we are going to extract, and then the transformation pipeline comes in. So what the data supposed to be, like we need to transform by using any programming language. It can be Python, PySpark. We need to understand the requirement, and then we need to transform it by code, and then the end user is going to consume it. This is how the data pipeline is gonna work. So let's suppose, I want to check the balance of my bank account. So I'm using daily transaction in different sources, right? Like I can use Google Pay. I might use the ATM cards. I might use some other transaction paging. But finally, I want to know the balance of the my account. That's it. So here is what the transform is going to happen. So I want to only count the balance of my account. So the transformation pipeline also, it's going to only count the dance, like the processing is going to only the count the balance amount, and then I'm going to retrieve the balance of it. This is how the data pipeline is going to work. The sources can be from anywhere. We need to only process the data, only the transform the data, whatever the end user needs. So this is how the data pipeline is gonna work. So example, we can take this event as an example. So registrations happen, and someone might take in charge of the speaker, someone might take in charge of registration, someone might take in charge of inviting the speakers. So it can be from different sources, right? So finally, the organizers needs to know at the end of the day, so what the event update. So the pipeline here is going to work. So how many registration, the count is going to work, and how many people from which regions, like region wise, it will categorize. So this is how the data pipeline is gonna work. So instead of we manually work on the data to get the insights, the data pipeline will automate the process. It reduces the manual works. That's the part of data pipeline. And the next thing, so the AWS Glue. So it's one of the serverless ETL service provided by AWS to convert to automate that ETL to build the data pipeline by using the ETL. So it's an architecture diagram of AWS Glue. The main components are crawler and data catalog and schedule the workflows. This is how it is going to work. The data sources, it can be from anywhere. The data lake, like S3, we can take as an example as an S3, the data sources. So the crawler is the part where the crawler is going to get the data source. For example, the CSV file. I'm going to read it from the data source means the crawler is going to get the CSV file, and then it is going to make the metadata in the data catalog. The data catalog, you can assume it in the index of the book. So it is going to have which the column wise, the metadata of that the files. It can be a CSV, Parquet, whatever the file is going to be. The crawler is going to get the metadata of the files or data. So the data catalog is going to hold the column names or the column names of the source data. So the crawler is going to get the data. It is like discovering the data and cataloging into the data catalog part. So the data catalog holds the databases, and in databases, it's going to have the tables as well. This is how the AWS Glue is gonna work. And then we are having the visualizing the ETL. So you don't need to write the code manually also. So it is having the transforming options like to remove the duplicates, and it's having to find remove the duplicates and deduct the sensitive informations. It is having the wide operations in the transform. So you just need to click and you what information you need. You just drop down and choose choose a column. It's going to transform. The code is gonna automatically create in the background. So then you can you can find the destination and store it in the target. Maybe it can be any database or any data warehouse, whatever it is. So this is how the pipeline is going to work, and then it is having the workflow. So AWS Glue is gonna have a workflow. You are going to so after this data source retrievable ends, then you need to transform the event, and then you need to load it to the somewhere place. So it should be in the scheduled manner, one after other. It's gonna work. So this is how the schedule is going to be. So if it is on real-time streaming, it wants to be updated in the real time, and it wants to give the updates to the end user in the real time basis. But so if we are having the batch processing as well. You can schedule the event like for 4 hours once the job needs to run, and then it will run and then save the output in some data target base. So this is how the AWS Glue works. It reduces the manual workflow, and it ensures security, and it automates the ETL process very easily. So this is about AWS Glue. It's on serverless ETL service. Can remember like that. And so the features of AWS Glue, as I said earlier, like it's the job scheduler. You can schedule the event at whatever the time you want to run. Like 12 a.m. I want to run all of the bank details to retrieve the balance from all the users, and just to notify all the end users. And developer endpoints, it is having the interactive platform as well, and it's like the IDE, like Visual Studio Code. You are going to the Jupyter Notebook is there, right? So you are going to write the code, and then you can retrieve the output in the real time basis. So likewise, the developer endpoints works here, and automate code generation. So you are going to choose what do you need to transform over there. It automatically write the code in the backend, and then it easy the process of the transformation. It is the process of the data transformations and integrated data catalog. So it is about the data catalog is as I was telling earlier. It is about getting the metadata, and it is storing it in the data catalog option. So it will retrieve. So example, one of the tables, sales table is there. It is going to take what column is there. It will retrieve it. So you don't need to manually create a schema in the database. Before that, you want to go to the database and then you want to create the schema, create schema name. So, but AWS Glue automates the schema creation part. You don't need to do it manually. You just going to click over there. The behind the scene, you don't need to worry about what how many nodes it's using and what infrastructure it is going to use. It's going to You are going to choose the data and then run the crawler. It is going to take the path. So automatic schema discovery. So this is what the data catalog, the schema discovery is going to store it in the data catalog part. This is the features of AWS Glue, and you can build the ETL pipeline easily. That's what AWS Glue is about. And so here comes the data lake formation. So data lake formation ensures the security of the data lake. So you can ask me, that's what AWS Glue is also going to work. So AWS Glue, we can with AWS S3 and Glue, we can make the ETL pipeline. So we want to do in much granularity purpose. We can here comes the data lake formation. So it is having the fine grained access to it. So suppose it is having the centralized repository. So IAM and lake formation both are there. So IAM is the central repository to manage the users groups and policies, right? So likewise, the AWS data lake formation is concerned. So it is going to centralized repository. You are going to choose the user, which column the user is going to use, and which row the user can use, and tag-based access control. The data grows, you can go for the tag-based access control as well. So this is how the data lake formation works. It's a centralized repository of your data for accessing the data in the database level. It will go find granular access. Let's say example, we are having this event, AWS Community Day. So you are having the organizers wants to know how many attendees list. Okay, so maybe there is a marketing team that's system. So they want to know only the email ID of the participants. Okay, so one of the person is taking the initiative speakers. Only the organizer part of organization team wants to know, get the contact and the speaker details only. So this is how the data lake formation works. So which person needs to know which data in the granularity format. Example, so marketing team only wants to know the email data. They don't need to know the sensitive data of the customer. So it will hide the other details, only show specific essential details to the team members. So example, so I'm the person who wants to develop an ETL pipeline for two tables. So the data lake formation, we can define it. So in the database level, so only the table one and table two, Abhinav is gonna work and transforms the data. So here's how the database level access works. So okay, the database level. So it is database one. Under database one, Abhi is going to work on the table one and table two. This is how the table level access works to develop the data. And column level access comes in. So okay, example, I have telling about marketing team, right? So they wants to know in the wide range of columns, they wants to know about only the email and the contact information of the end user. So here is how the column level access works. So only the email ID and the phone number will be accessible to the marketing team to send the mails and whatever the updates to the end user. So the rollout, it is like a filtering the data. Example, so you want to know how many attendees are from the Melbourne. So example, you are filtering with the data. Like so let's start from the attendees where the region is, where the city is equal to Melbourne. So you are filtering out, and then you are assigning that to the so one of the user. So she can able to only access these data. So it is like filtering of the data. And here comes the tag based access control. So tag-based access control, how it works is, so the data grows rapidly, and you can't be able to sit and give the give the access each and everything, right? So when the data grows, okay, example, sensitive information is having, let's you can tag it. It's like a sticky notes, okay? You are having the if you are having the sticky notes, okay, this is like red color sticky note paper, so these are categorized into one, and then this is yellow, and this is blue. Likewise it will be categorized. So this is a marketing team, so it will like marketing team. We can give the data as the tag we are having whenever we are creating some detail pipeline. It will have that whenever you are creating the table as well. It will have the options of tag, like marketing team, or you can write it whatever tag you want. So marketing team, sales team, and then the organizers team, and categorizing into 3 to 4, and then giving access to that level. Okay, so this is the organizer team, so they want to know end to end whatever is happening to here. So I'm giving that level of access to it. So this is how the tag-based access control works. So data lake formation is about this is also it is going to give the access, and this is going to build a secure data pipeline. But you are going to use the IAM is going to give the access to, in the service level. It is the lake formation is going to give access to in the granular level. This is how the data lake formation works. And so I want to like categorize the IAM and the data lake formation. So IAM control access to the AWS resources as well. So and then the data lake formation, it will access to within the data lakes, the table level, column level, and it's like single tag, it's a fine grained level. This is the difference between the AWS IAM and the fine grained level of like data lake formation as well. And so this is a data pipeline with a data lake formation. So this is a data source. You are going to get it from any sources. It can be from anything like the Kafka, or each day you can get a batch processing data. Okay, so you are going to upload it to the raw bucket. So like the S3 bucket, you are going to store, and then you are going to create the crawler over there. So the crawler will run the crawler will scans the data which are present in the S3 bucket, and then it will get the meta only the essentially like the metadata, like metadata in the sense the columns of the data, and then it will update in the data catalog. The data catalog is the part you can assume it is an index of the book. So it is going to have which okay, this is a column name. So index the page 1, page 2, page 3. It's like it is having going to have the metadata of that part. So then the ETL glue job, you are going to have the processing of the information. So you are going to get the data, and then you are going to process it and then store it into the destination. So it can be in any format. So it's mentioning in Parquet, but you can have Avro, whatever the format you want to transform, and then we are going to use that for the processing. So this is how the data pipeline works. So example, so here comes, okay, we are having the IAM rules. So AWS Glue can communicate with the S3 bucket. So I can go to the here IAM, and then so AWS Glue can able to get the data from S3. I might give the S3 full access to it, and then so that only it can able to get the data from the AWS S3 bucket. So this is how the IAM works. And then the security and governance part, the data lake formation access control. So now I might define, so I need the email ID and the customer name can only visible to Abhinyam, so retrieve the data. So here is come, I define that I register the S3 location, and then I give the access only to the column part, the particular columns part to one of the user. So let's say I'm gonna retrieve the data by using the Athena. So I'm just select first name from this XXX database from XXX column. Only the access is gonna be, so it won't retrieve the data because I didn't give the access to the user. So what it will do is only the email ID can able to retrieve from the source. Other than that, we can't retrieve anything. So this is how the data pipeline with the data lake formation works. And I just generated this diagram by using Amazon QCLR. And so the data pipeline, as we saw, the ETL, and ETL is the data pipeline with the data lake formation. What is the benefits of it? So you are not automated and secure pipeline. You are going to create the ETL pipeline and with the IAM created IAM. So it is going to be automated, and you don't want to define, like you don't want to sit in the Excel, and don't need to clean and transform and then save it somewhere. Okay, it's gonna to be the automatic purpose. I'm just going to click. It's in the clickable format. You are going to drop the files, and you are going to click whatever you need, and it will gonna store in some destination. So this is according to the requirement. You are going to transfer some data. This is how the automated and secure pipeline works. And consistent access policies. So it is going to have the fine-grained access policies. So you are going to have each details to you are going to categorize the user, and and then do them, and then this is what they are going to use there. So it's like a fine grained access control. It will have the data lake formation will be attached to this through, and then auditable data access. So example, one, two, two, three users are using that pipeline, so it will have that logs. So who used that, and who transformed that, and who used which kind of columns over there. And this is how it is going to work, the auditable data access. So you can retrieve the logs over at any time. And then scalable governance. So scalable governance in the sense of as rapidly the data is going to scale up. Okay, so you can go for the tag based data lake formation. What it will do is whenever the data is going to be, you just want to have the tag over there, and then you are going to assign what access you are going to give. This is how the automated secure pipeline and consistent access policies and auditable data access. These are the benefits when you are going with a data pipeline with the data lake formations. And so basically it is about automating and govern and secure data flows that enable trust and analytics and compliance purpose. So this is a data, example of data pipeline with data lake formations. Let me go for the short demo. I will show this. And I already created the data pipeline and the transformation part and everything. So this is how it is going to work. So in this, I'm having the email processed. So in this, I'm having the customer CSV data. So I don't know what columns is having what data it's going to hold. Okay, so I have created the detail job. This is a data when you're going to the data through AWS Glue, you are having the data catalog, and then first you want to create a crawler over there, and want to create the crawler, and then it will retrieve the data. So I will just show how to create the crawler. So example, I'm going to create the crawler sample, and then so I didn't know what data source it is. I'm going to use, so I want to give the S3 part where the data is residing in. And so example, I'm choosing the process data, and we are going to crawl and add the, okay, you just added the data sources, and you can add the custom classifier as well. So if suppose it is having the headers. You can define the headers over here. So it's having the headers. You just want to leave the headers, like take the headers as the columns. So you can define over here, and what's IAM role it is going to work. So I have defined the for glue. So for glue, the glue can be able to access the S3. I have given the S3 full access to it, and we can go next. And what's the destination? Okay, so I'm giving example. I have defined, I have developed the database called the exam, like called example. So I have given that, and I want to know which time the crawler is going to schedule. So which time it wants to. So as of now, I'm going to the on demand, or we can use the cron to define the which hour, which time it wants to run, or hourly, daily, weekly, monthly basis. So now I'm not going to create it. I already have that. So this is how it's gonna work. So I already created the crawler over here, and then I run the job and run run the crawler as well, and the table name called, because I have taken the CSV file of email processed. So now I'm going to show you how the table. Okay, so it is gonna have the column. It is retrieve the column names from the CSV file, and it is having all the column names over here, and so then I can build the ETL jobs. I'll show quickly how we can create the ETL. So here is a visual ETL. So you can go with the visual ETLs. You don't need to know the programming or like. Uh, so you can use Amazon S3, and you want to define which location it is from, and then which format it is, and then which location, which file you are going to get it from, the source. And just give this, and so then I can define what transform. So here is come the data transformation. So you can have the change schema, you can change the schemas, then you can use the join commands. You don't need to write the queries over there, just to define what joins it wants to use. And then SQL query, you can specifically retrieve the SQL queries from here, and sensitive data, and it is having the data quality checks as well. It is having the predefined transformation over here, and if you don't want to do here, and I want to do the customization, you can go for the script, and then you can write the code, and then you can transform it as well. So this is how the ETL works. So I have already created the ETL and run the jobs. So this is sample file. I have defined the script. I didn't go for the visualize detail. So I just try only filter the customer ID, which is having this ID, and you are going to have the output over here. Okay, so it is defined, and the ETL job has run. So now I'm gonna define the data lake formation, and so you want to go to the data lake formation, and you want to register the location which you need to give, which data lake you are going to access, and you are going to do the find data access control. So I'm registering, I have registered the email processed data over here, and I registered this, and then I have the data permission, whichever I created is. So I can give like grant, and then which, okay, I am user. So Cabiner is there. So Cabiner is going to use which, okay, create the database permission, table permission. Okay, super user. She can do anything in the database, but you are going to give one the table permission. You can choose the database, so she can do she can select the database, and then insert the data like in the table, and delete whatever she wants to. You can choose for the specific user, and then you want to give the grant. So this is how the AWS data lake formation, the granularity access works. So let me quickly show how the So here I have given for my user, so it should only have, she can able to choose only the country and email column from the specific data source. So if I go to the Athena and then if I'm running this thing, okay, so it won't, the column not forward because I didn't give the authorized permission to the customer ID of my table. So only I have given the given so country and email ID, right? So I can only choose email from it. Okay. If I run the query, it is retrieving the whatever the email address over there. So this is how the data lake formation with the data pipeline works. So we can able to do with Amazon Q CLI as well. So I have built the data pipeline for the AWS Community Day. So I just asked so fill the data pipeline for the AWS or Community Day event which has happened. So I have given the prompt to it, and then it has executed that whole data pipeline for me. And you want to just configure the AWS configure, and you want to specifically given the recommend to it, and then it will build the entire data pipeline for you. And I have queried how many registration went on that particular day. So it has queried the data, and then it is retrieving the total registration of the day. So this is how the data pipeline with the data lake formation works. And, thank you everyone for attending. So you can connect with me in LinkedIn, and you can like follow the podcast on Spotify as well. So thank you everyone for attending the session.
Hey everyone, good morning, good afternoon, and good evening. Welcome to another session about SQS and how do you monitor SQS, because today in the world of event-driven architectures, SQS is very important and one of the core pieces. So I'll be talking a little bit more into how do you monitor and look into metrics and traces, especially when you're using SQS queues in your architectures. So a quick introduction about who I am. I'm Jonesy Noel. I'm one of the serverless heroes based out of India, Bangalore, and I talk a lot about serverless, and be it on the blog or the podcast as well, where those of you who know Zach, I co-run the Zach Show, Talking AWS, along with the Zach all the way from New Zealand. Use the QR code to connect with me if you have any questions around serverless or observability in general. Today, the world is synchronous, and one of the keynotes that Dr. Werner Vogels did at reInvent, he dived into the world being asynchronous, where you do have things, whereas you're invoking APIs, and or be it in the world of e-commerce, where you're adding things to your cart, making payments, all of them under the hood are using events, be it in terms of where your payments are successful or not, events from your payment gateways. Once the events are successful, it creates more events where the orders are being processed, where things are being tracked, where events have been sent into a lot of warehouses to check for inventory and how do you ship them, and again, events for tracking the shipment itself, right from the warehouse to your home step. Today, where the world is dependent on events, You use a lot of architectural patterns where you do have things in place where it is SQS queues or SNS topics, or even as simple as event bridge buses. SQS, one of the oldest and most popularly used event bridge or event-driven architecture components, it helps you with decoupling. And when I say decoupling, it means that in the microservices architecture where you do have a lot of messages to be sent from one microservice to another microservice, the queues help with transporting those events. In the world where it is asynchronous, events is crucial, and SQS acts as a backbone. Today, you do have a lot of patterns when you're thinking about SQS. It could be as simple as SQS being invoked from an SNS topic, or you're using Lambda functions, where either a Lambda function is sending in messages to an SQS, or the Lambda acts as a consumer for your SQS queues. Most typically in serverless, you do have a lot of Lambda functions that's posting messages to your SQS queues, and SQS queues sends them as triggers to your Lambda functions. That's one of the most common patterns that you see when you're decoupling in serverless. And Lambda functions and SQS are the forefront of it. Today, you do have complex architectures where it still depends on as simple as pattern as SQS invoking Lambda or Lambda invoking SQS. You could have a very complex architecture where you do have different components, be it your API gateway level or your S3 buckets or events from an external source, or even things where you do have orchestration or DynamoDB events as well from the streams. All of them could be sent into an event-driven architecture or component of event-driven architecture such as SQS, Event Bridge, or SNS. Today, the focus is on SQS, of course, but you could also have a lot of observability as a whole on all of these components. Today, why do you think it is very important for us to have observability? Is because most of the times you do have events that is flowing in all the way from your different components to your queues, and when it does happen, you could end up in a scenario like this where there's an influx of images being posted to your SQS queues, and your queues are processing them one by one. You do have different capabilities with SQS, be it as FIFO or any such where standard queues where you can process them either in the sequence that they're coming in or as and when it happens, right? So most importantly, at scale, when you have something like an event-driven architecture for your e-commerce application, you do have orders that's flowing in at any given point of time, at any given millisecond granularity. And what happens is that SQS needs to process all of these queues and all of these messages in the queues. Today, observability is important because you need to understand how that specific SQS queue is performing. But why do you think is the challenge, especially when you're talking about event-driven architectures, is that event-driven architectures comes with a complexity. You did see from one of the architecture diagrams that I had that it was very complex, where you did have things such as Lambda functions, step functions, AppSync APIs, or events from S3 bucket itself, all flowing in to different components of your event-driven architecture. And this introduces a lot of complexity because it's firstly distributed, and also it is all over your architecture in terms of being the telemetry coming in from your Lambda function or from your SQS queues, or even from any other component that is part of your architecture. So it builds a lot of complexity, and it doesn't mean that you have observability at one given point, but it comes in different stages of your architecture. You need observability at the API level, or the forefront of the request level, also in terms of the compute and your event-driven components, and of course the database or any such third-party systems that you have. You need observability at all of these stages, because you need to understand as a whole how is your system performing. And given the complexity, the number of touch points where you would have to instrument, where you would have to build in a lot of integrations to capture telemetry information is a lot. And this again creates a lot of rush and a lot of telemetry information, be it in terms of your logs, metrics, and traces. Today, you do have the telemetry coming in from Lambda functions directly with layers or whatnot. But for your event-driven architectures, you heavily rely on things such as CloudWatch and X-Arrays. So even any other observability tool out there depends on something called as CloudWatch metrics, and this is completely dependent on how you're integrating it with CloudWatch itself. Of course, again, event-driven architectures comes with compliance, because you do need to ensure that your data is compliant in terms of the telemetry information, your logs are compliant, your metrics are compliant, and your traces are also compliant, because these are coming in from different architectural components, and all of them aggregated at one place, it's gonna be all lose hell, because you need to understand what's the telemetry information that you want to focus on. What's the telemetry information that is of interest for you alone, because this comes from a business requirement, or a business requirement where you want to look into what are the different metrics, what are the different touch points your architecture is performing good or not good. One such way where we do have with New Relic, one of the observability platforms where you can integrate SQS directly, is with CloudWatch metrics, and the links in there will take you to the documentation for enabling SQS integrations. And this depends on CloudWatch metrics, pulling in all the data from your AWS account with respect to CloudWatch metrics itself, and gets you an aggregated information about how's your queue health, what's the rate at which your message is being sent into your queue, and how's it performing. Well, enough of the talking. I believe we need to take into a demo. So yeah, what I have here is a simple CDK application where it involves an SQS queue configured with dead letter queue for the SQS itself, and also in terms of having a certain visibility timeout of 5 minutes. Also having having a configuration in terms of telling in, okay, how much of maximum messages can the dead letter queue receive, and which is the dead letter queue configured for this specific SQS queue. All that said, you do need a Lambda function producer that's been sending in telemetry, or that's sending in the SQS messages from your Lambda function. So you're configuring a Lambda function producer, and of course a consumer as well from your Lambda function, from your SQS trigger. What we'll do is, it's as simple as telling in, we'll construct a message with SQS, and all we'll do is send the message along with certain attributes. What I'm doing here, you could see that there's tons of other code or snippets of code available in this code base, but here what we are doing is custom instrumenting with New Relic. So now that you're sending in an SQS message right from the consumer. The next part is to ensure that the consumer is able to receive the message from the producer. So we are actually getting in the message from SQS and just logging it out and doing a bunch of other things just for demo purposes to ensure that you can do a lot more with the traces. Let me just invoke the Lambda function. So what this is doing is invoking the producer Lambda function that's sending an SQS message to your consumer Lambda function. And to do all of these things, this is as simple as an invocation. So when I go into my New Relic dashboard, okay, I do see an invocation coming in now. That's the same invocation that I did. Also, because my Lambda function is instrumented, it's giving me the telemetry information about my Lambda function itself, where it's telling if it's a cold start or what's the health of the Lambda function. The interest for now is SQS, so let me get into distributed tracing. It takes a while for the telemetry data to appear, so okay. So in the interest of time, before the telemetry data comes in, I was doing some testing last night, and I'll use those traces for the interest of the demo. Because we did have certain custom instrumentation, you can see that all of the telemetry information such as SQS queues, sorry, this is the producer Lambda. Let me go into producer Lambda. Expand. So you can see that whenever a message is being sent into SQS, we do detect it's available as an SQS message, and there are certain attributes that is available as custom instrumentation from the code. I'll give a quick rundown on the code as well in a few minutes, where you can look at how the name is SQS. You do have information about the trace IDs, the parent trace ID, priority, operation of the SQS, the SQS queue itself, the message ID from SQS, and a few other information about the timestamp. All of this is available along with it. You do get in metrics around the throughput about your SQS queue, writing into SQS queue, and the whole transaction itself, which took about 102 milliseconds for the producer Lambda to send in the message into SQS queue. From my SQS queue, what happens is that I get in from the consumer Lambda function, and the consumer Lambda function processes it and has a bunch of other steps that's doing in just for demo purposes, where I do have certain timeouts defined, and you can see that it's the attributes about the SQS process SQS message, the service tag, the entity name, all of them are available. Along with it, you can also see a breakdown about how in the code base I have custom instrumented to have different spans available. Let me just switch to my code base. So once I do get my SQS message, I'm doing a certain information where adding custom attributes with respect to the request ID, trace ID, and function name to give you the complete information about the trace and the function right from the invocation of the Lambda function, and also to bring in the complete information about what the parent trace IDs are, child trace IDs are. In the world of event-driven architecture, it's always hard to identify where and what went wrong. So it's important to have the trace information about your parent and child. So I'm adding them as custom attributes. Also, inserting a distributed tracing header for ensuring that the complete picture from your Lambda function to your SQS is being captured. Now that this is still a consumer Lambda function, what I could still do is go into my event source. From my invocation, I can find the information about SQS triggering my Lambda function with certain attributes such as what AWS provides, along with it, the ones that I was custom instrumenting from my code base. Because it's SQS, it's identifying the SQS as a trigger, and also the complete breakdown of how the invocation has happened. So first I did get my message, it processed it, it did certain other detailed processing. I've had it certain timeouts only for instrumentation where it's timing out at 100 milliseconds and returning the response back as success. So all of this information right because I've instrumented my Lambda function. Along with it, it's integrating with my SQS queues. Now that you've seen the trace of the complete execution itself, what you could also do with SQS specifically is build out dashboards, because it's important for us to identify how SQS is performing at any given point of time. And I just have a time duration for the last 12 hours where you could see the influx about the messages that's being sent, the number of messages that's being sent into SQS, the number of messages that SQS has received and also deleted. So when you are working with SQS or any such event-driven architectures, it's important to understand the number of messages that's being posted in and out of the SQS queue along with it, because you do pay for the amount of time that or the size of the payloads itself on SQS. It's important to be mindful about the size that your SQS has been consuming. So at any given point of time, you need to understand the maximum payload size that's being sent into an SQS so you can have metrics around it on your dashboards. All of this is powered with something called as New Relic's query language, NURCL. So when you can just go in here, you can view the query itself. So this is for a specific queue. So when I say DLQ, this is for the dead letter queue. Okay. So you did see that for the regular message. What I did initially was before I had the complete app running, I ensured that the consumer was not added as a trigger. So it ended, all of the messages that were sent into SQS did end up into my dead letter queue, the configuration that I was showing you from my CDK code base. And you can see right from there, the number of messages that has been sent into dead letter queue and deleted is a lot, because there was no consumer receiving or looking into the messages that that are being posted into the SQS queue itself. The same queries which I was talking to you all about is available as different touch points or different attributes along with NURCL, which gives you certain information such as the age of the oldest message, the number of messages that are being delayed, also in terms of giving you visibility of the number of messages visible and not visible. When you are using SQS, you need information about the empty receives, which is where whenever you send a message, whenever you're polling SQS to receive messages and you're not able to receive messages, It returns number of empty receives. So this can also give in different telemetry information about the SQS health itself. The other things are the number of messages deleted, received, and sent. Of course, the size of the message, the one that I was showing you earlier in the dashboard. Whenever you have any metric that's flown in, we do get in the complete information about the SQS queue itself, along with it, different other attributes like the ones I was just mentioning. So you could get all of it using this one simple NURCL query on your New Relic accounts. The number of messages sent and received and deleted, and the number of messages that are not visible. So basically, whenever you're sending in messages and they're not available to be received or retrieved from the queue itself. The size of the maximum payload that's being sent into your SQS queues. The number of empty receives as well. This is the same distributed tracing that I was showing you a while back, where you can look at the complete trace, the breakdown of each trace, about how your producer is being sending in messages to your SQS queue. Also for the consumers, the invocation part of it, where you can take a look at the SQS invocation and the information about how long did that transaction take for your Lambda function to execute and process these SQS messages as triggers. Well, now that is said and done, and you did get a sneak peek about how do you use event-driven architectures for your applications, and also enabling telemetry and observability for your event-driven architectures. The next steps is probably for you to understand you need to have certain metadata for your logs to ensure that you can look at where did this log come from, what is the context of this log, so it's easy for triaging. Whenever you have dashboards, it's important that although they are pre-configured dashboards, you need to identify what's the interest that you have and what's the business requirement. Building out dashboards with the right metric itself is very important, because taking a look at some metric that's not important is just another noise for your dashboards. Having alerts is very good, but having alerts with context is very much important, because you need to understand where and what went wrong in your complete event-driven architectures. So with that, I come to the end of the session. So feel free to connect with me on socials, and if you have any questions around SQS or observability in general, hit me up and I'll be happy to help you answer them. Also, whatever I talked about now is available as a blog, so feel free to read more in the blog. The CDK application that I have is available on my GitHub repository, so you can just deploy it on your own AWS account and take a look at about how messages are being flowing in from your SQS queues, from your Lambda function to your SQS queues, and SQS queues to your Lambda function. So with that, thank you, and kudos to the complete Oceanic team for having me here, and see you around.
Trippy. The day has arrived. We're all a bunch of nerves this morning.
Yeah, sure.
Yeah.
It's a big event. Lot to get to manage.
It looks really professional, though. I love it. I totally love this. The platform.
Oh, we're on.
Oh, we're live.
We're on.
Yeah. Good afternoon, everyone. Thank you and welcome for joining us. Today's Fireside Chat is a informal presentation by us. We're just sitting around a campfire, a couple of fellow developers, sharing some stories and experiences and insights. Today's conversations will center around the evolving role of developers and community engagement in a cloud-first world. We're living through some fascinating times where the way we build, deploy, and think about software is changing rapidly. The rise of AI and cloud-native architectures and the emphasis on developer experience and the growing importance of community-driven development are reshaping not just what we build, but how we connect with each other as developers. So to help us navigate these topics, I'm delighted to introduce two incredible advocates who live and breathe this evolution every day. Please join me in welcoming Derek Bingham, a developer advocate at AWS, focused on helping developers across Australia and New Zealand build better applications on the cloud. Derek brings over 18 years of hands-on development experience from industries ranging from healthcare to defense, giving him a unique perspective on the challenges developers face. Please also join me in welcoming Donnie Donnie, a software engineer, self-proclaimed barista, and principal developer advocate at AWS, with more than 17 years of experience in technology industry, from telecommunications and banking to startups. He's now focusing on helping developers understand the variety of technologies available to transform their ideas into execution. He loves coffee and any discussion of topics ranging from microservices to AI and ML. So we'll tap into their experiences today and to explore where development is heading. Donnie and Derek, thanks for joining us today. It's a massive pleasure to have you here.
Thanks, Paul. Thanks for having us.
Thank you, Paul. Thank you, everyone, for having us here. So, what are we going to do here?
Yeah. What are we going to talk about, Paul?
Okay.
Well, I think for the first little next 3 minutes or so, we'll just do a rapid fire session to get acquainted. I'll keep it light and quick, and I'll flick you some questions each, and you can feel free to answer with whatever's on top of your head here. All right. So I'll start with you, Derek.
Okay.
What was the first programming language you ever wrote in?
This is embarrassing, but the first programming language that I ever wrote, Paul, was in a job. So I did stuff at university. I won't count that. But for Rails, I did assembler. So I wrote assembler on OS 390 mainframes for airline industry. So I worked for British Airways out of university, and that was really quite the come down from learning more modern languages at university. And then my first job, they said, nah, you can forget all of that. Let's talk machine code.
That's pretty intensive. Hardcore. What's your preferred coding music? Silence, lo-fi, or heavy metal?
My preferable background music for coding is EDM.
Nice. I agree.
Yep. So I'm one of those people. It's also my preferred background music for life, but yeah.
Your biggest tech trend that's overhyped right now?
Biggest tech trend at the minute that's probably overhyped, and I think I talk about this quite a lot, is the world of AI. I think it's slightly overhyped, and we are using it for too many things. I think there's a need, absolutely a need, and there's a real. It is changing the industry, but I think sometimes we overdo it.
Fair enough. Your most underrated developer tool?
Most underrated developer tool is Vim. The end.
Well, I didn't expect that one.
Everybody, the power of Vim. I think Donnie will probably talk about Vim a lot because he loves it.
I love you,
Derek.
It's pretty good.
If you learn it, it's very powerful.
Nice one. Coffee or tea while coding?
What? To the veins, man. Coffee to the veins. That's what I like. And there's no substitute. Although I am finding green tea recently, so it's maybe because I'm getting old and I've been mainlining coffee for too many years.
Fair enough. Tabs or spaces?
This tabs. Tabs. Just tabs.
Yep.
That's the end.
What's one piece of code you wish you could go back and rewrite?
Every piece of code.
Every piece of code.
Every piece of code I've ever written, there's always room for improvement.
Are you going to vibe code it? I'm just kidding. If you could only use one AWS service, if you could only use one AWS service for the rest of your career, what would it be?
Lambda. Just flexibility, power, languages, ease of use, developer experience. It ticks all the boxes.
Very cool. All right, Donnie, some questions coming your way, bro.
Okay. I got it easy because I went first tonight.
You took
this
all
is like
of my
Family Feud.
All right, first programming language you ever wrote in, sir?
Pascal, Borderland Pascal, especially Borderland Pascal 7.0. So that was my first programming language. I tried to build a puzzle game with Borderland Pascal.
Nice. Your preferred coding music?
Coding music. Okay, so depending on the mood and how heavy the tasks are, but mostly will be like Chemical Brothers block rockin' beats. That's my favorite, block rockin' beats. Or like even like a sad song without an instrument, like Ennio Morricone from Love Them from Nata. So depends on the task.
Next, you'll be telling me you're an Enya fan. There you go. What's the biggest tech trend for you that's overhyped right now?
I would say Gen AI, but Derek already took it from me. So I would say blockchain. I keep on hearing about blockchain for everything, but blockchain is good. But blockchain for everything, I think there's quite a bit overhyped.
So we could say AI backed by blockchain.
Oh yeah, Gen AI powered blockchain or blockchain powered by Gen AI. Yeah, okay.
There you go. Your most underrated developer tool. You're allowed to say Vim if you want to. Oh, your mic's slightly disappeared for me.
Yeah, I can't hear you, Johnny. Ooh.
Johnny, your mic's gone. Apparently it wasn't Vim, or it was.
Yeah, you said something and it's upset Donny's mic. And
you hear me now?
Very low.
You sound like you've gone a mile away, unfortunately.
Can you hear me now?
Yes, sir.
Okay, that's because Derek took my answer on Vim.
Yes, exactly. Sorry.
Okay, so what was the last question, Paul?
Your most underrated developer tool.
Curl. CURL. Curl.
Yeah.
That's an amazing one. I mean, everything's an API, or probably like a FZF, the fuzzy logic. That's the tool that I use the most.
Interestingly enough, both tools are not UI orientated. There you go. Got to stick in the CLI, eh?
Yes.
Stupid question for you. Coffee or tea while coding? I think we know this one. And you're gone again. Oh.
Sorry about this. Coffee. Definitely coffee. Okay, something wrong with my mic. Can you hear me?
Hear you now, but it keeps reducing the volume.
Keep moving that volume thing.
Okay, that's weird.
While you're at it, tabs or spaces?
Oh, tabs. Definitely tabs. I don't understand why people are using spaces. It's not effective, but yeah, tabs all the way.
No, not effective at all. Johnny and I were like the brother from another mother.
Yeah, we are code brothers.
Yeah.
Brothers. So does that mean that you would like to go back and rewrite everything you've ever written as well?
Yeah, like all the codes that I wrote. Yeah, all the codes that I wrote, to be honest, especially during the keynotes that I've done with Derek. Yeah, definitely those scripts.
Yeah, but they work. The demos all work.
Yeah, they work. Yeah.
All right, no pre-recording for you guys. Very brave. Nicely done. And Donnie, if you could use only one AWS service for the rest of your career, what would it be?
EC2.
EC2.
Derek already took Lambda, so I'm going to use EC2. I can run EC2 with Firecracker.
Yes,
so
you can have the best of both worlds there. Yeah.
Clever. Very nice. Oh, thank you very much for that. I think I feel well more acquainted with you fellas, so hopefully everyone else does too. Nicely done.
That's good, Paul. I think, what are the scores on Family Feud? Did we get all the top answers?
Yeah, I mean, interestingly enough, I think for me though, the assembler one's probably the winner on the first programming language there. That's pretty much that's pretty impressive for me.
Thank you.
Even though
You know, I feel like the Highlander of the coding experience. I have been around for such a long time. Yeah, and Donnie's disappeared.
Donnie's disappeared.
Uh-oh. Oh. Okay.
How about we kick into my next question? Yeah, for sure.
Yeah.
So developer community trends. So in regards, you travel a lot and speak at events and you talk to developers regularly. So what trends are you seeing in the developer community right now, both globally and in your respective region?
Yeah, great question, Paul. I think we're seeing a lot of trends. I do travel a lot. I spend my life on planes sometimes, but first world problems. So a lot of trends we're seeing is the adoption of Gen AI tools. So with when I speak to developers, there's always three camps when we talk about Gen AI and specifically using the tools. So the whole concept of AI is massive, right? But as developer advocates, we like to concentrate on things that make developers more efficient and write better code and build better things. So we talk about coding assistants quite a lot and Gen AI and that. And we always see people in three camps. We have the people who really adopt it. So they love their Python. They are very very open to these tools and go really hard into them, and probably for the most point get the result that they want. Then they have the other side of that coin where the people don't want to adopt them because you've got maybe a Java programmer or a .NET programmer or someone who has a very highly typed and defined language. And they really reticent to using the tools. I hope I'm the only person hearing the feedback here. Yes. Okay.
Yes.
I'll keep talking. And then so our job is to convince those people because we are those people. We are the people who have come from a developer background. And we are advocating to use these tools because I actually think they're absolutely fantastic in the productivity they can give you, but should be like anything, used with a pinch of salt and used with a bit more structure to give them the best outcome for a practiced developer. And then you have the people who sit in the middle, so they don't go one way or other, and they're already the people that we've convinced. So I think Donnie and I, developer advocates, spend most of our time talking and trying to convince the people who are current developers these tools are good and these are the best ways to use them, because there's a better way to use them than just vibe coding the thing out of everything. And then for the people who just dive in, we have to show them the way to structure things rather than they run into great problems. Like an example that happened recently was a developer new to developing was using these tools but didn't know how to use Git, right? And then they were using the tool to control their Git code and how it went into version control and got themselves in a hell of a mess. So they didn't know how to use Git and they didn't understand branching, merging, and all of that. So yeah, that's the sort of conversations that we're having at the minute. Really interesting and good fun. I'll let Donnie speak next.
Yep. Can you hear me now?
I can hear
you.
Yes.
Awesome. Okay.
I originally asked when you dropped out there, Donnie, about the fact that you guys travel quite a bit, speaking at events, talking to developers regularly, and what trends you might be seeing in the community right now. So, but the shift in the kinds of tools and technologies, what do you think the developers are gravitating towards these days?
So definitely the developer experience, basically that we want to improve the productivity. So that's something, the trend that I'm seeing across the regions, especially because I'm managing ASEAN, managing like 10 countries in ASEAN. So we are seeing that kind of trends that we want to be more productive with all the tools. Now with the advent of the generative AI, definitely changes everything. It shifts like all the personas as well. But I've seen a lot of generative AI being used, being used by a lot of developers, like those who want to learn, like what Derek already mentioned, or those who want to improve So yeah, so generative AI, I think it's going to change everything, especially on how do we develop.
Sweet. Are you guys noticing any generational differences in how newer developers approach problem solving versus more experienced ones?
You can take this one first, Tony. I've had all the first questions.
Oh, okay, cool.
Yeah.
So I mean, let's take one example. I think AWS recently just released Kiro, right? So Kiro is something that for me is quite phenomenal in a way, because the way that we solve the problems is that we used to do like a vibe coding. We ask the prompt and then we just hoping it's going to give us the great answer. But it with a lot of these stories from developers that some of them like they come with mistakes along the way. Even like the worst case is that they drop database and everything. I think it forced us to rethink about the current workflow that we have. So instead of like just relying on vibe coding, having this kind of workflow, like a structured workflow, is something that we should do. So we should do like the user stories first, and then we need to advise the implementations and then also the tasks. So I always believe that the magic happens not because of the tools itself, it's because that we as a humans, we have the workflow, and we the generative AI is the magic one. But the real magic is how that we collaborate together. So that's why I think Hero is really a fantastic implementation, like a really fantastic manifestation on what we should do with generative AI. Yeah.
Do you think though, with the fact that you can put rules and constraints around how the AI will export or write its code, that it allows you to vibe code within those constraints still though, like spec service popping up in Kuro and allowing those stories to be generated by you up front to allow it to be more structured in its approach?
Yeah, I do. I do believe on that. Like specifying the guardrails, the steering guidance as well, providing like a proper context is something that we can do on from our end. But the other thing that developers often overlook is the model itself. So I think this model is something that's really valuable and the unique value proposition from all the providers as well. And I've been using QCLI to build most of the demos, and it's been fantastic. And I also use a couple of other tools, but I didn't find this kind of magnificent results. Right. So so I think yeah, the model itself, I mean, in the future, developers will think about what's this model all about, what is the characteristics, and then can we trust them? I think that's something that's really crucial.
Quite interesting you're using QCLI a lot. I am too. I'm sort of forcing myself into that landscape and see how it goes. Hey, Derek, I'm going to throw you a harder one because I know you've been doing a lot with AI though. So beyond the obvious AI ML boom, what's one technology trend that's flying under the radar but gaining real traction?
What is so? It's not a technology trend, right? So what I see that's falling under the radar at the minute, in terms of the whole AI thing, is automation. So there's a lot of people talking about how to automate the process and processes that come with building things with AI. We talked about it quite a lot about a year and a half ago with ML ops. Now, a lot of people are doing similar things with Gen AI models and evaluation and building that into their app pipeline. But it seems to be well, certainly in my world and the people I talk to, it seems to be under the radar. And it's incredibly important because the biggest challenge that we face using AI is productionizing. And so and as we all know, and anybody watching who doesn't know, automating everything is the way to get things to production, because you want to take us, the human element, out of that loop. And so automating the AI application and getting it into production is very important. And we need to maybe bubble up the thoughts and the thought processes and patterns that I'm hearing into the larger domain. I think that's probably under the radar at the minute, and we need to bring it in front of mind.
Yeah, I'd agree with that. There was some decent patterns about a year ago that I saw about the whole, was it the ML ops using code pipeline, et cetera, to submit all your SageMaker processing for your new LLMs, et cetera. It was quite cool. It's really something I'd recommend as well.
Yeah, and it falls very nicely. It's just into what Donnie was saying in his last answer about a model evaluation, because all of these models will behave differently. And if you see what happened last week, where OpenAI launched their new model and then discontinued all of their older models at the same time. So if you're running something in production that relies on a particular version of a particular LLM, you could be screwed. And so how would you do that in a traditional application? Well, your pipeline would tell you, as it tries to build a version for a lower environment, not production. So that's why it's incredibly important.
Sweet. All right, Donnie, throw you another one. What's one tool or practice that was hot 5 years ago that you're seeing developers abandon? Don't say traditional coding.
Well, that's tough questions. Okay, hit me again.
These are hard questions, Paul.
Well, what's the one tool that developers abandon? Come again, Paul?
They're abandoning. So what's one tool or practice that was hot 5 years ago that you're seeing developers abandon?
I don't want to say this, but can I say this? It is. I mean, yeah. So I think it's the methodology. I will not say the tools, but it's the methodology that I believe you all familiar with the waterfall methodology, something like that. All these methodologies, like people seem to abandon it, and I do agree what Derek already mentioned. There's actually like a significant difference between the EU5 code, which is good for prototyping, and then you want to deploy a production grade applications, which is need to have a rigid structure. So that's something that I do think like most of the developers keep on abandoning this, especially all the good practices on the DevOps side, on the CI/CD. We haven't talked about SREs aside, but yeah, on the DevOps side, there's a lot of methodologies like developers think like they just rely on generative AI, and it generates the results. Okay, let's put it on the production apps. So yeah, so that thing is something that I do think that developers keep abandoning the methodology. We need to stick with the structure.
Fair enough. Well, how about we move on to some of your advocacy background? As you've both been with AWS for over 5 years, which is almost ancient in DA years, what's been a standout moment for you both in your time so far? Derek, we'll start with you, eh?
Yeah, sure. Oh, well, I start typing in chat. So Donnie and I, it's funny, Donnie's been at AWS a month longer than I have, and we've both been, we're approaching our eighth year anniversary, and Donnie for the entire 8 years has been a DA. So I am nowhere near the experience of my learned colleague. However, in the 5 years I've been a DA at AWS, the highlight has always been the collaboration I can do with the community and with my fellow DAs. So is what part of our job as DAs, we're very, very blessed to be able to connect with the community, and probably we work the closest with community. People like yourselves, Paul, and everybody in the background who's putting this together, and everybody who's talked today. We have the privilege of working with all of you closely, which makes our job the best job in AWS, because you're all so cool and very authentic, and we really, really love that and appreciate everything you do. And as part of that, we get to nominate and help community builders and heroes. Now, the hero program in particular has a very, very high bar. And so particular highlights for me in the time I've been in developer advocacy is being able to help people become heroes. So there's some fantastic heroes in APJ, and it's been fantastic to see the progression of heroes into the hero program, nothing. So from just getting to know AWS, just getting to understand their background, getting them into the community builders program, nurturing them there, and then seeing them get to hero, because it's incredibly hard to get to hero. So we, like Donny and I, sometimes we just wonder where you get the time to do this, because
For sure.
such a lot of work to do. And so yeah, I'm in awe of every single AWS hero that I know, and a lot of the community builders as well. Just so much work you put into it. So thank you, and it's the best part of my job, without a doubt. Not building cool demos, yeah, whatever. But working with the community is just the best.
Nice one. Donny, what's been a standout moment for you in your time so far?
I would say
Thanks, Derek.
it's the same answers, but for me, it's really personal. Like people think as the DA is something. I mean, we build demos, and I always think that developer advocate we are the bridge, like between developers and in this case it's AWS. So we can relay all the great stuff that you have done. If you have any questions, let us know what kind of help that you need from us. But the most standout moment was when I joined AWS in 2017, and then the next year I organized AWS Community Day. And Community Day ASEAN and APJ, which we invite leaders and developers across APJ to come to Ho Chi Minh in Vietnam. And that was the very moment I realized that actually that community is the pivotal role in all of this space. So, and then the passion that we have, like whenever people wants to talk about microservices, serverless, containers, or observability, this is their passion that bring us them all together, and that's the glue. So I think that's the really like what do you call? For me, it's an awakening call. That community is the heart of my job. So yeah, same answer with Derek as well. But you guys been amazing.
Nice one. So you don't have to answer this, I suppose, but I'll throw it out to either one of you. What's been one of your most embarrassing moments on stage or on the road as a developer advocate?
Tony has one, but I'll go first. We all have them, right? So there's this myth that we rock up on stage because we do it so often and we never make a mistake. That's absolute nonsense, because we all make mistakes.
Those demo gremlins.
Yeah, they happen. They happen. But I think the most embarrassing for me is would be I was in a talk and the Wi-Fi went down, and this is probably why I've sort of steered away from live demos for a while. Yeah, and specifically, because live demos are live demos, because we are cloud advocates, rely on the internet, and so it happened just at the beginning of a talk. You get everybody really excited, and you go yes, and then we'll just dive into the demo, and crickets. So that happens. That's happened a few times, and it's never fun. And
well, it's good to know it happens to the best of us. A few of our speakers today have actually been going hardcore and trying to do it live too, so it's been a bit of fun.
I've taken the easy way out recently and just recorded a couple of days before. So I'm checking it out. Yeah. I've lost my edge. Donny, you have some great ones.
Well, that's a great advice, but I'm really stubborn. I'm still doing live demos, but the fact is that I've been traumatized by live demo as well. So at the AWS Innovate closing keynote, I had run like a 10 minutes to do the live demos, along with our magnificent Chris Howard and also Dean Samuels. And like 3 minutes before my second, which is the live demo on showing the CloudFront and also the Snowball Age, my laptops crashed. Like totally crashed. It's totally crazy. So it was amazing. It wasn't about the Wi-Fi. It was about the laptop. It was crashed. And then, so obviously I didn't make it in time, but I tried to make everything as I'll get back online as soon as possible. So they went through the Q&A, Dean and also Chris, and then I gave like a signal to them, like my laptop is ready now. Let's do the demo. So I was like, and then yeah, so we went back to my demos, and yeah, I've done all the demos, but yeah, that is one of the most embarrassing moments. Laptop was crashed.
And Paul,
That would be pretty hard.
I'd just like to add, Paul, rather than this would, for me, it would put me off running, I think it was an IoT demo. It would put me off running an IoT demo for life, right? And so we just did the Builders Online session last week. Was it last week? And so Donnie's idea for a demo, IoT. I'm like, you're mad, absolutely mad.
It's fun. It's fun until it's crashed.
Yeah, and I guess a remote wireless access point on your iPhone doesn't help either.
No.
All right. Cool. Thank you. So here's another one for you. What's one area where you think AWS still has room to improve in terms of the developer experience?
Yeah. Do you want to take this one? I have some ideas.
You go first.
Okay. So I think what we're missing, and this is conversations that obviously we have internally a lot, is a single point of entry for developers. So we have a lot of great information, we have a lot of great demos, we have a lot of great blogs and all over the place. And so what we really need is a central pane of glass over these, so that we have a single point of contact, or a single point where we engage developers. That would make it easy for us, and it would make it easier for all the developers out there. So I think that's what AWS Builder Center is going to be. That single point to engage, not for developers, for community members, even at some stage, hopefully, we get to trying some of the services as well via going into Builder Center. You're seeing at the minute Builder Center logins for Kiro, Builder Center logins for QDev. So that single point, that's something that we've always been missing, and it's something we're working really hard to improve.
So it's kind of an interesting segue then into another question I had, which was about what kind of piece of advice would you give someone early in their career, or even someone senior, wondering about their next steps, about what to learn and what they should be doing, and getting involved in either the community or with tooling. So in this fast-paced landscape, how can we keep pace with the changes? Donnie.
That's me. Okay. So
go on.
So 2 weeks ago, I went the AWS Community Day in Singapore, and and Farah Campbell delivered her keynote, and she gave a really amazing advice. Now, the funny thing about career is that it's not predefined. It's that something that you need to build, right? And then my advice to all developers is like build, start building, start getting your hands dirty with all of the things that you probably want to, or you probably didn't want to before. If you want to learn about microservices, learn about communications, learn about asynchronous. If you want to learn about containers, try first AWS App Runner or Amazon ECS. Or you probably want to run your Lambda functions with container image as well with Lambda Web Adapter. So build stuff, build things, document them, and share with community. I think that is the best things that you can do at the moment. Especially we have a really vibrant community. Like now we are the AWS Community Day, where all the amazing speakers join and then help the developers. So yeah, build stuff. Don't hesitate to get your hands dirty. Ask for help from us from AWS side, or ask from community side. We have heroes, community builders are ready to help you. Document, share, and participate in all these community activities.
Yeah, speaking of which, I think we've got only maybe a couple of minutes left at most. So if both of you guys are doing keynotes at community days, one in Wellington and one in Brisbane. So if you can give us a sneak peek into what you're talking about, and maybe also how do you prepare for a keynote, any rituals you do, and what you're personally hoping people might take away from your talks. Derek, go with you. Yeah.
Well, I'm doing Brisbane with Mike, who did the keynote for today, and so the prep is this actually. So,
so you're reaching for the whiskey bottle just then.
Yeah, well, so when I take the stage with Mike, I like to come armed because he can talk a lot. So I use this sword to stop him from talking. No. So yes, so we prep for Community Day. We're doing a talk very similar to what Mike did at the start, but it'll come with a different character, which will be me, and I will be playing the character of someone who doesn't really understand or get Gen AI. So is really glass half empty kind of person. And we'll talk through, the challenges of using the Gen AI as technology, how to improve what you're currently doing, and of course, Mike will give his excellent view on how to get better and improve your awareness and knowledge of the technology as a whole. So that'll be the keynote. Well, lock note actually of Community Day in Brisbane, and I know for a fact that Mike will have an equivalent to my Minecraft sword just to defend himself.
He has a shield.
It's got a shield.
He has a pickaxe.
Di, how about you?
Yes.
Any ritual that you've got, or any key takeaways from your speech that you might want to?
Oh, okay. So I'm planning to do something that's for me is kind of bit cool. Is the feature of microservices. I don't have any terms for this. I haven't seen anything about this, but I'm gonna say it's agentic microservices. So so this is something that I'm gonna deliver at the AWS Community Day closing keynote in Autoria, and then the way that I prepare is just like it's super easy. Demos first, slides later. So define the storylines, demos, and then slides. If we don't have any slides, that's okay, but we need to have demos. So I think that is my key takeaways. Hopefully that most of the developers will understand the feature of microservices if it's right, if it works as well.
Nice one. Right, guys, I think we're at time. So thanks so much to you both for all your amazing insights. It's been a lot of fun hearing about all your views and your wisdom. So good luck on your keynotes and the community days and developer advocacy that you do in future. It's been an absolute pleasure talking to you both. And thanks to everyone for watching. So we hope you found the conversation insightful and that you'll be able to navigate the developer community more effectively in the future. So thanks very much. Our final keynote speaker will be for the next slot up. So stay tuned. See you later, guys.
Thank you, everyone.
Yeah.
Hi everyone, my name is Shafraz Rahim. I'm a senior program manager focusing on developer communities in Asia Pacific, Japan, and China region. And thank you very much for joining my last talk today at the AWS Community Day out here, Oceania version, I would say, for joining with us. Thank you very much. It's been a long day, and then I'm pretty sure the team behind this is also looking forward to this keynote and then end in a high note. So today, my topic is going to be around developer trends and the importance of community. Because I am very close to the community, which is near and dear to my heart. At the same time, I'm a developer by heart, so I wanted to mix both together in my final talk. It was 2012 when I was in my second year of university when I first joined a developer meetup. Back then, augmented reality, virtual reality was the trend. Unlike AI nowadays, it was those two. I still remember in one talk, in one of those meetups that I attended, one of the speaker was giving a talk, and he showed how to build a .NET desktop application that can read your mood, show weightages, and he later showed how to add a filter to the face as well. So it was pretty amazing, pretty mind blowing. It was pretty common now to have such features in apps like Facebook, WhatsApp, Snapchat. But in 2012, augmented reality can get you speak for about 1 month or even more than that. It was the talk of the town. That night, right after the meetup, I was full of inspiration, lot of passion, and I wanted to go back home and try it out. Um, since I wanted to try this out, I didn't actually plan out anything. I was like, let me open up my NetBeans, download OpenCV, and try to build the same thing that the speaker was also a speaker built as well. And I failed miserably over and over and over again. It was a complete disaster. I didn't know what to do. I felt lost at that moment. I still remember. I'll never forget that feeling. And now I can't sleep as well at night because I want to solve this somehow. So I tried searching for answers in the internet. I started posting up in Stack Overflow, and I was trying to find a solution for this. I was tired, but the fire in me kept going. So is coffee. By next morning, I couldn't get it working. Still not working. So I reached out to the speaker to get an advice. He was very open to help out, and somehow we managed to build the demo finally. um, Later I extended it to become an Android app as a restaurant finder. When you open the app, the camera view opens up, and it also calls the Google Maps API, and it showcases like an overlay on top, showcasing when you point your camera, it shows where the restaurant is in a very interactive and in augmented reality way. So that was like pretty amazing for a kid who is in second year learning how to code. It was like pretty amazing. There are hundreds of apps just like that, but if you wasn't for the help that I got from these like-minded people, I would have given up easily. This is why I love tech communities. Developers getting together, sharing new ideas, solving problems, asking you for help, and more. Since then, I've been very passionate about communities. This is my story, and I'm pretty sure even your story can be this, or even thousands of other developers' stories can be this, or maybe this is how we all got started too. So it actually sets the stage for what I have to tell you in this in my talk. Um, I I am very fortunate enough to work with thousands of developers across Asia Pacific region, and one thing that I'm noticing in this region is that there's an increase in appetite for cross-border collaborations. What I mean by that is developers of a country are very likely to learn from developers of another country. or to collaborate on a project. This is not something new. This is not something, uh, wow, this is pretty cool, pretty new. This is not new. It has been there for a long time. But the thing is, it's trending upwards, be it in a digital setting or in person. Advancement in digital technologies and cost of travel are becoming cheaper compared to a decade ago is making this behavior very possible. The results of this is developers are becoming more resilient or challenges they face because the support structure is growing. For an example, I'm seeing this happening very commonly in AWS Community Builders program and then the Slack channel right over there, where if someone from Sri Lanka is stuck in a technical problem, and even if an AI cannot resolve it, they will reach out to someone in New Zealand or even someone in Korea for help. This happens pretty organically. Josh Pancration, an annual 24-hour virtual event, is a very good example of this. They invite speakers around the world to present in their own language, but it also gets translated in real time to Japanese, so Japanese developers can learn from the rest of the world. Now you're attending one of those similar events that the AWS user groups in Aotearoa is organizing, which is Oceanic, where you have invited lots of developers across the world to speak at this event. Cross-border collaboration increasingly is moving upwards despite our regional challenges, be it language challenges, be it the gap between the experiences, it's all getting diminished at this point. Secondly, the landscape of programming language is changing. Stack Overflow developer survey results came out a few months ago, and 84% of the respondents are using or planning to use an AI tool in their development process. An increasing that's an increase from last year, about 76%. This year, we can see 51% of professional developers are using AI tools daily. Not only for professional developers, but also for um, student developers as well. For an example, recently we ran a developer learning campaign called Build Games with Amazon QCLI, which actually came as a result of Derek Bingham, who's our ANG developer advocates blog. So in this particular campaign, what we encourage developers to do is that to build a game using Amazon QCLI, and to sort of interact with the QCLI tool with using natural language. Andre Karpathy, who's the ex-director of AI at Tesla, a computer scientist and potentially the person who coined the term vibe coding, says the software development will happen through natural language prompts, making it the new programming language. Tools like Kiro, Amazon Q Developer, Amazon Q CLI are helping developers to move from this whole paradigm shift of vibe coding to be more spec driven development and to be intentional about how you use natural language in software development. If you heard your professor say to learn a programming language a decade ago, guess what? Learning to master effectively writing or even prompting using natural language is going to be useful in the future. Now, another sort of area of uh, development that we are also seeing in terms of mm, um, evolution of programming language is that not only these uh, these these tools or maybe natural language are being used in I would say half of the time, and also at the same time another half of the time developers would prefer to actually write codes. So it's actually moving towards like a mix of how the developers are approaching these programming languages. But in the future, most probably, it's going to be uh, we use our own languages to do coding. And thirdly, there's a strong positive correlation between a country's GDP and internet penetration. As a country's GDP increases, the internet penetration rate tends to increase as well. This relationship often seen as a virtuous cycle, where increased internet access drives economic growth, and economic growth in turn facilitates greater internet adoption. And we are seeing this across our part of the world, which is APAC. So I was in Vietnam a couple of weeks ago, attending AWS Community Day. About over 400 attendees, and most of the developers I spoke to were less than 30 years old, but they had progressed in their careers to become lead developers, heads of engineering, and many other senior positions as well. They started early. That was enabled through one key contributing factor, which is the country's higher internet penetration. That's enabling these young people to start off doing coding, doing programming at a very early stage. It not only enables one person to learn self learn, but also to collaboratively learn as well. One of the initiatives that we saw in Vietnam is that there's something called the first cloud journey, which is sort of a mix of AWS and then community collaboration, where you would find these individual young people coming and enrolling themselves to this program, and then they build materials by themselves. They learn from a source, and then they build their own materials. They build their own materials in their own language, which is Vietnamese. And then the future generation are also encouraged to do the same. And at the same time, they encourage through this program for people to get hired. Once they get hired, they also create another layer of future developers as well. So it happens as a very cyclical way, was amazing to see. Not only in Vietnam, but we are also seeing this happening in places like in Indonesia, places like in Korea. So these type of engagements are being made possible through higher penetration of internet. So finally, if you look at everything that I discussed, there's an increased degree of developers valuing a considerable level of human interactions, despite AI being able to help us in many ways to be productive, to help out move our legacy code, to modernization, to build like really cool apps within few seconds or few minutes. It's helping us in many ways. But the thing is, developers are actually now looking forward for ways to collaborate in maybe in person, some way or the other, in person or even virtually with another human being. Humans are social animals that thrive through discussions, collaborations, and calibrated learning. And if you ask me, I see communities are becoming increasingly important in this fast-paced world. Not only to learn, but to push, not only to learn from each other, but also to push ourselves to build a thriving world. So, and finally, I also want to mention, if you are someone who's not yet a part of AWS communities are growing. AWS communities has different aspects as well. Now, this particular event was put together by the AWS user groups in Aotearoa, coming together, collaborating, and hosting a meetup that can help to thrive other developers also within the region. So we have the AWS user group program. Along with this AWS user group program that enables peer-to-peer learning, there are individuals behind this who are helping out as well. For an example, we have AWS Community Builders, um, which has like a massive network around the world who are helping out behind the scenes as well. We have AWS Cloud Club leaders. That's for university students who are passionate about cloud technologies, who have joined this program, are also helping out behind the scenes. And also AWS Heroes, who are helping out this who are helping out this activity or the event as well. So that means a lot of collaboration, a lot of people are coming together, a lot of communities are coming together to make this event possible. So I hope you were able to learn something new through this talk, and I'm very hopeful and very positive that the changes that's happening in the developer landscape is going to help us benefit in the long term. Um, I'm very much looking forward to what the developers in Asia Pacific, Japan, and China region are able to work towards as collaboratively as communities, as developers who are very eager to help out each other. I'm very much looking forward to see what all of us can come together and build for this region. So with that, I would like to conclude my session, and thank you very much who tuned in for AWS Community Day Oceania, the very first edition, throughout this 8 to 10 hours of period, which is not an easy task. And I would like to thank all the organizers of this event, the speakers, the volunteers, everyone who got involved to make this event possible, including Mike behind the scene, who's helping out to organize to put this virtual setup together. And of course, to Derek Bingham, who's the Australian New Zealand developer advocate, for helping out these communities to thrive. So with that, I would like to conclude my talk, and thank you very much for joining, and hope to see you in person at an event. Thank you.
And I even cried a little bit. But that's only because I have some issues. Anyways, the AWS user group Aotearoa would like to thank the sponsors for their fantastic support. And also the speakers listed in the credits just over there. You've been amazing. And of course, we'd like
Thanks
to
for
thank
that.
you.
That was awesome.
You, our
We're
audience,
just ending the
wherever
stream
you
up now.
are in the world, you have been wonderful. Thank you for joining in on our very first
It was quite
virtual
encouraging.
event.
So thanks.
Speaking of events, we have
Wonder if
two
I could
events
put
coming up in the
AWS
next month
Community Builder
and a
on my
half
LinkedIn now.
here in Oceania,
Who knows?
and these ones are in person. So the first one coming up really soon is the AWS Community Day 2025 Australia. That is coming up on the 15th of August, so 5 days from now, and that is at the Brisbane Convention and Exhibition Centre. To find out more and register attendance, head to awscommunitydayAUS.com. That's all one word. I'll repeat it again, AWS Community Day AUS.com. And, of course, the AWS user group Aotearoa has one too. So join us in person for networking, hands-on workshops, and face-to-face interactions. That is happening on the 18th of September, and it's going to be at Tākina Events in Wellington, at 50 Cable Street there in Wellington. To find out more information, register your attendance. You can do that at aws-community-day.nz. I'll repeat that again, aws-community-day.nz. The links below for both are in the description. Also, don't forget, follow us, the AWS user group Aotearoa, on LinkedIn for upcoming events, and maybe you too can join in on one of these events. put something aside. Give it a go. Anyways, I opened this day with a karakia, so now I have to close with one. Thanks for joining with me. Tui, 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 I ronga, unite above. Tui, 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 I raro, unite below. Tui, 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 I roto, unite within. Tui, 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 I waho, unite without. Tui, te here tangata I te ao, unite the bond of humanity in this world. Ka rongo te po, listen to the night. Ka rongo te ao, listen to the world. Ti hei mauri ora. Share with me now the breath of life. Kia ora. Thanks for watching. We'll catch you next time.